Recording in progress.
Our world faces challenges that no one imagined. We only have one planet. To make critical decisions for its future, we must first understand it. Working together with customers in over 100 countries, we create the Earth modeling, geodata management, and collaboration software that connects science, people, and the planet. Because when everyone sees the bigger picture, they can make faster, more sustainable decisions with less risk to humanity and the environment. Across the civil, environmental, mining, and energy industries, professionals use Sequence software to integrate their teams and data to build Earth models that better reflect reality and can evolve with changes, turning complexity into clarity. Every day, they're changing the world. We're here to help them. A better understanding of the Earth creates a better world for all.
PT Timah Tbk merupakan salah satu perusahaan penghasil logam timah terbesar di dunia. Perusahaan ini berkantor pusat di Kota Pangkal Pinang, Provinsi Kepulauan Bangka Belitung, Indonesia. Wilayah operasi PT Timah meliputi Provinsi Kepulauan Bangka Belitung dan Provinsi Kepulauan Riau yang dikenal sebagai Indonesian Tin Belt. PT Timah memiliki visi menjadi perusahaan pertambangan terkemuka di dunia yang ramah lingkungan. Dengan misi membangun sumber daya manusia yang tangguh, unggul, dan bermartabat, melaksanakan tata kelola penambangan yang baik dan benar, mengoptimalkan nilai perusahaan dan kontribusi terhadap pemegang saham, serta tanggung jawab sosial. Sejak tahun 1995, PT Timah telah tercatat di Bursa Efek Indonesia. Pada tanggal 29 November 2017, PT Timah bersama PT Aneka Tambang PT Bukit Asam dan PT Freeport Indonesia resmi tercatat sebagai anggota holding industri pertambangan MGEI di bawah naungan PT Indonesia Asahan Aluminium atau Inalum. Sebanyak 65% kepemilikan saham PT Timah dimiliki pemerintah melalui PT Inalum dan 35% oleh publik. PT Timah merupakan perusahaan penambangan yang terintegrasi, mulai dari eksplorasi, penambangan, pengolahan, smelter, hingga pemasaran. Penambangan di darat di wilayah izin usaha pertambangan timah berlokasi di Pulau Bangka dan Belitung. Sedangkan penambangan timah di laut menggunakan kapal keruk dan kapal isap produksi. Sebelum dilebur, biji timah hasil tambang diproses di pusat pencucian biji timah. Setelah dipisahkan dari mineral ikutan, kadar SN ditingkatkan hingga mencapai syarat utama peleburan. Untuk mendapatkan logam timah berkualitas tinggi, maka dilakukan pemurnian. Prosesnya memakai crystallizer dan electrolytic refining. Proses peleburan dilakukan di Muntok, Bangka Barat, dan di Kundur, Kepulauan Riau. Saat ini dikembangkan proyek fuming dan ausmelt untuk mendukung operasional peleburan. Jenis logam timah yang diproduksi PT Timah yakni Bangka Tin, Mentok Tin, Kundur Tin, Bangka Lowlit, dan Bangka 49. Merek dagang Bangka Tin dan Kundur Tin terdaftar di London Metal Exchange dan bersertifikasi CFS dari RMI. Negara tujuan ekspor antara lain Jepang, Korea, Taiwan, Cina, Singapura, Belanda, Jerman, Prancis, Spanyol, Italia, serta wilayah Amerika Serikat dan Kanada. Kegiatan usaha PT Timah Tbk ditunjang beberapa anak perusahaan, yakni PT Timah Industri, PT Timah Investasi Mineral, Timah International Investment, PT Dok dan Perkapalan Air Kantung, Indometal London Limited, PT Timah Karya Properti Persada, PT Timah Agro Manunggal, PT Tanjung Alam Jaya. Guna menjaga eksistensi perusahaan, dicanangkan 4 pilar utama rencana pengembangan perusahaan yang mencakup pilar 1, mempertahankan dan memperkuat bisnis pertambangan timah perusahaan dengan melakukan peningkatan jumlah cadangan dan produksi. Pilar 2, pengembangan bisnis pertambangan non-timah dengan fokus pada mineral ikutan timah. Pilar 3, pengembangan bisnis hilir timah secara agresif dengan menguasai pasar domestik dan menembus pasar global. Pilar 4, pengembangan bisnis selektif, fokus pada bisnis yang memberikan keuntungan kompetitif pada grup PT Timah. Sebagai salah satu faktor penting keberlanjutan perusahaan, PT Timah terus mengembangkan SDM berbasis karakter unggul dalam kinerja maupun perilaku. Hasil kerja keras semua pihak ini membuahkan penghargaan dari berbagai lembaga, baik dari dalam maupun luar negeri. Sebagai entitas di tengah masyarakat, PT Timah mempunyai program tanggung jawab di bidang sarana, pendidikan, usaha mikro, sosial, dan pelestarian lingkungan. PT Timah Tbk, perusahaan pertambangan terkemuka di dunia yang ramah lingkungan.
Nikel telah menjadi bagian penting dalam perkembangan peradaban dunia. Berbagai produk yang menunjang kehidupan manusia saat ini tak lepas dari kandungan nikel di dalamnya. Dan Indonesia adalah negara dengan sumber daya nikel terbesar di dunia, khususnya di Sulawesi dan Maluku Utara. Pulau Obi yang terletak di Kabupaten Halmahera Selatan, Provinsi Maluku Utara, menjadi salah satu daerah penghasil nikel. Sejak tahun 2009, Harita Nikel telah mengelola sumber daya alam nikel dan memberi berbagai manfaat dan kontribusi bagi para pemangku kepentingan. melalui entitas bisnis Tri Megah Bangun Persada, Gani Permai Sentosa, Megah Surya Pertiwi, Halmahera Persada Legend, dan Halmahera Jaya Ferronikel, Harita Nikel melakukan aktivitas penambangan, pengolahan biji nikel kadar tinggi, dan pemurnian nikel kadar rendah di wilayah operasi yang sama di Pulau Obi. Dengan berbagai entitas bisnis tersebut, saat ini ada lebih dari 5.000 tenaga kerja dan 70% lebih berasal dari wilayah lokal. Sebagai bentuk komitmen mendukung cita-cita bangsa dalam mewujudkan hilirisasi sumber daya alam, Harita Nikel melalui Megah Surya Pertiwi telah mengolah biji nikel kadar tinggi atau saprolit menjadi ferronikel sejak tahun 2016. Ferronikel banyak digunakan sebagai bahan baku industri logam karena bersifat anti karat. Komitmen Harita Nikel akan hilirisasi terus berlanjut. Melalui Halmahera Persada Legend, Harita Nikel mengembangkan industri pengolahan dan pemurnian nikel kadar rendah menjadi produk yang lebih bernilai, yakni mixed hydroxide precipitate, dan diproses lebih lanjut menjadi nikel sulfat dan kobalt sulfat. Produk-produk tersebut merupakan bahan baku utama baterai kendaraan listrik. Keberadaan industri ini merupakan wujud komitmen perusahaan dalam konservasi mineral dan mampu menciptakan tenaga kerja bagi anak bangsa dan terjadinya alih ilmu pengetahuan dan teknologi. Penerapan teknologi high pressure acid leach menjadikan Harita Nikel sebagai pionir dalam mendukung terwujudnya program pemerintah dalam percepatan program kendaraan bermotor listrik berbasis baterai karena mampu memanfaatkan biji nikel kadar rendah atau limonit yang selama ini tidak diolah. Di Harita Nikel, seluruh proses pertambangan hingga hilirisasi dijalankan dengan tata kelola pertambangan terbaik. Kesehatan dan keselamatan kerja menjadi komitmen utama dalam menjalankan operasional sehari-hari. Program pemantauan lingkungan dilakukan dengan mengacu pada aturan pemerintah, termasuk melibatkan pihak akademisi dan lembaga independen dalam pelaksanaannya. Secara reguler, perusahaan melaporkan hasil pemantauan lingkungan kepada pemerintah. Harita Nikel juga memiliki fasilitas pembibitan tanaman mandiri untuk menunjang aktivitas reklamasi. Kegiatan reklamasi telah dilakukan tanpa menunggu operasional selesai. Perusahaan juga mengelola sisa tanah olahan atau produk samping berupa slag nikel menjadi produk bermanfaat. Dengan izin pemanfaatan dari pemerintah, slag nikel dan abu hasil pembakaran batubara diproses menjadi material bahan bangunan yang kokoh dan berkualitas tinggi, yaitu bata beton. Produk ini telah dimanfaatkan secara optimal dalam pembangunan pondasi berbagai fasilitas perusahaan. Melalui kerjasama dengan pemerintah setempat, Harita Nikel juga berkomitmen dalam pengembangan dan pemberdayaan masyarakat. Berbagai program terus dilakukan untuk mewujudkan cita-cita bersama, yakni menjadikan masyarakat setempat mandiri. Seluruh program mengacu pada 5 pilar, yaitu infrastruktur, pengembangan ekonomi, pendidikan, kesehatan, dan sosial budaya. Dengan dukungan dari seluruh pemangku kepentingan, Harita Nikel berkomitmen untuk senantiasa mengoptimalkan sumber daya alam Indonesia bagi kemandirian bangsa, serta kontribusi terhadap pembangunan dan kemajuan ekonomi daerah maupun negara. Dari Obi untuk Indonesia.
Our world faces challenges that no one imagined. We only have one planet. To make critical decisions for its future, we must first understand it. Working together with customers in over 100 countries, we create the Earth modeling, geodata management, and collaboration software that connects science, people, and the planet. Because when everyone sees the bigger picture, they can make faster, more sustainable decisions with less risk to humanity and the environment. Across the civil, environmental, mining, and energy industries, professionals use Sequence software to integrate their teams and data to build Earth models that better reflect reality and can evolve with changes, turning complexity into clarity. Every day, they're changing the world. We're here to help them. A better understanding of the Earth creates a better world for all.
PT Timah Tbk merupakan salah satu perusahaan penghasil logam timah terbesar di dunia. Perusahaan ini berkantor pusat di Kota Pangkal Pinang, Provinsi Kepulauan Bangka Belitung, Indonesia. Wilayah operasi PT Timah meliputi Provinsi Kepulauan Bangka Belitung dan Provinsi Kepulauan Riau yang dikenal sebagai Indonesian Tin Belt. PT Timah memiliki visi menjadi perusahaan pertambangan terkemuka di dunia yang ramah lingkungan. Dengan misi membangun sumber daya manusia yang tangguh, unggul, dan bermartabat, melaksanakan tata kelola penambangan yang baik dan benar, mengoptimalkan nilai perusahaan dan kontribusi terhadap pemegang saham, serta tanggung jawab sosial. Sejak tahun 1995, PT Timah telah tercatat di Bursa Efek Indonesia. Pada tanggal 29 November 2017, PT Timah bersama PT Aneka Tambang PT Bukit Asam dan PT Freeport Indonesia resmi tercatat sebagai anggota holding industri pertambangan Main ID di bawah naungan PT Indonesia Asahan Aluminium atau Inalum. Sebanyak 65% kepemilikan saham PT Timah dimiliki pemerintah melalui PT Inalum dan 35% oleh publik. PT Timah merupakan perusahaan penambangan yang terintegrasi, mulai dari eksplorasi, penambangan, pengolahan, smelter, hingga pemasaran. Penambangan di darat di wilayah izin usaha pertambangan timah berlokasi di Pulau Bangka dan Belitung. Sedangkan penambangan timah di laut menggunakan kapal keruk dan kapal isap produksi. Sebelum dilebur, biji timah hasil tambang diproses di pusat pencucian biji timah. Setelah dipisahkan dari mineral ikutan, kadar SN ditingkatkan hingga mencapai syarat utama peleburan. Untuk mendapatkan logam timah berkualitas tinggi, maka dilakukan pemurnian. Prosesnya memakai crystallizer dan electrolytic refining. Proses peleburan dilakukan di Muntok, Bangka Barat, dan di Kundur, Kepulauan Riau. Saat ini dikembangkan proyek fuming dan ausmelt untuk mendukung operasional peleburan. Jenis logam timah yang diproduksi PT Timah yakni Bangka Tin, Mentok Tin, Kundur Tin, Bangka Lowlit, dan Bangka 49. Merek dagang Bangka Tin dan Kundur Tin terdaftar di London Metal Exchange dan bersertifikasi CFS dari RMI. Negara tujuan ekspor antara lain Jepang, Korea, Taiwan, Cina, Singapura, Belanda, Jerman, Prancis, Spanyol, Italia, serta wilayah Amerika Serikat dan Kanada. Kegiatan usaha PT Timah Tbk ditunjang beberapa anak perusahaan, yakni PT Timah Industri, PT Timah Investasi Mineral, Timah International Investment, PT Dok dan Perkapalan Air Kantung, Indometal London Limited, PT Timah Karya Properti Persada, PT Timah Agro Manunggal, PT Tanjung Alam Jaya. Guna menjaga eksistensi perusahaan, dicanangkan 4 pilar utama rencana pengembangan perusahaan yang mencakup pilar 1, mempertahankan dan memperkuat bisnis pertambangan timah perusahaan dengan melakukan peningkatan jumlah cadangan dan produksi. Pilar 2, pengembangan bisnis pertambangan non-timah dengan fokus pada mineral ikutan timah. Pilar 3, pengembangan bisnis hilir timah secara agresif dengan menguasai pasar domestik dan menembus pasar global. Pilar 4, pengembangan bisnis selektif, fokus pada bisnis yang memberikan keuntungan kompetitif pada grup PT Timah. Sebagai salah satu faktor penting keberlanjutan perusahaan, PT Timah terus mengembangkan SDM berbasis karakter unggul dalam kinerja maupun perilaku. Hasil kerja keras semua pihak ini membuahkan penghargaan dari berbagai lembaga, baik dari dalam maupun luar negeri. Sebagai entitas di tengah masyarakat, PT Timah mempunyai program tanggung jawab di bidang sarana, pendidikan, usaha mikro, sosial, dan pelestarian lingkungan. PT Timah Tbk, perusahaan pertambangan terkemuka di dunia yang ramah lingkungan.
Nikel telah menjadi bagian penting dalam perkembangan peradaban dunia. Berbagai produk yang menunjang kehidupan manusia saat ini tak lepas dari kandungan nikel di dalamnya. Dan Indonesia adalah negara dengan sumber daya nikel terbesar di dunia, khususnya di Sulawesi dan Maluku Utara. Pulau Obi yang terletak di Kabupaten Halmahera Selatan, Provinsi Maluku Utara, menjadi salah satu daerah penghasil nikel. Sejak tahun 2009, Harita Nikel telah mengelola sumber daya alam nikel dan memberi berbagai manfaat dan kontribusi bagi para pemangku kepentingan. Melalui entitas bisnis Tri Megah Bangun Persada, Gani Permai Sentosa, Megah Surya Pertiwi, Halmahera Persada Legend, dan Halmahera Jaya Ferronikel, Harita Nikel melakukan aktivitas penambangan, pengolahan biji nikel kadar tinggi, dan pemurnian nikel kadar rendah di wilayah operasi yang sama di Pulau Obi. Dengan berbagai entitas bisnis tersebut, saat ini ada lebih dari 5.000 tenaga kerja dan 70% lebih berasal dari wilayah lokal. Sebagai bentuk komitmen mendukung cita-cita bangsa dalam mewujudkan hilirisasi sumber daya alam, Harita Nikel melalui Megah Surya Pertiwi telah mengolah biji nikel kadar tinggi atau saprolit menjadi ferronikel sejak tahun 2016. Ferronikel banyak digunakan sebagai bahan baku industri logam karena bersifat anti karat. Komitmen Harita Nikel akan hilirisasi terus berlanjut. Melalui Halmahera Persada Legend, Harita Nikel mengembangkan industri pengolahan dan pemurnian nikel kadar rendah menjadi produk yang lebih bernilai, yakni mixed hydroxide precipitate, dan diproses lebih lanjut menjadi nikel sulfat dan kobalt sulfat. Produk-produk tersebut merupakan bahan baku utama baterai kendaraan listrik. Keberadaan industri ini merupakan wujud komitmen perusahaan dalam konservasi mineral dan mampu menciptakan tenaga kerja bagi anak bangsa dan terjadinya alih ilmu pengetahuan dan teknologi. Penerapan teknologi high pressure acid leach menjadikan Harita Nikel sebagai pionir dalam mendukung terwujudnya program pemerintah dalam percepatan program kendaraan bermotor listrik berbasis baterai karena mampu memanfaatkan biji nikel kadar rendah atau limonit yang selama ini tidak diolah. Di Harita Nikel, seluruh proses pertambangan hingga hilirisasi dijalankan dengan tata kelola pertambangan terbaik. Kesehatan dan keselamatan kerja menjadi komitmen utama dalam menjalankan operasional sehari-hari. Program pemantauan lingkungan dilakukan dengan mengacu pada aturan pemerintah, termasuk melibatkan pihak akademisi dan lembaga independen dalam pelaksanaannya. Secara reguler, perusahaan melaporkan hasil pemantauan lingkungan kepada pemerintah. Harita Nikel juga memiliki fasilitas pembibitan tanaman mandiri untuk menunjang aktivitas reklamasi. Kegiatan reklamasi telah dilakukan tanpa menunggu operasional selesai. Perusahaan juga mengelola sisa tanah olahan atau produk samping berupa slag nikel menjadi produk bermanfaat. Dengan izin pemanfaatan dari pemerintah, slag nikel dan abu hasil pembakaran batubara diproses menjadi material bahan bangunan yang kokoh dan berkualitas tinggi, yaitu bata beton. Produk ini telah dimanfaatkan secara optimal dalam pembangunan pondasi berbagai fasilitas perusahaan. Melalui kerjasama dengan pemerintah setempat, Harita Nikel juga berkomitmen dalam pengembangan dan pemberdayaan masyarakat. Berbagai program terus dilakukan untuk mewujudkan cita-cita bersama, yakni menjadikan masyarakat setempat mandiri. Seluruh program mengacu pada 5 pilar, yaitu infrastruktur, pengembangan ekonomi, pendidikan, kesehatan, dan sosial budaya. Dengan dukungan dari seluruh pemangku kepentingan, Harita Nikel berkomitmen untuk senantiasa mengoptimalkan sumber daya alam Indonesia bagi kemandirian bangsa, serta kontribusi terhadap pembangunan dan kemajuan ekonomi daerah maupun negara. Dari OBI untuk Indonesia.
Ladies and gentlemen, the session will start in 5 minutes. Thank you.
We are PT Agincourt Resources, a world-class gold mining company based in Indonesia. We manage the Martabak Gold Mine, located in the South Tapanuli District, North Sumatra. Our vision is to develop a sustainable world-class operation, delivering first quartile performance in the gold industry. We will achieve this by growing our business and optimizing our assets, all of which is built on our strong foundation of sustainable development. We are pursuing exciting growth opportunities through exploration, the sulfide development project, and plant debottlenecking to 6 million tons per annum. We have invested in a successful exploration program to deliver significant growth and value to the business. We have 6 deposits in reserves category and a vast mineral resource which we continue to develop. Our project pipeline includes an impressive portfolio of projects across a range of near-mine and contract of work targets. The focus is on near-mine exploration targets to utilize the existing infrastructure of the Martabak process plant. The Sulfide Development Project presents an opportunity to change the game at Martabak, enabling the processing of refractory ore and upgrading the recovery of precious metals from transitional ore. The project upside could potentially double the life of the mine. Our short-term opportunity is to further enhance asset performance by debottlenecking the process plant from its original design to 6 million tons per annum. We can do this with incremental capital investment and drive efficiency and costs even further. Production at Martabak is operating above design and ahead of plan as we are driven by opportunities for efficiency and asset performance. We are delivering in excess of 350,000 ounces of gold and 2.5 to 3 million ounces of silver per annum, all within first quartile cost comparisons worldwide. The foundation of our business is our belief in sustainable development. We believe that mines should be developed, operated, and closed in a socially and environmentally responsible way. In terms of our local community, we deliver practical outcomes, such as employment and capacity building, where more than 70% of our workforce are local people. And our CSR programs, which focus on health, education, infrastructure, agriculture, and economic development.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. A very warm welcome to the second day of the 13th MGEI Annual Convention. This year's theme, Accelerating Perpetual Endeavor Towards Sustainable Mineral and Coal Resources. The future starts today. First, let us all pray according to our own personal beliefs. May this year's convention be beneficial and that we are all safe and healthy. Prayer starts. Prayer finish. Ladies and gentlemen, my name is Rahma Marsha. I'm a graduate geologist from Universitas Indonesia, and it is my honor to be your Master of Ceremonies today. Before we begin today's sessions, please give us your attention as we bring you through this safety procedure. 1. Make sure that you are safe and comfortable and not participating in activities that can harm you during this convention. 2. Please locate any emergency exits should there be any natural disasters or any other hazards. 3. Please sit with the correct seating position. Your back should be straight and your shoulders back. 4. Make sure all electric cables and devices are safe from any hazards. 5. Make sure your internet connection is secure and well connected for maximum experiences. 6. Make sure to rest your eyes once in a while or use anti-radiation glasses to help your eyes not get tired. And last but not least, make sure to keep your mask on all throughout this convention should you be in any public spaces. This year's convention would not have been possible without the generous support from our sponsors and media partners. Starting from our Superbite sponsors, we have PT Geofix Indonesia, PT Merdeka Copper Gold Tbk, and PT Petrosi Tbk. Our Gigabyte sponsor, we have PT Antam Tbk. Our Megabyte sponsors, we have PT Agincourt Resources, PT Aman Mineral Nusa Tenggara, PT J Resources Nusantara, PT Namsuma Luban Abadi Sumacorp, PT Reka Buana Penjuru Mineral, and PT Sumbawa Timur Mining. Our Kilobyte sponsors, we have PT Eksplorasi Nusa Jaya, I Minerba Indonesia, PT Greenland Resources, Harita Nickel, PT Indodrill Indonesia, PT Nusa Halmahera Minerals, and PT Timah Tbk. Our workshop sponsor, Sequent Limited. Our other sponsors, PT Medco Energy Mining International, and PT Minevesting Resources Indonesia. And last but not least, our media partner, Dunia Tambang. To our sponsors and media partner, we sincerely thank you for your support in making this event happen. To start today's convention, the first session will focus on implementing new technology for mineral exploration and discovery. This session will have two keynote speakers. The first speaker is Dr. Jeffrey Hedenquist, an independent consultant from Ottawa, Canada. Dr. Jeffrey Hedenquist will be speaking of a state-of-the-art to link porphyry and epithermal systems for exploration and discovery. Next, our second keynote speaker is Dr. Xiaoshan Chang, a researcher from Colorado School of Mines, who will be speaking of SCARN, zoning patterns and controlling factors. This session's moderator is Dr. Andi Yahya Al-Hakim of Institut Teknologi Bandung. But first, allow me to introduce Bapak Andi Yahya Al-Hakim's background. Dr. Andi previously earned his undergraduate and graduate degrees in mining engineering at Bandung Institute of Technology, Indonesia. He then earned his doctorate degree in the chair of geology and economic geology at the Montan Universität Leoben, Austria. His work experiences is currently a lecturer at Earth Resource Research Group, Faculty of Mining and Petroleum Engineering at the Institut Teknologi Bandung. To Dr. Andi, you may now open this session.
Hi everyone. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh, Pak.
My name is Andi Yahya. I'm the welcome to today's MGEI webinar. I will be moderating today's webinar, and I'm going to give a little bit more time while people are joining. But in the process, I just wanted to offer a few logistical items. We will have the conversation today is going to be listened for participant, and we invite you to raise your questions after the presentation. So I would like to introduce Dr. Jeffrey Hedenkis. Dr. Jeffrey Hedenkis is an independent consultant, and he has a position at the University of Ottawa. He worked with the New Zealand and Japanese government for over 10 years each on geothermal energy, development, and volcanic discharge, respectively. And during this time, he also studied the formation of epithermal and porphyry deposits. Since 1999, Dr. Hedenkis has been an independent advisor to over 120 mineral industry and governmental groups. And he was the president of the Society of Economic Geologists between 2010 and 2011. Without any further ado, please welcome Dr. Hedenkis. You have 30 minutes of talk and is followed by 15 minutes of presentation. And is followed by 15 minutes of discussions. Pak Jeff, can you hear me?
Yes, thank you very much, Pak Andi. And I have shared my screen. Pak Andi, can you see my screen?
Yes, we can see it. So it is Sumbawa. Time is yours, Pak.
Thank you very much. Selamat pagi. I am very pleased to be here this morning at the invitation of MGEI to discuss the transition to the top of the porphyry copper deposits from epithermal deposits, the level of epithermal deposits. This view shown here is overlooking the recent valley discovery of Onto Sumbawa, a world-class copper gold deposit in Sumbawa. I'll briefly discuss it at the end of my talk. The general points I want to make: the arc-hosted epithermal deposits form at shallow depths, less than 1 kilometer below the surface. Epithermal and porphyry deposits are both intrusion-centered in arcs, and therefore there are magmatic hydrothermal fluids involved with all of them. And from the epithermal to the deeper porphyry level, there's a transition of zoned alteration that we'll be discussing. First, let's look at the distribution of major porphyry in blue and epithermal deposits in yellow. As we can see, there's the Circum-Pacific arc, the active volcanic arc, but also epithermal and porphyry deposits. Also, there are older deposits distributed through the Tethyan arc, as well as even Paleozoic deposits in Central Asia and elsewhere. This general schematic shows the nature of convergent margins, that is, subduction zones. And subduction zones are critical for the formation of major epithermal as well as their linked porphyry copper deposits. We have particularly two styles in the arc, two end members, I should say: epithermal high sulfidation deposits, closer to porphyries, and somewhat to the margins, intermediate sulfidation deposits. And those show a transition to the tops of porphyry deposits. Now, this is a general framework. There are many variations, impossible to discuss them all today. And some things don't make sense, just like this nice green apple skin around an orange. Therefore, we have to make observations and interpret those observations. Now, this is a recent schematic by Dick Silto of arc-related porphyry copper systems, showing general ore distributions at depth related to the shallow 2-3 kilometer deep intrusions. There's the porphyry system, as well as marginal skarn and or carbonate replacement deposits. And at a shallow level, there's the lithocap of advanced argillic alteration that forms essentially in the epithermal environment. Now, this environment hosts proximal high sulfidation deposits, proximal to the underlying porphyry, and more distal intermediate sulfidation deposits on the margins of lithocaps. Now, in this view, we see the alteration distribution. At depth, we have potassic alteration, biotite, magnetite, that's related to brines. Now, those brines exsolve a vapor, and that vapor can rise, discharge from volcanoes, but a part of that vapor condenses and forms the acid fluids that cause the advanced argillic lithocaps. Thus, we say that these are linked. Brine and vapor are linked, and therefore potassic and lithocap are linked and form at the same time. Subsequently, we have an overprint of lower temperature and lower salinity liquid over the potassic zone, and that's basically causing white mica alteration, and at a shallow level that transitions to aluminosilicate alterations at the base of the lithocap, and that may also be the stage for introducing metals to the initially barren lithocap. Now let's take a look at the surface at these vapors that are discharging from volcanic structures. Here is Satsumi Ujima, the south of Kyushu in Japan, with acid hot springs as low as pH 1 discharging around the margins of the island, and the discoloration is due to the dissolved rhyolite that's in solution. High temperature fumaroles discharge with hydrochloric acid and SO2, but very low concentrations of gold. These vapors, when they condense, the H2S, the SO2 combines with water to form sulfuric acid. And as the temperature decreases, both sulfuric acid and hydrochloric acid dissociate and cause very acid conditions. Now, those acid conditions result in the leaching of the rock to residual quartz, sometimes with a vuggy texture. In places, we can have up to 97% silica in, for example, here, originally a rhyolite rock with only 70%, because all the sodium, potassium, calcium, magnesium, aluminum is leached. We also get alunite alteration on the margin, and in this case, there's less than 2 part per billion gold in this alteration, locally one sample of 29 part per billion. So this, we say, is essentially a barren style of alteration. Now that's Satsumi Ujima on the horizon. Here on the mainland of southern Kyushu, there's a high sulfidation deposit called Iwato in the Nansatsu district. Here, quartz alunite alteration formed at 3 million years. And the residual quartz that's present in this, shown in this plan map about a kilometer east-west, it has narrow halos of quartz alunite alteration to kaolinite alteration, shown in orange and yellow, but the residual quartz hosts the plus 1 gram gold ore bodies. It looks like a continuous zone. However, when we look at a long section, we can see something different. We see that the impermeable andesite is cut by a series of fractures, and narrow zones of alteration that rise. And then when they reach this permeable tuff horizon, there was mushrooming of the acid condensates, acid fluids, and that zone coalesced. Subsequently, when the gold mineralization took place, we also had the gold concentrated in the feeder zones and then mushrooming over into the lithocap. This is the first recognition of lithocap control, and also where they are mineralized, the highest grades are in the feeder zones. Now, this was a deposit was studied even earlier, locally with high grades, Summitville, Colorado. It's the type locality where we first used vuggy silica or residual quartz. Here we can see on the left the original monzonite with large feldspar phenocryst completely leached out. This rock is over 90% silica. This is subsequently the host to gold mineralization. And on the margins, underneath the snow here, is the quartz alunite with very coarsely crystalline alunite. Now, these zones of residual quartz, quartz alunite, and aluminum silicate halos, they flare upwards as we get to shallower levels. And also, these sulfides have a evolution from deep tennantite or chalcopyrite to shallow enargite or covellite. Very simply, the upward flaring of the alteration is due to cooling. The fluids become more reactive on cooling, and also the shift from chalcopyrite to covellite at shallower depths is also related to cooling. Very simple processes. Now, this is a schematic to show the nature of these lithocaps. The lithocap follows the permeable lithologic horizon with a core of residual quartz and halos of quartz alunite. In the early stage, this is barren on formation. All lithocaps have feeder zones, but if there's no permeable horizon, the feeder zone will not have a lithocap. And finally, importantly, many lithocaps are barren, but where they are mineralized by a subsequent fluid, the best grades are in the feeder zones, the highest grades. So those zones must be tested. Now, also, we can have a different style of advanced argillic alteration called steam-heated kelnite alunite alteration at the paleosurface, related to H2S oxidation to sulfuric acid. Now let's take a look at one of these examples of high sulfidation deposits. Here, the La Coipa high sulfidation district in Chile, first discovered was Ladera Ferion, mined in the early 1990s, but subsequently discovery of Coipa Norte and Can-Can, except that those were underneath steam-heated alteration. Now the residual quartz of the ore body is very dense, quartz-rich, we can see here with vuggy texture, but the steam-heated zone, which forms a blanket over Coipa Norte and Can-Can, is very soft rock, white porous rock, kaolite and alunite with opal, similar minerals to the halo of the residual quartz, but different environment. Now, this steam-heated alteration extended to the north into the Puran area, and so the company continued their exploration to the north, recognizing that the steam-heated alteration may be lying over, the barren steam-heated alteration may lie over mineralized ore bodies. Initially, they were testing this zone of steam-heated alteration. Some drill holes, however, were unsuccessful in this area, but with some geophysical surveys, as well as low levels of geochemical signatures, they eventually discovered a deposit beneath Puran Norte. And this deposit was underlying the blue horizon of steam-heated alteration, with a zone of silver-rich and gold mineralization at about 50 meters depth or more, and with only a 3 gram per ton silver anomaly in the steam heated alteration at the surface. Here we see, after discovery, the mine having been opened up, and the steam heated alteration forms a nice blanket of kaolinite with opaline horizons, replacements, very opaline, right at the paleo groundwater table. Now, how does the steam heated alteration form? Here we have White Island in New Zealand with high temperature vapors also discharging with SO2 and HCl. On the surface, we see those high temperature hypogene magmatic vapors that condense, form a pH of about 1. They leach the rock with alunite kaolinite halos. However, nearby, there are low temperature fumaroles, only 100 degrees. These are called steam heated. And these fumaroles only have CO2 and H2S. The H2S basically condenses, and atmospheric oxygen causes the oxidation to sulfuric acid, not as acid, pH 2 to 3, and kaolinite and alunite nevertheless still form. I'll show you a short video clip here. This is a steam heated mud pool. It is not boiling. It's 70 degrees in temperature, and those bubbles are CO2. The mud is kaolinite. So this style of alteration forms at the paleo surface over the deeper residual quartz alteration. Now back to White Island when it was not erupting. Here we see the volcanic vent filled with very acidic waters, pH 0.2, which flow out to the ocean, dissolving the rock, flowing off to the ocean. This is dissolved andesite and dacite here. But within the acid crater lake, there's colloidal silica that's settling out of suspension and forming finely laminated colloidal silica deposits. Here they're mud cracked. Well, why are we looking at silica, colloidal silica depositing in acid crater lakes? Well, let's move to northern Chile, Yanacocha, the world's largest high sulfidation mining district. 1,200 tons of gold production and resources. Here we see a dome, barren lithocap, with flow-banded textures here indicating the volcanic dome nature. And right on the margin, at this level, are a series of finely laminated siliceous sediments, even with cross-bedding, indicating a lacustrine formation. Elsewhere in the district, we also see finely laminated siliceous sediments with classic sediments, even in drill core. These are basically indicating that this was the paleo surface of a series of acid crater lakes. And they define basically the original surface. Now, since we were talking about Yanacocha, let's take a look back at the high sulfidation deposits, a series of high sulfidation deposits over district 15 kilometers long. Chaquicocha was right here, that barren dome, but Chaquicocha deposit present at depth. Basically, the lithocaps that host the high sulfidation gold deposits are sitting over the top of a porphyry or a series of porphyries, and we can see one in Kufertal, meaning Copper Valley. At the bottom of the valley, we've descended below the lithocap of residual quartz, the host of gold mineralization, and we can start to see these porphyry vein stockworks. And they're overprinted by white mica along with perovskite and alunite. And we also see patchy perovskite alunite replacement of the residual quartz in the drill holes. Now, the porphyry itself has a biotite age, hydrothermal biotite age of 10.7 million years, the same age as alunite within the adjacent lithocaps, gold deposits, 10.7 million years. So at the same time the biotite was forming, the alunite was forming from vapor condensates at the surface, but not directly over the porphyry, rather on the margins, or as we say, on the shoulders of the porphyry deposits. Now, let's shift to a little bit closer to Indonesia. Here in northern Luzon in the Philippines, a series of linked porphyry and epithermal deposits. Here at the surface, we see the quartz alunite lithocap, very resistant to erosion, hence forming a cliff, and other cliffs all along been exposed by the river erosion. And the reason for the quartz alunite being present in cliffs along that valley is because it's at the unconformity between the volcanoclastic basement and the overlying dacite pyroclastics. Let's look at a cross-section through that unconformity. Here we see the unconformity between the volcanoclastic basement rocks and the overlying dacite pyroclastics. Right where the river eroded that unconformity, we see again cliffs, very resistant cliffs of quartz alunite. Here, very low grade, 12 to 49 ppb gold only. If we were to drill a hole through this zone from the top of the hill, it would look like this was a rootless lithocap going through camlite, dictite, quartz alunite, maybe hitting some residual quartz, maybe with a little bit of gold anomaly. But there are no rootless lithocaps. All lithocaps have feeder zones. So we should map and realize that this is an unconformity, realize that unconformities, lithocaps have feeder zones, perhaps recognize that this fault could be a feeder zone. And if we tested that intersection, we would have drilled through the feeder zone and experienced very high grades. Indeed, 70% of the Lepanto ore body is hosted within the feeder zone and lower grades within the marginal lithocap. So the cross-section was right here, 1.5 kilometers from the underlying far southeast porphyry deposit. This was recently drilled out from 700 meters depth underground, 98,000 meters of drill core, and a porphyry copper deposit with 1% copper grade shells, 0.7 gram grade shells. And you can see 600 tons of gold, 5 million tons of copper. The biotite is 1.4 million years related to a brine. Well, that brine would have given off a vapor, which would have ascended to the surface and discharged its high temperature fumaroles, but some of that vapor would have also condensed into groundwaters, flowed off along the unconformity between the basement and the pyroclastic rocks in the plane of the Lepanto fault in this section. And that's when the lithocap formed, residual quartz and quartz alunite. The alunite, not surprisingly, the same age as the biotite, because the brine and the vapor are linked. And at that stage, we formed the residual quartz, barren, low-grade residual quartz here, very silicic. Subsequently, there was a slightly younger 1.35 overprint of white mica alteration on the porphyry. That grades up to pyrophyllite at the base of the lithocap, and that lower salinity, lower temperature fluid flowed out along the lithocap, and you can see here the brecciated lithocap has been cemented by enargite and gold ore. And so that is the mineralization stage of the lithocap. Now, in addition, just like at Puren, those were intermediate sulfidation veins 3 kilometers north of the La Coipa district. Here, there are also intermediate sulfidation veins only 500 to 1,500 meters away from the porphyry. Hence, our schematic model, we see everything of the schematic model. The proximal Lepanto high sulfidation deposit, residual quartz hosted, the more marginal intermediate sulfidation Victoria gold deposit veins on the margin of the lithocap, overlying the transition of white mica to perovskite in the deeper porphyry. Now let's take a look at this transition zone from the epithermal deposit or the epithermal environment down to the top of the porphyry. Here, let's go to the Andes in northern Chile, north central Chile, the El Salvador porphyry copper deposit discovered in the 1950s. And in the Andes, many porphyry deposits are exposed due to deeper erosion. And in this case, we have the original biotite and sulfides of potassic alteration overprinted by muscovite, a very large area of muscovite, 4 square kilometers. But the top of this hill here, Indio Muerto, is dominated by perovskite alteration. If we take a look at a cross section shown through here, but then this part of the diagram is outcrop surface, we can see that bornite chalcopyrite or chalcopyrite pyrite is a halo at depth to this late intrusion. The intrusions are at depth and hosting the copper mineralization. Over the top of the intrusions in the copper mineralization is a zone of muscovite, as well as andesite, andalusite in the purple, and subsequently an overprint of perovskite. Here we can see in an SEM image, the dark bands are perovskite replacing the crystals of muscovite. And that is occurring just slightly more shallow than the muscovite horizon. Why do we get muscovite being overprinted by perovskite? It's not because of more acid fluids. It's very simply because of cooling. Julian Hemley conducted experiments in the 1960s, and he showed this muscovite or muscovite plus andesite coexistence at higher temperature. But as these fluids cool, at 41.5 million years in the case of El Salvador, those cooling fluids enter the perovskite stability, and below 300 degrees, they can even enter dicite stability. A simple case of natural cooling as fluids are rising. And so when we look at El Salvador here, we see the preserved biotite largely altered, formed at 41.5 million years. We suspect, just like at far southeast in Lepanto, there would have been a similar age or same age residual quartz and quartz alunite lithocap. But there's been a kilometer erosion and the lithocap has been removed. Subsequently, there was this overprint of andalusite and muscovite over the top of the ore system. And at the upper portions of the muscovite and andalusite, we have this perovskite zone due to the cooling of the muscovite fluids. Very natural transition over the top of the porphyry. Well, that brings us to Onto. I showed this at the beginning, and this was a spectacular discovery by valley geologists in Indonesia, Sumbawa, Indonesia, a few years ago, recently announced. And there is some kaolinite, alunite, and clays at the surface, but we're going to look at a cross-section provided to me by valley geologists, a recent publication, Northwest, Southeast. And here we can see a shallow horizon in blue of residual quartz, locally with vuggy texture. And below that is a zone of quartz alunite to quartz pearlite alunite, locally, just like at the Kuffertal porphyry at Yanacocha, there's patchy textures of pearlite alunite replacing the residual quartz, or replacing the rock, I should say. And that alteration style is what hosts the mineralization at Onto, with this purple covalite as mixed with pyrite, locally very high grades of copper as well as gold. And it appears, based on the initial work, that the covalite is intergrown with pearlite and alunite. It was taking place during the luminosilicate alteration. Now, unlike El Salvador, where the aluminosilicate alteration was acting as a halo over the top of the intrusions and the copper mineralization, here the intrusions are present at the level of mineralization. Mineralization is shown in this dotted blue line and through here, but all the alteration is completely dominated by aluminosilicates and alunite. However, we know that there were early AB veins, typical porphyry veins, almost to sea level elevation, and these were subsequently overprinted by residual quartz. We can see the veins present here, but they've been completely overprinted by residual vuggy quartz. Nevertheless, they're still great in the rock. And so this is a variation on the theme. It's not typical. Definitely, it's a very interesting deposit, a huge deposit, but it's not typical in its style. It requires observations to be made, examination of the paragenesis to determine what are the characteristics that led to this particular deposit forming. So in summary, we see the epithermal environment here at shallow depth hosting high and intermediate sulfidation deposits, hosted by the lithocap or intermediate sulfidation adjacent to the lithocap, but there's a transition with depth to the tops of the porphyry. We have a variety of alteration styles. Steam heated alteration at the pediosurface that's barren, formed at low temperatures. Then we also have a different style of advanced argillic alteration formed from vapor condensates, magmatic vapor condensates at higher temperatures, forming the residual quartz alunite. Another style of advanced argillic alteration, that is the pearlite and dicite, but that's related to cooling of the magmatic fluid from white mica to pearlite. And of course, we can also get supergene oxidation of pyrite, causing a supergene overprint. So we have 5 different environments to produce advanced argillic alteration minerals. If we only call this all advanced argillic alteration, we're losing the detail. We must maintain minerals and mineral assemblages rather than simply summarizing it all as advanced argillic alteration. Now, La Cuepa sat beneath the steam heated alteration. Puran, intermediate sulfidation, 3 kilometers to the north, also sat beneath barren steam heated alteration. Yanacocha, hosted by lithocaps, but below the lithocaps in that valley of erosion was the Kuffertal porphyry, the tops of the Kuffertal porphyry through the pearlite white mica transition. And Lepanto's hosted by lithocap that may be over 1 kilometer lateral from the underlying porphyry, far southeast porphyry. Victoria is 0.5 to 1.5 kilometers to the south of the porphyry on the margin of the lithocap, and through the quartz pearlite and white mica transition, we get to the far southeast porphyry. The question is, how does Onto fit into this? It's clearly a more complicated system, one of overprint, and I look forward to the valley geologists in Indonesia sorting this out and informing me in the future. Thank you for your attention. Here, a final few points. There are no magic bullets, no magic tools or techniques, just good geology. Don't force prospects or deposits into a published model. Simply interpret variations. And finally, use your training and think laterally. Also, build on your experience to eventually come up with the best targets to test. Good luck in your exploration. Thank you.
Thank you, Pak Jeff, for the insightful presentation. So there's many things that we can learn from the expert, and I would like to invite someone who have some questions to Pak Jeff. So you may raise your hand and I will select you, and the committee will try to unmute you. Okay, first we have Pak Ilham Ilmawan and then followed by Pak Adi Mariano. So, okay, Pak Ilham, you may ask your questions to Dr. Jeffrey Hadenfish. Time is yours.
Okay, thank you for the occasion. Thank you for your speaking, Mr. Jeff. I want to ask, a few moments ago, I worked on an exploration project in northern Maluku to look for the continuity of Gosowong complex epithermal vein. Unfortunately, none of them had been found. I only found advanced argillic and opal silica blanket. We tentatively concluded by the limitation of the analysis provided, just hand lengths, that we are playing in a steam-heated environment. As you explained before, steam-heated alteration is formed due to the presence of H2S that rises to the surface, followed by interacting with groundwater and form acid sulfate water. H2S is present through the vapor release from boiling at the deeper level. As we know, the boiling in the low sulfidation epithermal environment is the most important process in the deposition of gold from bisulfite complex. I want to ask, is there any hope of finding the spectacular vein texture represented by the boiling somewhere below this zone? And what is the geochemical indication to guidance to the ore? Thank you very much.
Well, that's a very extensive question. Could take a long time to answer, but I'll try to be brief. Prior to the answering that question, I would say I've been fortunate to work once at Gosowong, and there is to the west slightly older porphyry systems that are eroded and have produced residual quartz alteration. At the same time, there appears to be places where residual quartz may actually overprint Gosowong's style of alteration. It's a very complicated tectonic environment, switching back and forth between hydrothermal styles. So it's definitely complicated. While I was there, I did not see steam-heated alteration, but I did not look far beyond the mines. Yes, you're correct. Steam-heated alteration does require the deep fluid to be boiling. And we can have steam-heated alteration, sometimes extending for kilometers away laterally from the source of deep boiling fluids. So it simply is a challenge to track back. The problem is that there's very little, aside from mercury, there's very little geochemical anomalies in steam-heated alteration because this is very low temperature vapor. It doesn't transport arsenic or antimony. However, sometimes steam-heated alteration does, because of erosion of the groundwater table, does overprint the deeper altered rock. And so it is worthwhile analyzing and looking for any geochemical anomalies. Like at Puren, that 3 ppm silver anomaly, in fact, was due to an overprint. Low grade, but still it was anomalous over the 0.2 ppm silver background. So I don't have any good advice aside from do the best geology you can. Look for any deeply incised valleys that might give you exposures beneath the steam unit alteration.
Thanks, Pak Jeff. I hope it can answer Pak Ilham questions. And now we have Pak Adi Mariano. Pak Adi, time is yours.
Thank you. Hey Jeff, a long time no see.
Yeah, Kadi, good to see you and hear you. I feel that I'm in now.
Yeah, it's really good to have you and very clear and sound what you call lecture that you give to us. It's really good. It's and you speak slowly and quite clear for us. I have a question for you, Jeff. Number one, that some of the telescope system, they do have still footprints of the feeders, like that you pointed out, that we can still observe. And why it is important to see the footprint of the feeder? Because when we mining, when we processing, it's bring a lot of consequences, including the penalties and the concentrates, arsenic and pyrite and other things here. My question would be, I don't see those things we can recognize at Onto. And my question would be, how can we actually recognize and map the feeder so that we can have a better mineralogical distribution into the system so that we can recognize during the development and the processing? That's number one. And number two.
Can I answer that one first before I forget?
Yes, sure, please, yeah.
I'm getting old and I have a short memory. Thank you. No, that's a very good point. I don't have, well, first of all, as you pointed out, Onto does not have copper arsenic sulfides. It has covellite, which is tremendous. There is some enargite on the margins of the system, but it's not very much. Less than 10% of the copper resource at Onto, from what I understand, has some arsenic in it, and only on the margins. Why that is, we'll have to ask the valley geologists working there to work on that problem. Now, there are 3 quartz alunite zones that look like they pinch down into the main ore body. They may actually be upflow zones with halos of the peroxide, Dicite peroxide alunite zones. I don't know, I've never worked there. I'm just going on the basis of what I've read so far. You mentioned telescoping. Now, I'm speculating here, but I'm wondering if there was an early porphyry Onto, and then there's a deeper porphyry below Onto, deeper than drilling. And what we're looking at is the lithocap, the quartz alunite and transition zone of an even deeper porphyry intrusion. That's only speculation. As I said, I really don't have good answers to your points, except to try and focus on the mineral assemblages. Definitely do not call it all advanced argillic. Work on the assemblages of residual quartz, quartz alunite, quartz alunite peroxide or dicite, and with a shortwave infrared equipment, we can help define that along with using our hand lens. And also record the textures, of course, along with the mineralogy, textures and morphology. And hopefully that will all help come together to answer those questions. I don't think I completely answer your question, but I'll try the second one.
It does make sense, Jeff, because when you're looking at David's paper, actually, they have several events of the high school radiation events, which actually quite different age ages, and it could be that it's possible. Okay, the second one that's always intriguing for me as explorer is you described very well about the lithocap, the setting, the what do you call the geometry, and the variety. If you compare with the transition of the porphyry that you described, the question is always how can we recognize at the surface for the barren lithocap? Yeah, because we all believe that it is proxy to the economic deposit. But the problem is that as a practical people here, we don't want to drill like, spending $30 million US, not getting anything. I mean, Vale was very good example of persistence and a successful, but it is painful because it spent a lot of time before discovery. So then not everyone's like Vale, and then a small company, we have only said that 5 million at maximum, and we want to make a use of it, and it's a cost-effective way of exploring things. So what would be the critical picture recognizing barren to the mineralized lithocap?
Okay, I'll give you a few quick explanation or a few quick observations. The first is to appreciate that lithocaps may be barren. In fact, they may be completely barren, but if you have a lithocap, you definitely have an intrusive system at depth, and that may be copper mineralized. And it will be proximal to any feeder zone, and feeder zones always have some type of structure. They might be on the margin of a diatreme or a dome complex or a big through-going fault. So map out those potential controls to feeder zones, because one, the feeder zone will always be the highest grade. So even though you don't have a good control on the variation mineralogy in the lithocap, look for big structures and test those big structures. And if they're barren, okay, maybe the lithocap is barren. But then also, if you're near a big structure in the feeder zone, that will be proximal to a deeper porphyry. So there's no, as I say, magic bullets. It's just taking good geology, but having the right background and understanding, and hopefully some experience on this style of deposit and exploration. And realize that there is a lot of variation in the shallow environment. Lithocaps can be huge. The lithocaps at Onto extend for at least 4 kilometers to the north. And fortunately, Vale they did test an early porphyry, low grade, but they were very fortunate to have then tested the Onto system. The other thing is, at Onto, about the upper 300-400 meters of the lithocap are barren, but they found some breccias, phreatic and phreatomagmatic breccias that were carrying mineralized clasts. So on the basis of those mineralized clasts, they recognized that there was something at depth. And also those mineralized clasts did give, it was nature's drill hole, and did give some geochemical anomalies in the shallow stream sediments.
Thanks very much, Jeff. It's quite insightful. Yeah.
Thank you, Adi.
Thank you, Pak Adi, and also Pak Jeff. Okay, we are running out of time, but we still have one more questions. And please, Pak Rizal Furqon, you may direct your questions to Pak Jeff.
Hi Jeff, I'm Reza, student from Akita University of Japan. Yeah, nice to see your presentation, Pak Jeff. So I have a question about the mine state copper mineralization in the porphyry system, because in the past we normally searching the potassic core to find the high grade copper mineralization, but I think in the recent 20 years some discoveries prove that the mine state copper mineralization in the porphyry system not always associated with the potassic alteration, right? In Cukui, Kamata, and most recently, I think next year, I don't know you involved or not with Antonio Arribas in the paper in the Lepanto. It's associated in the white mica state alteration. So I have a question: what causing the variability of the different mineralization states in the porphyry system, while some other associate with the potassic event, but some other associate with the white mica states event? I think that's my question.
Good, thank you. Yeah, you're right. There is a lot of observations, and we're starting to change our thinking. At Far Southeast, Michael Calder's work, which paper almost accepted now in economic geology, showed that maybe the potassic stage was 0.5% copper, 0.5 grams gold. That's not a bad porphyry grade if the porphyry is exposed at the surface. If it's deep, those grades are too low. However, the chlorite, white mica, elbite overprint was responsible at lower temperatures for bringing the high grades. And that appears to also be the case at Batu Hijau. Now, originally, we saw a lot of sulfides in AB veins at Batu Hijau and many other porphyries, but recent examination of cathodoluminescence shows that those AB veins are simply reopened by the later fluids. So what was thought to be early is actually the white mica chlorite stage. Why? I don't have an answer for you, but we simply realize now that it's this overprinting stage that is more and more recognized and also is associated with the high-grade copper. Not all the copper, there is copper with potassic, but particularly high-grade copper. And I believe that may also be the case. I don't know, I don't want to put words in your mouth at Grasberg, but I look forward to seeing your work at Grasberg.
Yeah, thanks for review our data. Yeah.
Okay. Thank you for the answer, Pak Jeff. And by that, I would like to come back the session to the moderator, the Master of Ceremony. Please, Mbak Rahma. Ya. Udah. Iya, langsung.
Thank you very much, Dr. Andi Yahya, and also to Dr. Jeffrey for your presentation. And now I would like to invite Dr. Arifuddin Idrus, Secretary General, to give the memento virtually to Dr. Jeffrey. All right, if the two gentlemen could please look to the camera, I will count from 3, 3, 2, 1. All right, thank you very much. And now I would like to take a photo with the three gentlemen, Dr. Jeffrey, Dr. Andi, and also Dr. Arifuddin Idrus. Could the operator please display the three gentlemen? All right, I will count from 3, 3, 2, 1. All right, thank you very much, gentlemen. And now I would like to give it back to Dr. Andi Yahya Al-Hakim to open the second session with Dr. Zhaoshang Chan. To Dr. Andi, you may now proceed to open the second session.
Again, thank you for Pak Jeffrey Hedenkis for the presentation. Please, we may give some virtual claps for his sessions. And we shall continue to our next agenda. Okay, now we'll have Dr. Zhaoshang Chan from Colorado School of Mines. Dr. Zhaoshang Chan has been graduated from Peking University in 1997, and he earned his PhD from the Economic Geology of Washington State University in USA. He has worked at Peking University as an assistant professor, during 1997 until 2000 at Washington State University as postdoctoral research associate at Coates, James Cook University, and also he was also the director of the Economic Geology Research Center at James Cook University. Dr. Chang currently sits at Colorado School of Mines as the Charles Fogarty Endowed Chair in Economic Geology. He has studied a wide spectrum of mineral systems, including porphyry, skarn, epithermal, IOCG deposits, tungsten and tin, and also sediment-hosted gold deposit in 14 countries. And currently, Zhao Shen runs a laser ablation ICP-MS laboratory and shortwave infrared analysis lab at Colorado School of Mines. Okay, Dr. Zhao Shen, can you hear me?
Yes, my internet here is not stable.
Okay.
Do you mind play the video?
Yes, we will show you. We will show the videos. Could the operator help us with the presentation?
Thank you.
Okay, Dr. Zhao Shen Chang has recorded the video, and we will play the video, and he will join with us for the question and answer sessions.
Hello, everyone. Thank you for coming to this session. And firstly, I'd like to thank the meeting organizer for inviting me to give this presentation. And thanks for the introduction. My name is Zhao Shen Chang. I'm a professor at Colorado School of Mines in the United States. Today, in this presentation, we're going to look at scars and the zoning patterns and the controlling factors. Why do we care about scars? Actually, scar is one of the most common type of deposit in the world. In this diagram, that shows the my database of more than 1,600 scars. Those are the scars actually described in literature in the public domain. And many of you are from the industry, and you know that how many more may be locked in the archive of the mining companies and never get to be described in the public domain. So there's many scars around the world. And they're the major sources of tungsten and tin, and a significant source of copper, gold, zinc, lead, moly, iron, etc. For example, Antamina in Peru is one of the largest scars, and it has more than about 3 billion tons of resources. That was in 2015, I believe. Now there's more. And in Indonesia, you have another very big scar, which is the Earthberg Grasberg district. And it's very well known. Everybody says it's a porphyry deposit. But when Clyde published this paper in 2012, and you look at the number, the scars actually has 2.8 billion tons and porphyry 2.3 billion tons. There's slightly a bit more copper in the scars actually than in the porphyry. That's about 55% of the copper and 47% of the gold are in the scars actually. Okay, so they are quite important. How do we find scars? And the zoning pattern actually is a very good vectoring tool in the exploration of scar deposits. And there are zoning patterns at different scales, and there are zoning pattern at the deposit scale, and also there's zoning pattern at district scale. Let's start with the larger scale from the district scale. Say scar, their proximal scar, their distal scar, and if you can figure out which part is the proximal scar, then towards the intrusion, you may have porphyry deposits if the wall rocks are more oxidized and less fractionated, and also you may have Grayson type deposits if the magma is highly fractionated. So that's getting closer to the intrusion. You may have different types of deposits, And at the distal end, if you go to more toward the marble side, we may have carbonate replacement deposits. CRD, those are carbonate replacement deposits. And if you go further out and toward the wall rock, you may have Carlin type deposits, or outside of Nevada, it's mostly called Carlin-like deposits, mostly gold mineralization. And those zoning patterns, so that's when you have one of these deposits in this scar-related system, you can find other types of deposits by following through the zoning patterns and by figure out which direction is toward the intrusion and which direction is toward the wall rock. Okay, so that's district scale zoning patterns. At deposit scale, there's also a lot of zoning patterns we can use. Suppose we have a intrusion here, the fertile intrusion, and then we have calcareous wall rocks, and there may be limestone, maybe dolomite stone, and maybe calcareous shale, etc. And so the zoning typically is that in the intrusion, we can have endoscars. Inside the intrusion, the endoscar may occur as veins. And when you get to the margin, you may or may not have a zone of massive endoscar. And then in all these wall rocks, we'll have those exoscars right next to the intrusion. We have massive metasomatic scars. Those are the heterothermal scar. Go further out, there's the bleached marble, and then to marble and to limestone. And you may say, oh, what's bleached marble? Well, limestone is typically gray color and even to black color because of the organic carbon inside them. And when they are recrystallized to marble, they may still be gray color. But when it really gets close to the scar, the temperature is higher, and then the organic carbon is driven out, and you lose the color, and it become a white marble. And so that's called bleached marble. So that's the typical zoning pattern from the intrusion to the wall rock. And if your wall rock change composition, if the wall rock is calcareous shale rather than this limestone or dollar stone, and then this calcareous shale will be changed to calcitic hornfels at the position equivalent to marble. And in another scenario, if you have alternating thinly bedded shale and limestone, then you may form a lot of reaction scars. Again, the position is equivalent to marble. So over here, they are all metamorphic scars. They are not hydrothermal scars, they are metamorphic, caused by the thermal metamorphism of the intrusion. Okay, so that's the general pattern. And sometimes those massive scars and the metasomatic scar, they can be really massive. And if there's tens of meters, you probably don't worry about it too much. You're finding the scar, you're close to the intrusion. But sometimes they can be hundreds of meters and sometimes more than 1 kilometer. So if you find a scar, you're standing on an outcrop of scar, you can be still having trouble and say which direction is the intrusion, which one direction is the wall rock. So do we have any zoning patterns inside this massive scar? And actually, yes, we do. So something we can look at is the garnet-pyroxene ratio. Typically closer to the intrusion, we have more garnet, and then closer to the wall rock, closer to the marble front, we have more pyroxene. So the garnet-pyroxene ratio actually decrease toward the marble front. The garnet color also have a significant change. Typically closer to the intrusion, we may have dark red, almost black color garnet, and you go outside, further out, it become red color, then become brown color, and eventually it gets to very light to green or yellow color at the marble front. Pyroxene also have a color change, but this time the color is all green, and the change of the color is from light green color closer to the intrusion to dark green color closer to the marble. In addition to those colors, there may be the combination of the pyroxene, and if you have amphibole, they can also have a bit of change, and that's shown as the manganese content. And the manganese content in those two minerals will increase from the margin of the intrusion to the marble front. And well, you can't see that in the field, but actually there's something you can infer the manganese content is by the color of those pyroxene and amphibole. If the color start to change to brownish color, it tells you actually there's more manganese in those minerals, and normally they are green color. Okay, so those are the zoning patterns inside the massive scar. There's something else is the further outside of scar, there are also fluid escape structures. Those are typically veins. Closer, that's wider veins, and away become very narrow veins. And those ones typically has manganese oxide and tell you this is related to a hydrothermal system. And those ones can go out into the marble or even into the limestone. Okay, so that's the overall picture of the scar, the zoning in scar system. Let's look at some examples, and those are the copper scar. This is Coal-Fark scar in Bingham district. Actually, current day, it's already in the Bingham pit. So it's part of the big porphyry scar system. This is the intrusion here, and you have different beds. There's a shale, the limestone, and sandstone, limestone, etc. Obviously, all the scars occur in the limestone beds. And along those margins, you can have reaction scars and chalcophytic hoarfrost. So the scar itself, if we look at it, closer to the intrusion, and that's garnet much more than pyroxene. And then you go out and garnet more than pyroxene, and you go further out and garnet equal pyroxene. And you go further out, there start to have more pyroxene than garnet. So the garnet pyroxene ratio has a systematic change. The garnet color also here closer to the intrusion is right to brown color. Then you go out to brown color, then you go out to brown to green color, and then the closer to the marble front and it becomes yellow to green color. And so the color is getting lighter and lighter, and it's a fairly obvious change of color. And this is another example. This is the Mexico scar in the Philippines. This one is a short, narrower scar zone. It's only in the drill core. It's from 38 meters to 54 meters, so only 16 meters of scar. But it still shows a clear color change. And so this is the quartz diorite porphyry that's causing intrusion. And you can see the red color, the dark red color, that's garnet, and plus those epidote alteration. And so dark red in the inner scar, then you go out to the axial scar, it's kind of reddish brown color, and then to brown color and to yellow brown color. And then if you at the at the marble front, actually those are fairly light yellow color. So garnet color change is fairly significant. And another example, this is zinc scar, and this is a seal or a dike. It's a hypothesis coming off a major intrusion, and the intrusion may be way on this side. And so by the time we come to the end of this dike, the temperature is already fairly low. And then you can see this is the garnet, the red color, the brownish color, that's garnet more than pyroxene. And then the green color is much more pyroxene than garnet because the temperature is lower, and we're at the fairly distal part of the system. And when you get to the real end of the intrusion, then we start to see those bastnäsite and rhodonite, and those are manganese minerals. And if we look at the garnet-pyroxene ratio, we talk about that, and that's more garnet than pyroxene, and that's much more pyroxene than garnet. And this one is specifically to show the manganese content in pyroxene, because we are looking at a zinc scar, so it's more distal. And then we have more manganese in the pyroxene. And in this zone, it's less than 25% Johanssonite, and which is a manganese end member of pyroxene. And in the middle part, we have 25 to 50%. And toward the end, we have more than 50% manganese in the pyroxene. And that's very significant change. And also, you really start to have manganese minerals. And so that shows the zoning pattern. Another example, this is gold scar. This is the intrusion, and that's the hypothesis coming off the major intrusion. And again, the garnet color, the garnet pyroxene ratio closer to the intrusion, 2:1 or 3:1. That's more garnet than pyroxene. And then you go to here, the middle part is already more pyroxene than garnet, is 1:3. And go here 1:5, and it's less and less garnet. And toward the end, that's 1:20. So only about 5% garnet, so really dominated by pyroxene. The manganese content, which is the Johanssonite end member, that's JO, and there's, because it's close to the intrusion, overall there's not much manganese, but still there's a little bit of subtle change from 0%, 0%, 0%, closer, and then you go further out, become 4%, and then go to 6%. So still have this manganese content change. Okay, so those are the zonings inside the scars. And but the scar system doesn't stop at the marble front. And this one is the marble front. It shows the massive scar, and this is the white marble. And you can see the massive scar stop here, but there are other things coming off the massive scar, which are those green veins. And it's very common in the scar system. And the green veins, if you scratch it, it's hard, then it's actually pyroxene. And sometimes it's really soft. That's typically chloride in those veins. And sometimes if you have garnet, and you can also have little garnet veins from the massive scar going into the marble. And then this is 50 to 100 meters away from the scar. You will not have any veins of garnet or pyroxene. It's those black veins. Those are typically chloride or other types of clay. And sometimes you may also have very fine grained disseminated pyrite inside that. And you can see 5 to 100 meters away, they're still fairly thick, a few centimeters thick. And when you go to 200 meters away, and those veins get really narrow and become very narrow and curvy and looks like a stellarite. But actually it's not stellarite, it has the shape of stellarite. And another example, this is Yaojialing in China. This white marble, you see this is white marble close to the intrusion. And then those are convoluted, and you see those convoluted veins, narrow veins. And those are the fluid escape veins. It tells you there's a hydrothermal system around, likely to be a scar. Sometimes if you go further out, really it's just limestone, well, calcite and calcite. There's calcite from the sedimentary limestone, there's calcite from the hydrothermal system. Then how do you know whether there's a hydrothermal signal? And this time, just by mineralogy, we can't tell anymore. Then we can use other tools, for example, carbon and oxygen isotopes of those carbonate minerals. And those are whole rock analysis. And you can see those ones are shale, and those are impermeable layer. This is the example of El Mochito zinc lead scar in Honduras. And those are shales, and in between those are limestones. And some of the mineralization is following the bedding, and that's mantles, and some of them are vertical, cutting across the bedding, and that's mantles. And those are all scars, those hash pattern, those are all scars. And you can see this one, that's the oxygen isotope accommodation, that's the carbon isotope accommodation. So 25% per mil, actually, 24.9% per mil. This one is actually a typical marine sediment signature. So that's the pure sedimentary signature here. And then when you get closer to the scar, you can see the oxygen isotopes that drop to 14%, 18%, 10%, etc. So when it's less than 20 per mil, and it's actually you can be sure that there has hydrothermal signatures in those carbonate rocks. Okay, so that's another one. And typically those in this deposit, oxygen isotope halo is 300 to 400 meters wide. If along faults, it can be up to 4 kilometers long. And the carbon isotope halo is narrower. It's up to 30 meters wide. We're doing more analysis. We have been doing more analysis at Candelaria in Chile, in those carbonates covering the ore body, above the ore body. And we're also doing analysis at Utah around Bingham to up to several kilometers away, and looking at more of those carbon oxygen signatures. Okay, so those are the typical features of the zoning patterns. And you may say, oh, Josh, what you presented is so nice, but how come in my project it's not such a clear zoning pattern? Actually, there are many factors actually affecting the formation of the scar and also the zoning patterns. I'm listing these factors here, but we don't have enough time to cover everything. So I will focus on the first one. So those are the factors. The redox state gradient is not only the redox state of the intrusion, it's not only the redox state of the wall rock, it's actually the redox state gradient, how things change between the magma and the wall rock. And that's a significant feature. We'll look at that. And the causative intrusion, the volatile, the degree of fractionation, the redox state, they're very important for wall rock, the accommodation, the redox state, and the permeability. They can affect scar zoning, and the depths of formation and the distance from magma. They are all important factors. I have submitted an extended abstract to the conference, and hopefully you will see it in the proceeding of the conference. You can read more details about this. So we're only looking at the thermal gradient between the two end members. And so we have this zoning pattern. Actually, there's assumption behind this zoning pattern. The intrusion, the assumption is that the intrusion is oxidized and the wall rock is reduced. For the formation of the scars, then the intrusion is an oxidizing agent and the wall rock is a reducing agent. So if we have this kind of situation, the main thing is the ion, the status of ion. So in nature, we have ferric ion and ferrous ion. And in the oxidized condition, there's more ferric ion. And the ferric ion can only go into the lattice of garnet. And you can only form garnet. So therefore, you have more garnet here. And at the marble front, and there's more reduced environment, and there's more iron 2+. And when you have iron 2+, it can only go into Heidelbergite, which is a type of pyroxene. So because of this, you have less and less garnet and more pyroxene closer to the marble front. Okay, you say, oh, this assumption, is this assumption right? Well, most of the time, if you're looking at the copper scar or moly scar or iron scar, this is always right. We need to have the oxide intrusion to form those scars. And the wall rock is limestone, typically marine sediments. You always have dead bodies of sea animals or sea plants. And so they are very good reducing agent, so organic carbon. So normally it's right. But nature is never the same. There are always exceptions. What will happen if both the magma and the wall rock are reducing? And in this case, this example, nickel plate gold scar in Canada, and the intrusion is here, and you can see it's aluminum bearing, and the I over total I is 0.15. The criteria is 0.4. If you are less than 0.4, it's reduced, and the 0.15 is fairly reduced. The wall rock is reduced too. So what do you end up with? And you can see the scale bar here, 1 kilometer, there's maybe 1.5 kilometer and 2 kilometers of scar. Most of them are pyroxene, much more pyroxene than garnet. So everything is reduced, then much more pyroxene. Another end scenario is both the magma and the wall rocks are oxidizing. Now this is the example of the Maxio scar in the Philippines, in coarse diorite porphyry with lots of magnetite, and so it's very oxidized. And the wall rock is different. It's not a normal limestone. It's actually a marble conglomerate. Long before the marble has changed to conglomerate, then it tumbled into valley and become a conglomerate. And so the organic carbon was already driven out before the formation of this conglomerate. So it's not reducing anymore. So in this case, everything is oxidized. What do we have? And actually in this one, you can see red garnet, that's mostly garnet. The green part, this is pyroxene, a little bit of pyroxene. Again, garnet, mostly garnet, mostly garnet, mostly garnet. So the whole scar zone is mostly garnet. If you say, oh, I need to see my pyroxene to know I'm close to the marble front, you won't find it because everything is mostly garnet. Okay, so those are the alteration zonings. How about metal zones? Well, before we talk about the metal zones, we have so many metals, and we first need to look at which metals will occur together in a zone, and that's the association. And how do we do that? And recently we did the accumulation of scars in China. There are about 390 scars in China. There's a lot of those. And China used to be the planned economy, and they were not thinking about profit. So if there's any metal in the scar, they will calculate the resources. So maybe silly in terms of making money, but actually it's very good for us to look at the associations. So let's look at it. So firstly, moly and gold and tin, and you look at it, this is 162 deposits plotted on this diagram. But really, you can see most of them are plotted at the end member. So they don't really occur together very much. Those metals, they dislike each other. So between gold and moly, there's only 9 deposits have both moly and gold. And it's mostly one of them is a byproduct. Between moly and tin, there's only 4 deposits have both moly and tin. And between gold and tin, that's even less. There's only 2 deposits and have both tin and gold, and they both have only a few tons of gold. So those 3 elements, they don't really like each other. What's the reason for that? And that's actually there is a fundamental reason for that. Let's look at tin versus moly. Tin in nature can occur as 4+ and 6+, 2+. If it is oxidized magma, then tin occurs as 4+. Then it can substitute for titanium and iron. Then it goes into biotite, hornblende, titanite, ilmenite, and magnetite, etc. So what does this mean? And that means the tin get dispersed in those magmatic minerals, and they are just dispersed in the magma chamber. You don't have any tin left for mineralization. If you want to make a tin deposit scar, you really need the reduced environment so that tin occur as a tin 2+. If tin is tin 2+, then it's incompatible. They don't go into any of those magmatic minerals. So they get enriched at the end and then extracted by hydrothermal fluids. Okay, so that's tin. Tin really need a reduced environment. And for moly, moly occurs as 6+ and 4+. If moly is 4+, then it can substitute for titanium, and again goes into the magmatic minerals and dispersed. So for moly, it really needs an oxidized magma so that tin moly is moly 6+ and incompatible, it gets concentrated at the end. Okay, and this diagram is Larry Manner, 1995, long time ago, he already noticed that. And this is all the magma intrusions related to those magma. And the average iron 3+ over total iron, the ratio is 0.4. So 0.4 is the criteria. Above is oxidized and below is reduced. And you can see tin is reduced, moly is oxidized. So that's why they don't occur together very much. How about gold? You can see gold-only scars are also reduced, but why gold and tin don't occur together? And that's another axis. This is actually the fractionation of the magma. For the formation of tin scar, you need a highly fractionated magma with high silica, and typically granite more than 72% silica. But for gold-only scars, they are typically related to more reduced intrusion, about 62% average silica, way less than tin scars. Those are the tolenolite or quartz diorite or dacitic combination. So that's why gold and tin don't occur together very much. Okay, how about others? And there's copper and tungsten and tin. So copper and tin actually, they don't, that's less than 10% of association, so not much. And a surprising factor is actually tungsten and tin. You hear tungsten, tin all the time, but actually they don't really occur together very much, only tin deposit. Tungsten and copper, they actually have a moderate degree of association. Copper, gold, and moly, this is similar as porphyry deposits. So copper, gold have very strong association. Copper, moly have very strong association. And gold, moly, again, not much. Unless you have copper present, then you can have copper, gold, moly together and in the field deposits. This diagram is mostly to show tungsten and moly, they occur together actually very much, very strong association between tungsten and moly. And in fact, the largest, the fifth and ninth largest moly bearing scars, moly is actually subordinate to tungsten. About zinc lead. Zinc lead actually, you see zinc lead can be associated with iron, the scars, and can be associated with tin. If it is related to tin, that's reduced system. If it's related to iron, that's oxide system. So actually, zinc lead can be related to both oxides and related reduced system. Iron also actually, iron can be moderate association with copper, gold, moly, zinc lead. Weak association with tungsten and tin, but it's not absolutely no. There are some of the deposits also have segmentation of magnetite tin scars. Okay, so if we make a summary, and actually we need to have 4 zoning patterns to account for all the metals. There's not a single zoning pattern can explain everything. If there's oxides and strong fractionation in the magma, and then in the intrusion, we can have porphyry, moly, and Grayson type tin, tungsten. In the proximal zone, that scar, it's moly and or tungsten in those scars. and plus minus copper plus minus is I. And then in the distal part, we can have distal moly and distal tungsten and plus minus copper. If it is oxide but weakly to moderate fractionation, this one is more favorable for copper and gold. So in the intrusion, we can have porphyry, or in the scar style, the metal could be moly and or copper. And then in the proximal scar, we can have copper and or I, and plus minus gold, plus minus moly. In the distal part, we can have distal copper and locally zinc lead. Zinc lead and gold will be far distal, more further away than copper. Reduced intrusion, strong fractionation, and that's granite, and that's be inside intrusion Grayson type tin tungsten and tin plus minus tungsten, and the proximal scar mostly tin plus minus copper and plus minus a little bit of iron. And in the distal part, you can also have distal tin, and far distal will be zinc lead. If it is reduced plus weakly to moderate fractionation, in the intrusion, we don't have much example yet, but the proximal scar is mostly gold. And in the distal part, we can have zinc, lead, and gold. So those are the 4 zoning patterns. Then you notice that something gold occurs everywhere. It can be proximal to distal. It can be related to oxide magma. It can be related to reduced magma. So gold is very versatile. And zinc and lead being distal is very well known. But what do you expect to find at the proximal location? And you may want to find a copper, but actually some of the deposits you may actually end up with a zinc tin mineralization. Gejiu 28 million tons of zinc lead, and proximal is 3 million tons of tin. And this is another example, the largest tungsten scar. The red, the intrusion is here, the red is the tungsten mineralization, the green is copper mineralization. You can see actually away from the tungsten mineralization in the distal part, those are mostly copper. So the copper actually is distal to tungsten in this system. Other distal metals at distal location, you can have tin and moly and gold, and so many metals can occur at distal locations. So the final remark is that not one metal zoning pattern can fit all scars. And previously, when we have distal zinc scars, zinc lead scars, and people will argue whether it's related to magma or not. And nowadays, we have several more examples. We can see continuous mineralization from distal copper, zinc lead into proximal mineralization. And the longest one is 4.5 kilometers in China. And this zinc lead scar, you can see is going to the intrusion. So you can be now more confident if you see distal zinc lead scars, it has to be, there has to be a proximal zone, and you should look for that proximal zone, and you may find more deposits. And in fact, indeed, the large deposits, actually, those are the deposits have all the parts discovered from distal to proximal part. Okay, thank you very much. Sorry, I'm a bit over time. Thank you. Bye-bye.
Thank you, Dr. Chang, for the presentation. And we will have questions sessions. And Dr. Chang, are you with us? Just to inform that Dr. Zhao Chang is currently on a mine site in Durango, Mexico, isn't it? Can you hear me, Dr. Chang? Hello. Okay. We'll
yes.
Try to.
Yeah,
okay.
I'm in Mexico, in mine site, about 2.5 hours.
Okay, there are a few seconds of lag. No problem. We will have questions from Pak Arif Idrus. Pak Arif, time is yours. Pak Arif.
Yes, thank you very
Okay.
much. Okay, hello, Joshan, how are you?
Good. Yeah.
Yes,
Nice to meet you.
this is the second time we invite you during for annual MGEI convention. The latest in Bali, 2013. Okay, it was nice presentation from you, giving us more insight, knowledge on SCAN. Okay, I have two questions for you. Firstly, related to the PBZN SCAN, that sometimes is not found or not recognized the presence of garnet. Even this SCAN deposit is very close or adjacent to the interpretative causative intrusion of the SCAN. So what do you think about this? What can be interpreted from this phenomena? So the second question is the presence of silver, according to the mineral chemistry of the galena. In some galena chemistry contains a very high silver and also bismuth. If you compare with the galena and galena in other deposits such as intermediate epithermal sulfidation epithermal deposit, yeah, but we don't have any silver contained by this galena. So what do you think? What the condition actually controlling this differences deportment of silver in galena in SCAN and other deposit type? Thanks, Josan.
Thank you for the questions. The first question is saying if we have the SCAN zone only has pyroxene and no garnet, that case probably because the intrusion itself is reduced. One of the things we could do is use magnet to check whether there's magnetite or not in the intrusion. If you have black metallic mineral, but it's not magnetic, and that's likely to be humanite, and that's an indication that the intrusion is reduced. And if we have reduced intrusion, then wall rock is also reduced, and then the final product will be just dominated by pyroxene and very little garnet. That's a possibility. But some of the systems still have, after well exploration and lots of drilling, you still have a little bit of garnet. It's not 100% no. So if you still see only 100% pyroxene, no garnet at all, and there's another possibility. First, they check the intrusion, the property of the intrusion. Second is in SCAN zones, in SCAN districts, there's typically many intrusions. Some of them are pre-mineralization, some of them are causative intrusion for the SCAN, some of them are post-mineralization. So that's another factor to consider, whether the intrusion you're looking at is the causative intrusion or not. So that's the first question. The second question is silver in lead. This one I'm just starting to work on silver. Previously, I haven't done much work on silver. Right now, actually, is in the silver SCAN deposit. Looking at that, I don't know too much about details, but I do notice there's some regional difference, like the eastern side of the Pacific in Latin America, in Mexico, Peru, Chile, Argentina, there's just lots of silver, not only in scars, but also in epithermal deposits. In contrast, on the western side of the Pacific, Lepanto, far southeast, Batu Hijau, etc., there's just not much silver. So it could be a regional, there could be a regional control whether the magma itself carries silver when the water leaves the magma. So that's just one thought. I'm not an expert on this. Thank you.
Thank you, Zoshan.
Thank you. In the chat column, we have questions from Dr. Jeffrey Hedenkis. Are there any geochemical anomalies associated with the fluid escape structures?
Yes, we have done the analysis at various places. Candelaria, there's in the veins. We analyze both the whole vein, treating the powder plus the trace element using laser ablation and SPMS. One of manganese is one element always shows the peak goes out to a certain distance, then drop out, and depends on the analysis method and also whether the samples are along faults or not along faults. That distance, the peak maximum position, it may be different. Along the faults, it can be further out.
It seems that we have a problem with the connection. We will wait for a sec. Yeah. We are sorry that Dr. Zoshan is already back. Zoshan, we lost you for about 30 seconds. Could you please repeat your answer?
Yeah. In short, yes, there is geochemical anomaly, and manganese, zinc, lead shows the trend, and also sulfur also. Sulfur, we can now analyze trace amount of sulfur in calcite using our laser ablation SPMS. We have a triple quadruple SPMS, and we can do that analysis, and also shows. I think the trend is slightly different, and also rare earths also had a trend. Thanks.
Thanks, Zoshan. Okay, is there any more questions? Okay, we have Pak Muhammad Arba Azaman. Would you like to ask directly to Zoshan?
Yeah, thank you for this opportunity. I'm sorry I can't turn on my camera because of the resolution. Hello, thank you, Pak Zoshan, for your presentation. My question is, but before asking my question, I'm sorry if I missed some part of your presentation. My question is there any ore mineralization in the fluid escape structure?
Well, normally manganese is only anomaly, but in Uchucchacua, the manganese occurs as alabandite and it gets to more than 10%. They are mines, actually. In other places, those will be equivalent of the fluid escape structure or veins, but at Uchucchacua, it blows out and become a mineable and profitable metal.
Yeah, okay. Yeah, thank you.
Thanks.
Okay. Is there any more questions from the audience? We can still have one more questions. Anyone? Okay. If no, I would like to ask to Dr. Zoshan. You said that there are some variation of the carbon and oxygen isotopes in skarn. Is there any possible differences between the, for example, sulfur isotopes? Have you done some research on that?
Yeah, and the sulfur isotopes, we haven't done that. We're planning to do it in calcite. That's part of the reason we also analyze the sulfur content in the calcite, hydrothermal calcite. In sedimentary calcite, in the limestones, there's always we analyze there's always more than 200 ppm sulfur in the carbonate in the calcite, and that one actually is the method for the community to measure the ancient water marine sulfur signatures, the secular change of sulfur signature of ocean, and it's actually based on the measurement of the marine sediment, the sulfur. For hydrothermal one, we now know some of them has, depend on the location, you can have hundreds of ppm, and some places only tens of ppm. Then we send samples to a lab and still waiting for the result and to get the sulfur isotope accommodation of the calcite.
Okay, thanks. Jeff had question. Stable isotope for research. Would you recommend the use on exploration, time, cost, etc.? How about your opinion, Xiaoshan?
Yeah, carbon oxygen isotopes that nowadays you do the analysis in some labs, it's $15 per sample. It's way cheaper than whole rock analysis. So that's a easy way to use. There are different ways of doing the carbon oxygen isotopes, and the easiest way to do is just take a whole rock, including both the veins and the original rock, and analyze that. And it's quick and fast and cheap. Most of the time, the results make sense. It's difficult to see a clear trend, but there's a difference between pure sedimentary versus with hydrothermal signature, and you can have that. Most of the time it works, but sometimes it doesn't work. It's fundamentally is that using stable isotopes, we have to back calculate the isotope accommodation of the water components in the water, and just by doing the whole rock analysis, we are skipping this step when the temperature in a certain temperature range is not a big deal, but if the temperature water form magmatic water and groundwater, then they dissolve so the water itself become a mixture of fluids, and then will calcite deposit auto depends on the temperature. Sometimes the abnormal values of
Okay, thank you, Xiaoshan, for the answer. Okay, we are running out of time, and I would like to thanks to Dr. Jeffrey Hadenquist and Dr. Xiaoshan Chang for the kind of presentation. I would like to wrap up to wrap some notes. First, Dr. Jeffrey Hadenquist outlined the various advanced argillic zonation. And there are several types of advanced argillic zonation. First is steam heated acid sulfate, steam heated CO2 rich, hypogean acid sulfate, chloride, vapor condensates, cooling of magmatic hydrothermal fluids, and supergene oxidation of pyrite. And it is important for us, for the mining company, to understand what type of the advanced argillic minerals, as it will guide us to the discovery of the deposits. And the second presentation from Dr. Xiaoshan Chang outlines the metal zonation and mineral variation in skarns, and we can learn that several skarn can be formed under oxidizing condition, and several others are in reducing conditions. There are several factors, including the redox states, causative magma, and wall rock. And again, we would like to thanks to all keynote speakers. And I will return this stage to the master of ceremony, Mbak Rahma.
Thank you very much, Dr. Andi Yahya Al-Hakim as our moderator, and also to Dr. Zhaoshan Chang as our keynote speaker. And now I would like to invite Dr. Arifuddin Idrus, Secretary General of MGEI, to give a memento of appreciation virtually, first to Dr. Zhaoshan Chang. All right, gentlemen, I will count from 3. 3, 2, 1. Thank you very much. And now we would like to give the token of appreciation to Dr. Andi Yahya Al-Hakim as our moderator, which will also be given by Dr. Arifuddin Idrus. All right, gentlemen, please look at the camera, and I will count from 3, 3, 2, 1. Thank you very much. Thank you very much to Dr. Zhaoshan Chang, Dr. Andi Yahya Al-Hakim, and also to Dr. Arifuddin Idrus. And now we would like to take a group photo of the 3 of you. So could the moderator please display all 3 monitors? All right, and now we would like to take a group photo of everyone here. Could everyone please look to the camera? We will take several photos because there are several slides here. All right. Is everyone ready? Okay. We'll take the first photograph. 3, 2, 1. Okay, thank you everyone. And now we will go to the next slide. 3, 2, 1. Okay, thank you everyone. And now on to the next slide. 3, 2, 1. Okay, one more slide. 3, 2, 1. Okay. I think that is all for the group photo. Now I would like to thank Dr. Zhaoshan Chang as our keynote speaker, and also to Dr. Heidenquist as our first keynote speaker, and also thanks to Dr. Andi Yahya Al-Hakim as our moderator for this session. And now, before the break, we would like to invite everyone here to participate in our booth exhibition. This exhibition will include our sponsors and also our student chapter research poster, which you could look and check things out. Before we end this session, we would like to thank our sponsors. Starting from our Superbite sponsors, PT Geofix Indonesia, PT Merdeka Copper Gold Tbk, PT Petrosi Tbk, and our Gigabyte sponsor, PT Antam Tbk, our Megabyte sponsors, PT Agincourt Resources, PT Aman Mineral Nusa Tenggara, PT J Resources Nusantara, PT Nam Sumaluban Abadi Sumacorp, PT Rekabuana Penjuru Mineral, and PT Sumbawa Timur Mining. Our Kilobyte sponsors, we have PT Eksplorasi Nusa Jaya, Minerba Indonesia, PT Greenland Resources, Harita Nickel, PT Indodrill Indonesia, PT Nusa Halmahera Minerals, and PT Tima Tbk. Our workshop sponsor, Sequent Limited. Our other sponsors, PT Medco Energy Mining International, and PT Minevesting Resources Indonesia. And of course, last but not least, our media partner, Dunia Tambang. To our sponsors and media partner, we sincerely thank you for your support in making this event happen. We will now take a break for a few minutes. Please do not go away and stay tuned for the next sessions.
Salam MGEI dimanapun Anda berada. Nama saya Noel Pranoto dan saya sehari-hari bekerja sebagai geoscientist di dunia pertambangan. Dalam kesempatan ini saya ingin berbagi sepintas mengenai program Fresh Graduate Mentoring yang dilakukan oleh Masyarakat Geologi Ekonomi Indonesia atau MGEI. Seperti banyak lulusan geoscientist pada umumnya saat kami kuliah dan baru lulus dulu, gambaran sebagai geoscientist itu sangat menawan, apalagi buat mereka yang menyukai perjalanan, kegiatan di alam bebas. Ibaratnya kami bekerja dan jalan-jalan, melihat banyak tempat di Indonesia dan bahkan dunia ya. Namun atas biaya perusahaan, ya siapa yang nggak mau ya. Namun setelah sampai 1-2 tahun bekerja, ya ternyata realitasnya tidak hanya seperti itu dan terus terang saya kaget. Ternyata gambaran yang indah itu cuma penggalan kecil aja dari tuntutan nyata pekerjaan sebagai geoscientist. Mulai dari pekerjaan di lapangan, lalu kemudian menulis laporan, menyusun program dan anggaran, menjual ide atau presentasi, hingga harus memimpin tim kerja dan juga melakukan banyak-banyak hal yang sama sekali baru begitu. Nah, repotnya lagi hal-hal seperti ini tidak kami dapatkan secara terstruktur dan sistematis di bangku sekolah. Nah, untunglah pada saat itu kami memiliki atasan atau senior-senior yang mau mementor dengan sabar dan penuh dedikasi. Tentu saja di samping itu perusahaan juga memberikan resource untuk kami yang baru-baru lulus ini untuk bisa belajar sambil bekerja. Nah, berbekal kisah nyata yang berharga ini gitu ya, dan pengalaman di organisasi yang lain, kami bersama kawan-kawan di kepanitiaan MGEI memulai suatu program Fresh Graduate Mentoring di MGEI yang menyasar pada lulusan geoscientist dan mereka yang baru memulai karir di dunia eksplorasi dan pertambangan. Tentu selain meningkatkan kompetensi ya, dan menjadi ajang sharing dan learning antar generasi geoscientist, program ini juga bertujuan membangun jaringan yang berkelanjutan antara mentor dan mentinya di dalam mereka meniti karir. Batch pertama ini tentu saja banyak hal yang kami harus benahi. Kami belajar ada hal-hal yang waktu itu kami lupakan atau kami kurang begitu ya. Namun tujuan kami adalah progress, bukan perfection. Saya yakin sudah banyak hal positif yang telah dilakukan oleh para mentor dan mentee dibanding saat kita memulai program ini di awal tahun 2021. Akhir kata, saya mengucapkan terima kasih untuk para mentor dan mentee, khususnya untuk rekan-rekan yang sudah mendedikasikan waktu, tenaga dan pikiran untuk mewujudkan fresh graduate mentoring program ini. Saya yakin para mentor, mentee, dan panitia ini telah menjadi bagian dari tonggak sejarah dalam usaha kita untuk terus meningkatkan kemampuan biosaintis Indonesia di dunia eksplorasi dan pertambangan. Salam MGEI.
Halo semuanya, nama saya Dina Durardi. Saya adalah HR profesional yang saat ini bekerja di salah satu perusahaan tambang batubara di Indonesia. Saya pernah mengisi salah satu program FGMP. Topiknya pada waktu itu adalah Successful Interview to Score Your Dream Job. Ketika pertama kali saya di-approach oleh Mas Nol, yang juga pernah menjadi rekan kerja saya di perusahaan sebelumnya untuk mengisi sesi ini, saya tentunya sangat excited. Karena selain dapat membantu FGMP, saya juga memiliki passion untuk terus memberikan kontribusi sosial di luar kontribusi profesional saya di perusahaan. Pemilihan topik dalam proses mentoring menurut saya juga sangat tepat, karena dengan menguasai proses interview, tentunya bisa mempersiapkan mereka untuk memasuki dunia kerja secara lebih mudah, hal yang mungkin tidak mereka pelajari pada saat di bangku kuliah. Secara keseluruhan, MGEI menurut saya merupakan salah satu wadah yang sangat powerful dan barangkali perlu dicontoh juga oleh mereka yang berasal dari disiplin ilmu lain. Saya yakin program-program MGEI ke depannya akan lebih banyak dan lebih menarik lagi. Wadah ini saya percaya ke depan akan semakin solid dan bisa menjadi support system yang terus berlanjut, di mana anggotanya bisa terus melakukan sharing knowledge dengan pengalaman kerja di perusahaan masing-masing. Salut saya untuk MGEI dan sukses terus ke depannya. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. Saya Agaton Chandra Setiawan selaku mentor untuk bidang hidrologi dan hidrogeologi kegiatan FGMP MGEI tahun ini. Bagi saya, peran mentor cukup penting untuk kegiatan kali ini sebab dapat memberikan wawasan dan pengetahuan di dunia kerja bagi para mentee yang merupakan pelaku baru dalam industri eksplorasi ataupun pertambangan. Lalu wawasan dan pengetahuan ini dapat berupa teknikal ataupun non-teknikal. Dan sehingga harapannya para mentee dapat lebih cepat untuk beradaptasi. Seperti yang kita ketahui di mana dunia kerja dengan dunia kuliah tentu sangat jauh berbeda. Hal inilah yang kami harapkan selaku mentor agar dapat memberikan seluruh wawasan dan pengetahuan yang kami mungkin hanya lebih dulu kami dapatkan pada pengalaman kami di dunia kerja. Lalu bagi saya kegiatan FGMP tahun ini cukup baik dan cukup positif baik para untuk mentor ataupun untuk mentee itu sendiri. Sehingga harapannya di tahun ke depan dapat dilanjutkan dan dapat terus dilakukan evaluasi perbaikan sehingga baik mentor ataupun mentee untuk di kesempatan selanjutnya mendapatkan manfaat tentunya. Salam dari saya. Assalamualaikum warahmatullahi wabarakatuh.
Halo semuanya, perkenalkan saya Salma. Saya adalah salah satu mentee FGMP batch pertama. Saya merasa senang dan merasa tercerahkan setelah mengikuti mentoring ini karena saya dapat mengukur perkembangan saya juga dapat menentukan smart goal saya, dan saya juga merasa beruntung dan merasa bersyukur dipertemukan dengan mentor saya yang hebat, yaitu Pak Wesley Randa yang telah sabar mengajar dan membimbing saya melalui tugas-tugas, diskusi-diskusi, atau sekedar sharing-sharing pengalaman beliau tentang karir, tentang on-demand karir misalnya. Dan saya berharap untuk FGMP batch selanjutnya bisa dieksekusi secara lebih baik lagi dan komprehensif dan bisa menciptakan program mentoring yang aktif dan komunikatif.
Welcome back, everyone, from our short break. And in this second session, the topic will focus on mineral conservation for sustainable mining. This session will have 3 speakers. Our first speaker, Bapak Denny Lesmana of Nusa Halmahera Mining, who will be speaking of ore conservation from the utilization of Gosowong tailing. Our second speaker, Bapak Janjan Hertiana of Agincourt Resources, who will be speaking of mineral conservation scheme at Martabe Gold Project. And our third speaker, Dr. Ferian Anggara of Universitas Gadjah Mada, who will be speaking of valuable elements in coal, current and future trends. We first would like to deeply apologize of our moderator, who is previously Bapak Andri Budiman Firmanto of Directorate General Mineral and Coal. He is currently unavailable to attend due to government affairs. This session will be moderated by, again, to Dr. Andi Yahya Al-Hakim. To Dr. Andi Al-Yahya, apologize, to Dr. Yahya Al-Hakim, the time is yours.
Thank you, Mbak Rahma. Good morning to all of the distinguished speakers here. We have Pak Denny Lesmana, Pak Yayan Hertriana, and also Dr. Feren Anggara from University of Gadjah Mada. First of all, I would like to read the curriculum vitae of Pak Denny Lesmana. Okay. Pak Denny Lesmana currently works at PT Nusa Halmahera Minerals. He graduated from the, so it is not stated here. He has a bachelor degree of geology and postgraduate student in management. And currently, he has worked in PT Nusa Halmahera Minerals. Previously, he has been working in PT Bumi Makmur Selaras. And he has a professional background as an exploration geologist in nickel, copper, coal, and gold, and also production and resource geologist, and also in management area. His recent publication is Grade Control Sampling QA/QC in High-Grade Gold Mines, and also core scan application in mineral exploration, case study at Gosowong, North Halmahera. Pak Denny Lesmana, time is yours.
Thank you, Pak Andi Yahya. Assalamualaikum warahmatullahi wabarakatuh. Good day all. It's lunchtime in here. My pleasure, an honor to meet you here in virtual 13 MGEI Annual Convention 2021. Thanks for the opportunity for inviting us to give presentation about ore conservation from utilization of Gosowong tailing. At the moment, I will accompanied by Pak Tommy Octaviana, who is a project manager in Gosowong. So, can you show the slide, please? Okay, next slide, please. Next slide. Okay, as you know, the PT Nusa Halmahera Mineral Gosong is contracted of work amendment signed in 25 June 2015, and also PT Nusa Halmahera Mineral, as you know, that for the information, has been divested to Indotan Halmahera Bangkit from Newcrest Mining Limited. So it's 75% all share is right now is belong to Indotan Halmahera Bangkit. We also full permitted, and also we get some award as well. So next slide, please. Next slide. Okay, PT Nusa Halmahera Mineral is a gold mine located in Gosowong, North Halmahera Regency, North Maluku Province. The mining activities at Gosowong began in 1999, and currently Enheim operated two gold mines, Kencana and Togurachi. The ore from mine are processed in processing plant that produce ore as a product and tailing as a waste. The tailing are then transported and stored in the tailing storage facilities. Next slide. Gosong has strong foundation, a history spanning more than 20 years of exploration, discovery, and mining, resulting in constantly improving understanding of geological, geochemical, and geophysical characteristics. Since 1999, mining up to now, Gosong still grow with the cumulative metal endowment to 7.24 million ounces of gold, and a very significant opportunity for mine life extension. The one strategy to extend the mine life and sustainable operation is conservation minerals by reclaim and reprocess the tailing high-grade ore on the TSF. Next slide, please. So the background why we reclaim and reprocess the Gosong tailing as the ore conservation, first, based on the regulation of Minister Energy and Mineral Resource number 26, 2018 about good mining practice implementation and mineral and coal mining supervision. In Chapter 1, Article 3 and 4, we obligate to carry out implemented the good mining practice by making effort to conserve mineral and coal. And also in Article 24 and 25, we obligate to carry out mineral and coal conservation effort by planning and implementation, mining and process recovery, management and utilization of low quality coal or low grade mineral, management of byproduct minerals, tailing of slag and marginal reserve, and also the documentation of unmined mineral and coals. So the second background is the Gosong TSF deposit is high-grade tail during 2006. So the 2006 tailing deposition in the TSF, which is high-grade mill process and low recovery. We can see on the graph along the period, the spike in the tailing grade occurred due to the introduction of Kencana underground ore in early 2006 until process plant upgrade involving the installation of tertiary grinding or vertimill, providing a finer green capability, and it was completed in late 2009, and then after that a SAG mill circuit and also installed. So during June 2006 to mid 2009, there was an estimated 1 million ton of tailing gold grade with the average 2.7 gram per ton in the TSF. This is based on the mill data. In the mid 2009, the processing plant installed a pretty mill, which dramatically improved gold recovery. So after 2009, the tailing gold grade dropped to 0.7 gram per tons. Next slide, please. So PT NHM have two existing tailing storage facilities. The old TSF, which had been stopped operate since 2017 and almost dry, and new TSF West Extension, we call TSF WEX, which currently used to disposal tailings. Next slide, please. To confirm the deposition on TSF that carrying high grade need geology investigation and study. First, we need a drilling because the TSF is a special and unique area, different with the other area to build a drill pad. So we build a causeway over a high grade deposition zone. First step, sampling from the drill core in 2010 with 23 holes completed. With the interval drilling 20 by 20 meters, and by the interpretation from the drill hole data, the grade was confirmed with the new data. So the outline initial calculation is around 650,000 tons, with the grade is 2.9 gram per tons. But then only 266 tons. Please. Previous slide. Okay, but only 266 kiloton that we can reclaim the tailing on the TSF, and we put into a drill pad stockpile in the TSF area, and the average sample is 2.4 gram per tons. Next slide. After the uplift TSF project and redeposition tailing on TSF, we conduct second step drilling for sampling all TSF area in September 2017 to March 2018, which were completed 79 holes. This is including 13 holes, geotech holes, by interval drilling 50 by 50. The average depth is around 22 meters, and the minimum and maximum depth is around 10 to 30 respectively. The average core recovery is 88% with minimum recovery 40%. Sample were taken at 1 meter interval in poor core. The sample were analyzed for gold, silver, arsenic, zinc, antimony, molybdenum, and sulfur. Gold and silver analysis on-site lab, while the other element we analysis to outside lab. We complete also geotech study for potential tailing remaining at the TSF by consultant in August 2017 to March 2018. The study include assessment of characteristic the tailing material in terms of variability of engineering properties for settlement and stability. Next slide, please. So to know how much the potential resource, we then create the resource model estimation, the TSF gold, silver, and copper block model estimate using nearest neighbor estimation methodologies, and we make two domain and code for the area which were not mined and mined in 2011, then redeposition. From the estimation, the Gosong hybrid tailing mineral indicated resource is accounted to 1.9 million ton at 1.9 gram per tons. This is equal to 120,000 ounces of gold. So next slide, please. So the feasibility study for mining TSF high-grade tail has done in December 2020 by a consultant. The mining design limit is 80 meters distant from dam wall embankment, and the safety bottom cushion is 3 meters from the original topography as consultant assessment and recommendation. For the mining method, we're using conventional mining by utilize truck and excavator. Next slide. As we will mine on the TSF, which has special material properties, as you know, can you can see in here on the graphic, this is analysis of ground pressure of equipment, truck and excavator, which is the allowable bearing capacity exceed the ground pressure for TSF. So to prevent the subsidence of the equipment, we need the engineering control to support equipment can fit work above the ground of the TSF by creating the access using press waste rock from underground. This is for permanent or semi-permanent access, and Durabase below the waste rock sitting. Also on the open pit mining, as the open pit mining, we need always available pump to manage or to control the water runoff on the lower level. Next slide, please. And this is the section looking the high-grade tail position, mainly the high-grade distribution located in south middle of the TSF area and the deep between RL 31 to 45. Next slide, please. Next slide. So to mine the lowest level of high-grade tail in RL 31, the gradient of slope must be 10%. The excess with igniter by using press rock material sitting and Durabase. The loading point on RL 31 must install pump at the lowest area to manage or control the water runoff, and still using the waste rock material and Durabase. Because the lowest level of RL 31 is the boundary between high grade and low grade or waste material, so that we need to control when mining to avoid additional dilution. Next slide. So this is the figure showing that the boundary area of 80 meter pit limits from the dam wall embankment, as the upstream has undergone 2 times uplift. Its uplift is 5 meter height. This is for wall stability. So for the next slide, Pak Tommy Octaviano will present it. Pak Tommy, please.
Okay, thank you, Pak Denny, Pak Andi. Hello. Hello.
Can hear you, Pak.
You hear? Okay. Okay. You hear? Okay. Okay. Thank you. All right. Let me introduce myself. My name is Tommy Octaviantana. Now I'm here for accompany Pak Denny for explaining about the processing for the remaining tailing and recovering the tailing. Okay. Next slide. The PTNSM seriously decided to follow up and to planning to recover this high-grade tail deposit, which is we set up we set that initial objective to probably estimate minimum can be reclaimed about 50% from 1.9 million ton, with the high grade is 1.8, and the processing recovery minimum around 70%. Let I brief again why the tail deposit occur in the TSF Gosong. Maybe Pak Denny already mentioned before that during the 2006, the ore characteristic is changing. The size of the metric gold is become finer. It's below 45 micron. So it's but our processing plant is still don't have the regrinding or resizing size product below than the 45 micron. That's why the metric gold still not liberated and then went into the tailing dam. So in the late of 2009, the NSM has already installed the tertiary mill. So this is for the more finding the regrind of the sizing, the product to around PXT 30 micron. So it's from that time, the final tail go gradually down and recovery come back to the normal again. Okay, next. This is the metallurgy study that we already conducted. It's like a perform standard metallurgy analysis, such as this diatoxic leach, and also the size distribution test. It can be seen that about 74.2% could be processed by regrange and then CIL to get the recovered again the gold from the tail. Is the sample of the tail is or pardon?
Tommy, I'm
yes.
sorry to interrupt you. There's some noise that we heard. Could you please modify your microphone, please?
Sorry.
There's some noise. Could you please try to speak again? Yes, now it's better.
Still noise?
No, now it's better.
Okay.
Please go on. Thank you.
Okay. Continue. Sorry for the interrupted. Okay, so in this from after metallurgy test showing that about 80% of the material have size less than 20%, and then about the 20% the oversize is so it should be resized prior to the process CIL. Next. Currently, our existing processing plant in SM is still Maricore system, which is a conventional precipitation recovery system. So this system is suitable to be applied for the high-grade gold ore and low sulfide material. While the low-grade contain high sulfide, it will be more effective if using the carbon in leach system. The gold recovery will be better, and then also the gold purity of the bullion will be also better. That's why we have some kind of the option for processing to get in the future. We have some option. We have these three options there will be explained in the next slide. Please next slide. Yeah. Okay, this is the first option, which is we're going to standalone mill process for the tail only. So we build new processing plant with only process tailing with CIL system, and then the existing plant still process the ore from the mining. But for this option, we have consideration. So probably it will be big capital and OPEX, and also the manpower also will be increased. And then, but for the positively, for production, probably not interrupted because during construction it will be standalone. Next, this is the second option. Second option is we upgrade our mill existing process to about doubling the tons until to 180 tons per hour, and they converted their back-end circuit with the CIL system. So all low-grade and high-grade tail feeding into this upgrading 616 plant with blending, and then for this positively the capital cost will be a bit lower from the first option, and also the OPEX and the manpower will be lower than that. Next, the third option is we try to reduce or remove it the low grade is in the top of the high grade tail in the tailing dam to the other area. So that's we call that maybe in the landfill area, and then the existing processing plant will upgrade it to, sorry, that's wrong, should be a 120 ton per hour, and then convert it to CIL with feeding, blending about 1 high-grade tail with 1 ore from the mining. With these considerations, the lowest capital will there, and then probably will get the highest percent recovery. But this have negatively, probably there's come interrupted when the production, and also for the permitting when we removing the low grade material. So this quite because the tail is still the hazardous material, so it will be a kind of a challenge for that. Next. Yeah, all the option is still under in the detailed study, and economically also the optimally for the benefit and timelines, and also the effectiveness of that or the option. And here maybe you can look at the from the 3 options, I put it the DST. It's just intermezzo for you guys all, that the ST is dry stack tailing, which is the latest tailing disposal system that we plan to implement it at NHN as a replace for the tailing storage TSF, called the tailing disposal system. So broadly speaking, that dry stack tailing is the slurry tail from the process plant, which is deposited, and then it's filtered by the filter press. The result is the material tail dry with the water content about 15%, while the filtered water will be returned back to the processing plant to reuse again. Some of the advantage of this DST system, it will significantly low capital cost compared with if we build new dam or uplift tailing dam. Also more safely, because the risk of the dam failure and also the geotech risk could be minimized. And then also the big opportunity, we can use the dry material from tail. We can as a backfill test or to underground or other purpose, like make it some paving block or something like that. All right, so I think that's all the presentation. Thank you very much.
Thank you, Pak Denny Lesmana and Pak Tommy Octaviantana for the presentation. And to all attendees, hold your questions. We will have presentation from Pak Yan Hendriana, and then is followed by the presentation from Dr. Feren Anggara. Okay, Pak Yan, are you with us?
Yes.
Okay, please, I would like to read the curriculum vitae of the Pak Yan Hendriana. Pak Yayan Hertriana. Okay, I'm sorry for the interrupt. Okay, Pak Yayan Hertriana graduated from Teknik Geologi, Institut Teknologi Bandung. He has been working as a principal geology operation and mine geology at PT Agincourt Resources. Previously, he works as a superintendent to senior manager resource development in PT Agincourt Resources, and his professional background is as a registered competent person in Indonesia for exploration and mineral resources for gold in MGEI, AUS IMM, and then MGEI, IAGI, and Perhapi. And the recent publication is Progressive Management of Acid Mine Drainage, if I'm not mistaken, RIS, during construction of an integrated waste storage landform, a case study at Martabe Gold Mine, Indonesia. Okay, Pak Yanhan, you have 20 minutes and time is yours.
Thank you, Pak Andi, and thank you also for the committee to invite us on this event. It's very honor for us. Okay, we can start the presentation. Yeah, today I would like to present basically the mining conservation scheme at Martabe project. This presentation is compiled by us, basically it's not by myself. Just myself, and then Pak Atul Tambunan, he is the metallurgy manager, and then Dennis Litana, senior geologist for the control. Next, please. And Pak Atul will assist me if there is some question in regard to the processing. He's on the way to his home, but he's keen to help me to assist if there is any question on the processing side. So in general, Martabe is now is in North Sumatra. It's not Martabe project is North Sumatra. It is covered somewhere in 1990s by Greg sampling. Basically, it's Normandy conduct the regional other things. So the mineralization is located along the Sumatran Fault. This is the half sulfidation, and until June 2020, the resource is about 7.6 million ounces of gold and 66 million ounces of silver. And the reserve is about 4.3 million ounces and 33 million ounces of silver. So far, we have the 6 known deposit within the 6 to 5 kilometers square, which is the largest in Purnama. So production commenced from mid-2012 after 2-year construction and processing via CIL. The mill capacity basically is originally is 4.5, but it's ramped up to 6.7 in next year. And the last production, last year production is 0.3 million ounces gold and 2.3 million ounces silver. So that's we have still remain 14-year life of mine. Next, please. Please, next. So as we know in the geological side, we are in the dome complex basically. As we see in the color, the map is the coloring. The Dasit dome complex in with the color of the light blue, and the sediment in the brown. So the trending of the mineralization basically mostly is in northeast to northwest trending structural control. It's just for the introducing. I'm sure everybody, most of us already knows what this. Okay, next please. This is the current view of our site. This is Purnama pit, looking to the southeast. Yeah, we are very restricted the area, so the mill basically just beside the our pit Purnama. Yeah, the Purnama pit is start in mining in 2011, and then following by Barani on 2016, and then after that Slambagor in 2018. So that's the pre-pit we operate now, and the other two the other pit the other reserve basically we have in the north is Toru Ala, That's hopefully in next 2 years we already start the mining of that pit. Next, please. Define the martabe basically based on the economical value. So the economical value basically is the measure of the profit or the revenue that's after reduced by mining costs, processing costs, and refinery costs. On site, basically in martabe, what we call is FE1. So based on the regulation, we also have to conservation of the mineral waste, which is we measure it's like 20% above the current assumption gold price. Usually we call it FE2. In summary, we can call FE1 is if the FE1 is more than 0, that we call OR. If FE1 below 0, but FE2 above the 0 value, that's what we call the mineralized waste, or by the government rule they call lower grade. And then if revenue both FE1 and FE2 is less than 0, we call the waste. So that's very simple. And in the right hand side, that is the parameter of the pit optimization. Basically, a lot of factor over there, but so far that is we can apply it very well. So marginal cutoff basically with the our current economical value basically we apply 18,500. Sorry, 1,850 $1,850. That is equal to cut-off grade about 0.4. Next, please. Mineral conservation strategies in our site, basically we have divided into two, which is mining and processing. So the mineral strategies, what we apply basically is try to maximizing the throughput by managing crusher throughput, and in processing we try to reducing mining costs and reducing mining and processing costs to improve the economical value in block model. In the mining, we improve on the block model, it aiming to reduce the ore loss and dilution within ore and waste boundary. And also we control the blast movement. The other thing is maximize throughput to allow low grade ore and the low grade ore or mineral waste ore and some exceeded associated mineral to crush. Basically, what our strategy is in-pit blending, so reduce the ore handling cost, so it will reduce the cost handling, and also we apply the ore blending to throughput, and the rest of the mineral waste or low grade ore that will stockpiling in long-term stockpile. In processing costs and in processing, we improve plant capacity to process more refractory ore and reduce processing costs, which is first we install the secondary crusher in maybe 2015, and right now we have to install vertimill to improve the throughput capacity, install oxygen sear, and also the other one is install resin. Okay, next please. In mineral conservation, basically this is the ore flow or flow handling. What we are improved basically in the rerunner block model, reserve block model, basically by the infill drilling. And then we put in blast movement control, and then we apply the ore blending strategy during excavation and delivery ore to throughput. And also we stockpile the mineralized waste or the low grade. Next, please. So this is the improving the block model. So the grade control pattern is about 6.25 to 12.5 meter drill spacing, with drills set up minus 60 to depth of 12 meter depth, and using the archery for sure. In the grade control, basically we rerun all the resource and reserve estimate parameter. So there is some adjustment for sure because of the property of the grade control is different with the resource, such as like drilling spacing and maybe some smoothing on the domaining. Okay, next please. In the reconciliation, we apply, we reconcile basically between declare or mine to grade control and also to reserve. So there are two part of the 2 points that still need to be reconciled every month. Basically, so far our reconciliation DOM to grade control is very close. It's about 2%. And the grade control, declare or mine to reserve is still very good. It's about 94%. So there is some improvement, about 3% between grade control to reserve. Next slide, please. So the ore blending to maximize the throughput, basically we handling the, we have to be consider about the mill constraint. We have a mill constraint due to the delivery ore, which is silver and better is less than 20. It is copper cyanide is less than 130 ppm or gram per ton, and PLI is roughly is between 5 to 7. And also the we need to manage clay content and potential viscose in the leach tank. There is some about 7 basically or categories to be blend in every day, to be looked after by us, from a low grade, medium grade, high grade, super high grade, and also problematic ore which is exceeded on silver, copper cyanide, or what is more exceeded usually. Compared to the Kosowong, the grade is not really high in Martabe, so the 2.5 is we call high grade, but maybe in slight seen in Kosowong 2.5 is going to the tailing in the past. But we are very good now in here. Okay, the picture it is showing the block model basically, and what is the what we call the variation of ore in field that we install by the flagging tape, and also the blending we always put in on the board in the ROM, basically, so everybody is now what's the blending, what's the ratio of the ore that will be delivered to the crusher. And below is the table that we produce every day to inform field assistant and operator in the field in regard to the ore ratio. The target is on the ore delivery. Basically, we targeting 90% or 85 to 90% direct tipping. So basically, we must do the in pit or blending. Next, please. As mentioned below, with the blending, what we are talking about, the ore that exceeded is like copper more than 300 or maybe more than 500, which is exceeded to be solely sent to throughput. We are blending to be able to process properly. And however, some ore maybe cannot be go right to the mill because of the blending is not what is enough to do, so we can put into the long-term stockpile, especially for the low grade or the mineralized waste. If there is some exceeded volume, so we can put into the long-term stockpile. Next, please. The other on the conservation side is a blast movement control. We have basically blasting. We always have achieve the optimum fragmentation, but we need to be minimal movement. That is not always happen because the property of the rock. But we need to be control on the movement. And the other thing, because of we cannot prevent any movement, so we need to measure movement after blast. Last year we have assessed 3 ways, basically 3 indicators to measure the post blast movement by using software workflow between the smart vector, which is basically comparing pre-blast topography to post-blast topography, and also if there is any special case, we put in the blast vector index by installing polypipe or BMM. In right hand side, there is the when we installing the PVC polypipe installation, we put in the coloring the pipe and also the gravel to be more easier when we trace up after blast. And also we have put in the EMM device with the detector. This is sophisticated technology, but for sure it has additional cost for that. The input of the 3D, basically we need the in situ blast control model, pre and post blast topo survey, blast hole color and timing, and also the blast sign attribute such like powder factor, stemming, hole size. And again, if there is some case such like chaotic area, choke front face, high PF, PF means powder factor, so we need to be put in the polypipe or the BMM. Next, please. This is just example. There is not too much movement in this basically in this case because it's very ideal. We are comparing between BMM, BVI, polypipe, and smart vector. There is some improvement. Basically, the BMM for sure that is more valuable to this with the other, but we have to be compared the cost. So basically, we are trying to select which one is need to be put in BVI, polypipe, or just applying the smart vector with it, which is comparing the Infoco before and after blast. Next, please. Okay, in mineral processing, some improvement is applied. Okay, before that, the white box, basically that is the original setup of the plant. So in yellow one, we are putting some adjustment to improve the mill performance. Firstly, in about 4 or 5 years ago, we are putting the secondary crusher, which is increasing tonnage from 4.5 million per annum capacity to about 5.9 million per annum capacity to crush the ore. But after that, the bottlenecks in the processing is in SAG mill or ball mill. So the solution is we install again vertimill in this year, basically, and then starting Q4, we are using a vertimill. And we have some improvement also in the CRL. We are putting the oil oxygen seal reactor, and the last one put in the resin plant, which is to recycle the or to recover the cyanide that we consume in the CIL. Okay, next please. So the mill capacity basically is the aiming is to increase grinding capacity. It's, this is to improve the milling rate from 840 ton per hour to 770 ton per hour, or we can improve the capacity from of the mill from the 5.9 to 6.7 ton per annum. So it's about more than 10%. And also the good thing is it still maintains distribution of the size to 150 micron. And also that is some opportunity. We can increase the sizing distribution to be more finer to get the silver, better silver recovery. Let's look at to the graph below. The capacity of the mill is increased during the time. In 2016, we just have 4.3 thousand, and increased to 2020 to 5.1. Yeah, to 2020 it's 6.1 thousand or 6.0 mil, and hopefully in next year we can increase again to 6.7. Okay, next please. So we install also in processing the oxygen seal reactor. So it will improving a gold recovery. It means we can put in more sulfur content to the meal. So with this we put in this equipment, we can make it we can the efficiency of mixed oxygen will be increased, and also efficiency mixed oxygen and cyanide will be increased, and also that is the one basically improving on the gold recovery. As we now down deeper, the gold recovery is decreased due to the increase of sulfide sulfur. So that is what is naturally when we are going down, the sulfide sulfur is getting increased, and the ore is getting more sulfide than oxide. Next, please. The last one is we install the resin plant, basically under commissioning now. The resin plant is aiming to recover cyanide from the process plant. So the cyanide consumption will be reduced. It's been reduce the cost for the, to buy the cyanide, to purchase the cyanide. And also the other impact is we can save some copper from the tailing. The copper is we are not selling yet copper. But some copper is already there, so we can we are try to harvest sometimes in next month. Again, we would like to emphasize that reducing we are in plant basically in mill. We are trying to reducing processing costs, so we can improve the block model. It means we can make some waste to be ore. Some waste to be ore. Okay, next, please. This is the summary. So the improvement Martabe is continue in for last couple of years. Basically, and it's very supportive, aligned with the government policy on mineral conservation scheme that aiming to have an optimum gain of the recognized mineral resource and all reserve. In mining, the mining reconciliation is within acceptance tolerance and blast movement monitor was implemented. Our blending practice has applied for years now to let some lower grade or mineralized waste or refractories ore being able to be processed. Improvement in processing is to enhance metal recovery, mill throughput, and recycling cyanide. That improvement will reduce the processing cost that will impact to better economical value in reserve block model. That's all I think, Pak Andi. Thanks.
Thank you, Pak Yanyan, for the kind presentation. Again, please hold your questions. We will have another session from Pak Dr. Ferian Anggara, and I would like to read Pak Ferian Anggara CV. So from West Indonesia, from Gosowong, we moved to Agincourt, to Martabe, and now we will have a session related with the elements in coal. Could you, yes, I can read the CV now. Yes, Dr. Ferian Anggara graduated from geology in UGM, and his educational background during 2011 until 2014, he earned his doctorate degree from Kyushu University, and currently he is a lecturer in the geological engineering program in UGM. And the recent publication from Dr. Ferian Anggara is the characterization and mode of occurrence of rare earth elements and yttrium in fly and bottom ash from coal-fired power plants in Java, Indonesia, International Journal of Coal Science and Technology, and also from 2021, study on rare earth elements leaching from magnetic coal fly ash by citric acid, and also there are some publication xenosphere characterization from Indonesian qualified power plant fly ash and their potential utilization. And now time is for Pak Ferian Anggara. You have 20 minutes presentation and is followed by the discussion. Thank you. Time is yours.
Thank you, Dr. Yahya. Let me share my slide first. Could you please see my slide?
We can hear your voice and your slides is clear.
Okay, thank you. Good afternoon, everyone. Thank you for this opportunity. On this occasion, I would like to share our thoughts on valuable element in coal, a case study of rare earth element and yttrium in Indonesia coal and coal ash. My name is Ferian Anggara, as introduced Dr. Yahya. I'm from Department of Geological Engineering, Universitas Gadjah Mada. And actually my presentation is kind of overview of our current research on coal and coal combustion product in Indonesia. So actually the outline for today's talk, including introduction and objective, valuable elements in coal, rare earth element in coal and coal ash, case study, outlook, and closing remark. Coal-fired power plant take up to 50% electricity generation in Indonesia. Even though there is a new policy from the government regarding with the new coal-fired power plant installation in 2030, but the existing coal-fired power plant will generate fly ash and bottom ash, still generating fly ash and bottom ash. And another thing is, since the Indonesian government are also implementing a new policy to stop exporting raw material, there will be a new smelter projects, meaning that there is new electricity is needed. And as we all know, coal-fired power plant are the easiest and fastest way to generate electricity. So again, not only fly ash and bottom ash, but also coal combustion product will be produced. The current utilization of coal in Indonesia is mainly for direct use as power plant. However, there are many options for coal to give added value in the utilization, from petrochemical humic acid with increasing demand recently, metallurgy industry for sure, and others for unconventional energy resources. However, as today's talk, we are discussing about the valuable elements in coal and coal ashes, then the other added value in the coal and coal ashes will be discussed in other occasions. Actually, valuable element extraction is conducted from the coal ash that are enriched due to the reducing volume by the combustion process. So actually, we extract the coal, the valuable element is from coal ashes. The other main controlling factor for valuable element extraction from coal ash is high concentration of valuable element in the feed coal itself. So suitable geological condition in the coal-bearing sedimentary basin in Indonesia is becoming one of the important issues. And we already may know that the main producer for coal basin is in Sumatra and Kalimantan. So our sample are mainly from those two areas, and fly ash and bottom ash is coming from the power plant in Java. Next, we will discuss about the valuable element in coal. Valuable elements in coal are classified into several categories, and rare earth element and yttrium, based on Dye and Finkelman 2018, is classified as highly promising. Means that extraction technology are currently available and pilot plants have been successfully developed. One of the examples of industrialized valuable element from coal ash is germanium produced in Ulan-Duga coal mine, Inner Mongolia. They are producing industrial-grade germanium to supply high-tech company, especially computer chipset. So the main product from the coal-fired power plant is this area is not electricity, but fly ash as feedstock for germanium extraction. Next is about the rare earth element. As we may all know, increasing production for rare earth element since Monazite era, Mountain Pass era, Chinese era, or post-Chinese era is due to the increasing demand for high-tech industry, from catalyst for battery, metallurgy, and others that push many countries to find their resources. Even though there are many countries that currently have their rare earth element reserve, but the rare earth element production is still limited to only several countries. And despite production from the primary source, some studies now recently in the current years are focusing on the secondary geological material as in accordance with the circular economy of rare earth element. One of the promising source is coal ash. Actually, why the coal ash? Actually, RAE in the coal ash have several benefits. Average rare earth element in the coal ash is, average world coal is only 68 ppm or less than 70 ppm on the average world coal. It's actually very low compared to rare earth element in the upper continental crust. However, in the coal ash itself, we have around 600 ppm. It's 10 times higher and even more due to the volume enrichment during the combustion process. The second one is coal fly ash is already in the fine grain. So in terms of the extraction method, it will be give some benefit. Moreover, the radioactive material is also quite low, less than 500 ppm. The third one is since fly ash and bottom ash is classified as waste, so that utilizing waste to feedstock of valuable mineral resources will give a significantly added value in terms of circular economy. Then how about the cutoff grade? As we mentioned previously that average concentration of coal ash is around 500 ppm, then Saradin and Dye give the cutoff grade is around 2 times, around 10,000 ppm. However, this number will be discussed more in the several slides, in the next several slides about the cutoff grade in here. Based on some new report, actually there are several countries, several research institutes conducting research on the rare earth element from waste. One of them is from coal ash, and one of the new report is from the NETL 2020. They made several criteria on the performance attribute. And one of the interesting things is about the feedstock of RAA content. They only give number around 300 ppm. Actually, they have a feedstock around 500 ppm. So it's the interesting things about the RAA content as a cut-off grade for production. Why we can put around 300, we can put around 500 ppm to the recovery process of rare earth element. So actually, the RAA extraction in the coal ash is part of comprehensive utilization of fly ash and bottom ash. It starts from the high concentration rare earth element in the fluid coal, and then followed by several processes to extract valuable element. For example, we extract xenosphere. We utilize byproduct of carbon. And then finally, the extraction method for rare earth element is based on the mode of occurrence of rare earth element in the coal ash. So in the next slide, we would like to give some case study in RAA in coal in Indonesia with the high RAA concentration compared to world average based on the suitable geological condition. Actually, there are 4 genetic types of RAA accumulation in coal. First is terrigenous type. Second is tufaceous type. The third one is infiltrational type. And the fourth one is hydrothermal type. And we are collecting our sample based on the screening criteria based on the geological condition. Our first location, our first study area is in the South Sumatra Basin. The coal-bearing formation is Muara Enim Formation. And Muara Enim Formation, as we know, the coal-bearing formation is affected by volcanic activity represented by the tungsten layer. And based on our analysis, rare earth element in coal enriched significantly up to 200 ppm in the coal above the tungsten layer. It is more than 3 times higher compared to the average rare earth element in the coal seam. So hypothetically, it will produce more than 2000 ppm in the coal ash if it used as the feed coal in the coal power plant. The second study area is in the Ombilin Basin, in the vicinity of the basin itself. Why we choose the Ombilin Basin and why we try to locate the coal seam in the vicinity of the Ombilin Basin is based on the Wulantuga coal mine. The coal enriched with germanium and others valuable element is only limited in the certain area is it controlled by the geological structure. And based on our study, we delineate several coal seams with high rare earth element concentration. The third study area is either Senakin coal field. Senakin coal field, based on this figure, Moore et al. 2020, the coal field have several intrusions and the coal-bearing formation also in contact with the basement. Interestingly, we found the coal layer with rare earth element concentration higher than in the South Sumatra Basin. And we conclude that there are multiple enrichment process of rare earth element in the coal layer in this area. Next, we are also collecting coal sample from several companies with different coal basin in Kalimantan to examine the relationship between rare earth element concentration and the characteristic of coal. However, the results are still ongoing. We're still drafting the manuscript to be submitted into the journal. The next one, our result on the coal fly ash in Java coal-fired power plant, showing that our rare earth oxide is in the range of 300 to 500 ppm. It is in accordance with European and US coal ash. However, it's still under the cut-off grade from Saradin and Dye, since Saradin and Dye, as I mentioned previously, is 1000 ppm. However, our coal ash, our fly ash from Java fired power plant has the higher percent critical of rare earth element. And it will give us some perspective. It will give a new paradigm about how we define the criteria of cut-off grade. And next, we move to why we have a rare earth element in the coal ash just around 300. Because raw coal that we use have a low concentration of RAE, meaning that if we have the higher concentration of rare earth element in the coal, it will give an increasing rare earth element in the coal ash itself. And our study shows, our study proves this, this hypothetically that I already mentioned previously. Moreover, about the mode of occurrence, based on our result, actually there is no mineral-bearing red element has been found in our coal. And it is in conjunction with the SAM EDX analysis of fly ash and bottom ash, just published, just accepted in the journal, showing that yttrium occurs in the glass and low concentration in the spinel. This mode of occurrence will be give the data to determine the extraction method as part of coal ash upcycling processes. So actually we have a graduated PhD student that have already finished their PhD and successfully recover rare earth element from coal fly ash. So before closing our presentation, I would like to share our recent publication if interested to study more detail on valuable element in coal, not only the rare earth element, but also we have some publication on xenosphere and geopolymer. Feel free to discuss or send an email to us and we can discuss more deeply about these topics. For closing remark, first, there is a possibility to find coal with high rare earth element content in ash that are comparable with those of conventional economic ore. Exploration and exploitation coal as potential source of rare earth element should be conducted based on first, suitable geological condition for rare earth rich coal in Indonesia, and the second one is selective mining and modification of coal power plant, since not all coal is enriched in the valuable element. So selective mining, and we use this kind of coal producing in the mine mode coal-fired power plant is becoming important. And the last one is suitable extraction method for coal ash based on mode of occurrence in the coal, and coal ash is becoming important to determine the suitable extracting methods. That's all my presentation, and thank you for the kind attention.
Thank you, Dr. Feren Anggara, for the kind presentation. And currently we will have sessions, and I already see that Pak Fakih Alian has raised the hand. Pak Fakih, can you hear me?
Yes, Pak Andi, thank you.
Yes, you may turn your camera and then you can ask the questions and to whom the question is being asked. Okay.
Okay, thank you. Pak Andi, I would like to ask to Pak Denny. Thank you, Pak Denny, for your presentation. I would like to ask you two questions. As I learned from literature that the ore from shear or lode gold has potentially high variability in the grade, and for example in the duplicate sample. And my first question, in your TSF, on any challenges related to the grade variability, and if yes, how do you deal it with it to calculate your resource estimation? And the second question is, what sampling method do you use in your TSF and any drilling program on it? Thank you, for Pak Denny.
Okay, Pak Denny, you may answer the questions.
Okay, thank you, Pak, for the question. So I will answer the question. Our challenge is, you're right, the grade variation and high variability. That's why one of our strategy is to infill drilling is more dense, the data, like in underground. So our spacing for the drilling is 12.5 by 12.5 meters, and also we have data for in channel sampling each 3 meters. So that's why we reduce the high risk of the grade variation. And also we mentioned to the operation as well, to the engineers, that we notified that in some area we need to more data drilling. So that's why we coded our models with the grade risk. So that's the grade risk is based on the data density and also the lithological constraints or geology boundary. So I think that's the question.
Thank you, Pak Denny. Is there any more questions, Pak Fakih? Or is there any other questions from the participants?
Clear enough, Pak. Yeah. Thank you.
Okay. Thank you for the response. Is there any more questions from the audience? Okay. Pak Yan, I have a question for you. Related with the classification of waste, you said that there are some mineralized waste in Martabe. Is there any plan to mine the mineralized waste?
Yes, for sure. There is a plan basically for mineralized waste. I'm not sure when it is, but we have the experience using that mineral waste to feed the crusher, which is when we have the first wave of the COVID-19 on May 2020. We are feeding the crusher from the mineralized waste in a stockpile SK09 from the stockpile. So that is we feed that material for about 1 month because we are reducing the activity on site in the time. So yeah, it is yeah, I think that is the answer.
Okay, thank you, Pak Yan. I'm still waiting for another questions from the audience.
If there is no,
yes, Pak Arifuddin Idrus,
Yeah.
you may ask questions.
Yeah. Okay, thank you, Mas Andi. Okay, if there's any question from the other audience, I have a question to Pak Denny and Pak Tommy. As you mentioned that high-grade tailing is in TSF during late 2006, I think it's due to or characteristic change. So could you elaborate more about this? If you connecting to the deposit, which part of the deposit that actually producing the or containing the fine grain gold or very fine grain gold, less than 45 micron. Could you explain more about this related to the ore body, maybe texture or maybe the part of the ore body? And second question to my colleague, Dr. Ferian Anggara. So, if there's no REE bearing mineral recognized during the study, so it means that the REE could be categorized into ion absorption area type. Please, your more explanation, Pak Ferian. Thank you.
Okay, please, Pak Denny, you may answer the questions.
Okay, thank you for the question, Pak Arif. So maybe Pak Tommy can answer the question effective in metallurgy.
Okay. Yeah. I think for the ore characteristics changing because in 2006 we in NSM changing the pit from the open pit to the underground. Before we Gosawong pit and Tagurachi pit, and then in 2006 we start to Kencana underground pit. So in the Kencana or characteristic that we already doing the test with the fraction size distribution. Looks at the gold metric is very fine. It's below the 45 micron. So mostly that's under the about 20. Under the 30 micron. So average about 20 micron. The size of that gold. So that's why in the recovery is quite drop on that time because our processing plant still just produce the size size about the P80 to 75 micron. So this why the gold still mostly not liberated, and then the lot of gold is disposal to the tailing dam. I think because the area is changing, but the ore body is quite different between the Gosawong area and Tagurachi, and also the Kencana area. Maybe Pak Denny can explain where the position or that the ore body and with that mining.
Yeah, I think thank you, Pak Tommy, for the perspective. So I will add what Pak Tommy explained. Pak Tommy is right. The ore body in Kencana and also Tagurachi is different because it's Kencana is more the ore body is not hard like Togurachi, and Kencana ore body is not much of sulfide, different with the Togurachi. So and also I think is similar with the others deposit outside the Gosowong. This is just in terms of the processing plan strategy, I think. So.
So does it mean that going to deeper, the fine grind of gold become to be finer, Pak Denny or Pak Tommy?
Yeah, I think the more deeper is not is more finer, but we abandon of the sulfide content.
Okay, thanks.
We may move to the second questions from Pak Arif directed to Pak Ferian Anggara.
Thank you, Pak Arif. Yes, actually, we suppose that the rare earth element is ion absorbed in the organic material. So that's why it's also supported by data in the fly ash and bottom ash that rare earth element is scattered into the glass portion.
Thank you, Pak Ferian.
Thank you, Pak Arif, Pak Ferian, and also all the speakers. Is there any other questions from the participants? If no, then I would like to resume our sessions today. First, we are stepping into the future that our speakers has highlight the ore conservation that has been performed in Gosowong, in Martabe area, and also in several coal and coal ash from Indonesia. And we will face another challenge about how to exploit and how to mine the rare earth elements and other possible metals from the coal and fly ash, as well as how can we manage the gold, silver in tailings storage facilities, not only from the high grade, but also for the low grade ore. By that, I would like to thanks to all. Okay, there are some questions. I'm sorry for that. Pak Saud Simbolon, short answer maybe from Pak Denny. Have you fed the TSF to plant? Pak Denny Usman?
Yes, we already trial Pak Saud in 2011, and this is and we blend with the fresh rock from underground, and the grade is confirmed with the drilling result of the block model.
Okay, thank you, Pak Denny Lesmana. Okay, by that, I would like to give appreciation to all speakers. Thank you for the time and your expertise. And I would like to give the stage to the MC, Mbak Rahma.
Thank you very much, Dr. Andi Yahya Al-Hakim, as our moderator. We also would like to thank Bapak Denny Lesmana, Bapak Tommy Oktaviantana, Bapak Janjan Hertiana, and Dr. Ferian Anggara as our speakers for their presentations. Before we proceed to the memento of appreciation and photo session with our speakers and moderators, we first would like to make an announcement. This afternoon at 1 p.m. Western Jakarta time, we will have a special session with Menteri Koordinator Bidang Kemaritiman dan Investasi Republik Indonesia, Bapak Luhut Binsar Panjaitan, who is expected to come. So please stay tuned. Next, we will give the memento of appreciation and photo session to our speakers and moderator. This session will have Bapak Irianto Rompo, Deputy Secretary General of MGEI, who will give the memento of appreciation, starting from Bapak Denny Lesmana. All right, gentlemen, if you could all please look to the camera. I will count from 3. 3, 2, 1. Thank you very much. Up next, it is Bapak Tommy Octaviantana. All right, gentlemen, I will count from 3 again. 3, 2, 1. Thank you very much, gentlemen. Up next, we have Bapak Janjan Hertiana. Okay. 3, 2, 1. All right, thank you very much. And then up next, we have Dr. Ferian Anggara. Three, 2, and 1. All right, gentlemen, thank you very much. And last but not least, we would like to give a token of appreciation to our moderator, Dr. Andi Yahya Al-Hakim. All right, gentlemen, 3, 2, 1. All right, thank you very much, but please do not go anywhere. Now we would like to take a group photo with all 6 gentlemen. To Bapak Denny Lesmana, Bapak Tommy Octaviantana, Bapak Janjan Hertiana, Dr. Ferian Anggara, Dr. Andi Yahya Al-Hakim, and also Bapak Irianto Rompo for a group photo. All right, gentlemen, please look to the camera. 3. Oh, we are missing one person. All right, gentlemen, please look to the camera and smile. 3, 2, 1. Perfect. Thank you very much, gentlemen. Thank you again to Bapak Denny Lesmana, Bapak Tommy Octaviantana, Bapak Janjan Hertiana, Dr. Ferian Anggara, and also Dr. Andi Yahya Al-Hakim. Up next, before we go on a break, we would like to thank our sponsors and media partner. Our sponsors, starting from the Superbite sponsors, PT Geofix Indonesia, PT Merdeka Copper Gold Tbk, and PT Petrosi Tbk. Our Gigabyte sponsor, we have PT Antam Tbk. Our Megabyte sponsors, we have PT Agincourt Resources, PT Aman Mineral Nusa Tenggara, PT J Resources Nusantara, PT Namsuma Luban Abadi Sumacorp, PT Reka Buana Penjuru Mineral, and PT Sumbawa Timur Mining. Our Kilobyte sponsors, PT Eksplorasi Nusa Jaya, E-Minerba Indonesia, PT Greenland Resources, Harita Nickel, PT Indodrill Indonesia, PT Nusa Halmahera Minerals, and PT Timah Tbk. Our workshop sponsor, we have Sequent Limited. Our other sponsors, PT Medco Energy Mining International, and PT Minevesting Resources Indonesia. And last but not least, our media partner, Dunia Tambang. To our sponsors and media partner, we sincerely thank you for your support in making this event happen. And to our participants, we invite you again to our booth exhibition where you can see our sponsors and media partners' products and services to see what they have to offer. You may also check out the student chapter research posters where the students have created such lovely research. We will now take a few minutes break and see you soon for our special sessions with Bapak Luhut Binsar Panjaitan, MPA. Hello again, ladies and gentlemen, and now we have entered the sponsorship presentation with our first sponsor who will give a presentation from Suma Corp. Please give a virtual applause to Bapak Agdiosa Manyan. Hello, Bapak. How are you today?
Good. How are you?
Thank you. I'm doing well, sir. I hope you have a lovely day today.
You too. Thank you.
To Bapak Agdiosa Manyan, the time is yours.
Okay, I'm gonna start my presentations. Okay, so can everyone see the presentations now? I think so. Yeah. Okay. So hi everyone. My name is Manyan. I am from Suma Corp. We have a slogan of a dedication for solution, and today I'm going to tell you a story about us. So our story starts in 1999, where some former employees of BHP Minerals Exploration Group formed a company, and since then, since those 22 years, we have 1.1 million meter drilled and over 650,000 geophysically logged in. And this just proves of during all these 22 years, we must have done something right to do this consistently, during these years, throughout all of these years. And this is about who are we. So a lot of people have this misconception when they talk about Suma Corp. Are we the same thing as Suma Gut Saptasinar, which is very commonly known among the clients and people? Well, basically we are the same organizations. So Suma Corp is the parent company of two companies. That the first one is Suma Gut Saptasinar, or usually known as SSS or SSS. And SSS focus on drilling services that we did with all of our clients. And the other one being is the Namsuma Luban Abadi, or commonly known as NLA, that focus on exploration services. But the whole thing, the organization is basically the same. The only difference is the personnel on the operational teams, because SSS clearly focus on drilling and Namsuma focus on the exploration services, but we are basically the same company and the same people that are working inside it. And during those 22 years, we have a lot of projects that we did. We cannot mention all of the provinces and regions that we did our projects in, but this is the main picture of it. We did projects in Sumatra, Jawa, Kalimantan, Sulawesi, Maluku, and some projects as well in Mauritania and Madagascar. These are some of our clients. We have Kideco, Fiat, J Resources, Gumi Resources, Indica, Bantu Group, Rutmin, Baramoti, Bayan, Pama, Ambeka, Golder, BHP, NTI, and many more that we cannot mention and show everything on this slide. This just shows the kind of clients that we have all these years. We had every kind of companies working with us together. These are our project achievements in numbers. You can see the screens, the exact numbers of the things that we did. In the whole size numbers, we did IQ, and in the last one, we did 6-inch coring in Southeast Sulawesi. We do all of kind of drillings and the areas covered. We already talked about that as well. This is our head office. It's located in Bogor. This is our own offices, our own buildings and land. And beside that, we also have our own workshop where we build all of our custom rigs. And we usually take our clients to see, the kitchen of the technical aspects, so that they know our expertise and how we working on those technical aspects to show our clients that this is our rigs and this is how we done everything. Our main services is divided into 3 aspects. The first one is exploration, then drilling, and then tenement services. Well, exploration is pretty straightforward. We provide supports and services in all stages of mining exploration, starting from A to Z. We basically can help you with that as long as it's still in the area of mining explorations. And we have a team of professional, highly skilled, highly experienced mining consultants that we did a lot of projects all over Indonesia in various commodities and deposit styles. So if you are working with us, we're gonna assure you that you are working with the best teams and the best professionals that you can get. These are some types of explorations that we did. Prospect evaluation, management exploration, geological mapping, geological recon, and then some geophysical logging as well. This is some example of the tenement services that we did in the past as well. We had due diligence, tenement management, report preparation, mining licenses, and ground monitoring as well. Now, drilling. Drilling is one of the big part in our business. We provide all-purpose drilling services for mining exploration, geotechnical services. We have 1.1 million meter depth as our, curriculum vitae. So if you want to know our competencies, that you can see that we have these numbers to show our competencies. And it's like what I said before. We must have done something right to be this consistent all these years. And we also custom made all of our drill rigs to accustom to the type of projects and challenges that we did. Currently, we have 22 drill rigs with depth capacity of up to 600 meters and several types of rig mounting. We did all hole sizes and all moving methods and operations on the field. This is some of the photos of the projects that we did. We had some coal drilling in Batu Kajang, minerals drilling in Sukabumi, and then we also have this RC reverse circulation drilling in Bontang, is Kalimantan. As you can see, we have various types of drilling rigs that we use among our projects. We also have minerals drilling in Gunung Kencana, and then the other one is gold drilling in Doup, and then another gold drilling in Bontang as well. This is the track mounted that we have, the Sumatec 600 Trustan, doing coal drilling in Batu Kajang. And then we also have some iron sand drilling using RC technique as well, air compressor, that we did in Palangkaraya, Central Kalimantan. We also did geotechnical drilling in Dairi, North Sumatra, back in 2019 using one of our drilling rigs as well. This is some operations that we did, any type of rig moving, starting from heli-sling operations using helicopter and chopper, and then crane. This is during the Pulau Laut constructions. We also did some excavator moving, tractor moving as well. We also had portable rigs that we can carry it out, and then we also do moving by winch and the self-mobilization, of course, using our track-mounted rigs and bulldozer as well. Of course, this is one of the most common type of rig moving that we did in our projects. And that's basically it. We are looking forward for any of your inquiries, all of your questions. You can visit our booth to know about us more. And then you can also visit our website at www.sumacorp.co.id to know more about us. And we are looking forward to work together with you guys, and hope to see you guys again in the collaboration or working together in the future. Thank you very much.
Thank you very much, Bapak Agdio Samanya. And now we would like to invite our next sponsor speaker from J Resources Nusantara, Bapak Johan Arif.
Selamat siang. Good afternoon, Mbak. Can you hear my voice?
Yes, I can hear you well. How are you today, sir?
I'm very good, thank you.
All right,
The
Bapak
sound is
Johan
not
Arif.
very clear, but I hope I can make it.
All right.
Let me share the presentation here. Hold on.
All right, Mr. Johan Arif, without further ado, I will let you take over this session.
Thank you.
Very much.
Can you see my slide?
Yes, very clearly.
Okay. Good afternoon, ladies and gentlemen.
I'm sorry to cut you off, Mr. John. Could you perhaps press the slideshow option?
Actually, I did. Okay. Yeah. Thank you. Good afternoon, all. This time, I would like to introduce G Resources Asia Pacific, which is where I've been working with G Resources for almost 7 years now as the GM for exploration. Brief presentation outline, company profile and asset overview, selected asset details, GR with the resource management and also award. Just as a side note, this slide is actually created early 2001. So there has been some new development regarding takeover some of the assets, especially in GSM. So I will not really explore on the slides from the GSM. Okay, the G Resources is basically an Indonesian mining company. We have 2 operating mines at the moment. It used to be 3, but for the other one in Kalimantan, Seriong, has been almost closed. And we have now have a Bakan still operating strongly, and Malaysia, we have also 1 mine there. We also have projects in pipelines, which is including Pani, which is right now under a process of takeover, and also 2UP. Both of them are in development states, but 2UP have more advanced development with construction ongoing, and we hope that we have a gold pour early next year. Pulangitan and Pulahidun, as part of the GSM, is also an exploration space. All of these are located in the north arm of Sulawesi. In 2020, our reserve was 4.6 million with a total resource of 9.2 million ounces. As you can see here, this is the detail of every project and site with the resource and reserve status. This is also basically showing the asset overview. We have Bakan, which is 80% owned, and then Penjom in Malaysia, and Seriong and North London, which is at the moment is closing down. And 2UP is development assets, and Pani, which is, as I mentioned before, it is under process of overtaking, which is in the exploration assets. We have Pulakidun and Pulangitan. So in terms of project pipeline, in 2021, it should be a really good and healthy project pipeline. In terms of the mine development and costs, and also the mining production, this is how GRN statistics from 2016 to 2020. Roughly, we're producing between 150 to 190 ounces a year, with a cash cost between 500 to 730. So it's quite good. And this is how we actually managed to improve our growth of the reserve and resources. Almost every year, we are quite successful in terms of adding the resources. And this is mostly part of the strongly support from management and finance to give the exploration teams to do drilling and also detailed exploration activity. Right, on the project details, I will touch on the Bakan and 2UP. Bakan, it's located in North Sulawesi. Right now, we have around 558 hectares of permit area, and we starting production in end of 2013. We do the 2 years of construction. This is contributing between 70 to 100 ounces a year, and currently we have reserve for 5 to 7 years of mining. And with the additional some of the discovery, I think this is will extend to 10 years mine life at the moment. It is open pit mining, and we processing the dynamic heap leach, and then also adding with agglomeration where the ore have a lot of clay, we do the agglomeration. Some of the exploration targets still around the mine area and also near mine interest. We have around 1 to 1.7 million ounces of gold, mostly oxide ore at grade between 0.3 to 1.3 gram per ton of gold. This is the projection of the production and cost profile of Pakan. As we see here, the cost is increasing as we getting deeper and more less oxide ore. This is adding more cost, but this is the production. We're trying to have a steady production until 2028. That's about Pakan. And for Duap, this is in progress of mine development. This is actually also in North Sulawesi as well. We have at the moment 4,000 hectare area of permit. Currently, we targeting for 10 years of operation. It's also open pit mining, but this is different with Pakan. This is a gravity and carbon in leach operation because the ore is unoxidized, and we do milling. Exploration target around the area of interest between 100 to 450 million ounces, but new development, this can be stretched to up to 1 million ounces near the mine. It's grade between 0.8 to 1. At the moment, the reserve is 1.9 million ounces at 1.2 gram per ton, with resource 3.3 at 1.16 gram per ton. Okay, that's two up. In terms of the projection pipeline, I think when we look at this graph, it's quite healthy exploration pipeline. On the prospecting side, we have Pulau Gidun, which is mostly in GSM, and Pakan Patende, this is in Duap, and some of this in near mine Pakan. And on exploration, which is we have some more detailed work and trying to improve the estimation. We have also Polopoa, Pulangitan. This all is good project pipeline. And development, currently we have Duap, which is slightly moved to the pre-production. And also we have some of the Pani project area. So it will try to fit the production need, and then we project that it should be quite sustainable in terms of the operations. Some of the award, I think GSR and also safety that GRN has been received from the government. I guess this is quite significant, as we knew that GRN is very young company, but I guess we made a good commitment in terms of the government regulation. In 2020, we have a good mining application award and also best people development from IAGI. And this is the annual, almost every year we got quite good award from the ESDM and also some of the other award from the Asian Mining Association. In terms of the corporate governance and environmental social responsibilities, we always working together with the government and make sure that we at least fulfill the requirement, or at the most we're trying to exceed the requirement. I guess that's all the introduction of the GRN. Thank you very much. I give the time back to you. Thank you.
Thank you very much, Bapak Johan Ari, for the presentation. And now we will continue to our break, and we'll see you again in a few minutes. Have a good break, everyone.
Welcome to PT GeoFix Indonesia. GeoFix is a multidisciplinary and multi-commodity exploration and mining consultant drawing all over Indonesia. With a band of highly skilled professionals as our core, GeoFix committed to maintain the highest standards and best practices, comply with the code and policies, and never compromise on safety, health, and environment in doing our business. We support all scope of mining enterprises to unravel their proficiency to fix, build, and enhance their assets' value through explore, discover, develop, and repeat. With the provision of innovative, reliable, and high quality of services and solutions, whilst nourishing state-of-the-art platforms and ecosystems in mining industry. Our services encompasses GIS, Greenfield Exploration, Brownfield Exploration, three-dimensional modeling, geometallurgy, metallurgy, resource estimation, technical due diligence. We also provide drone LiDAR survey services, a high-precision aerial topographic survey provide reliable and accurate data for your project. GeoFix has diverse professional experiences in assessing across the range of multi-commodities and project stages. How do we execute a strategy and deliver a goal? Reputable expertise with passion, teamwork with state-of-the-art technical and non-technical capability, consistent and persistent management and stakeholder support. Guided by our values: respect, reputation, technology and innovation, breakthrough, quality and integrity.
The energy and minerals sectors are experiencing significant times, and the willingness to embrace and ability to harness change will become crucial factors to continuously move forward. Here at Petrosi, embracing this change is exactly what we continue to do. Established in 1972, Petrosi has been listed on the Indonesian Stock Exchange since 1990 and is now recognized as one of Indonesia's leading contractors that serve the mineral resources, infrastructure and oil and gas industries. In carrying out our operations, we are supported by our main shareholder, PT Indica Energy Tbk. Drawing on rich and varied experience throughout the Indonesian archipelago, we are now entering a new stage in our journey, harnessing emerging enablers to drive better performance and pursue new growth opportunities. With over 45 years of experience under our belt, Petrosi continues to be one of the most trusted contract mining service providers in the country, ready to tailor our integrated mining solutions for each of our clients. But experience is not the only thing that sets us apart. Our willingness to continuously innovate is also our winning factor. The company has taken a strategic step towards the transformation of our entire mining operations, with the implementation of new enablers within our other business lines also slated in the near future. We believe that the visibility and clarity delivered by these new enablers will enhance our agility, improve our productivity, and positively impact our future financial performance. Petrosi also has vast experience and expertise of providing engineering and construction project management and services, the mining and infrastructure industries, while constantly maintaining strong relations with key stakeholders such as the government, consultants, and communities to assist our clients in meeting their business goals. With the acquisition of PT Kuala Puebloan Indonesia in 2018, we have also continued to strengthen our ability to provide logistics services for the mining and infrastructure sectors. Petrosi provides services for the oil and gas industry in Indonesia through our Petrosi Offshore Supply Base, or POSB. From our deepwater supply base located in Sorong, West Papua, we consistently deliver international standard and cost-effective services to all of our clients. In 2016, Petrosi was officially inaugurated by the Indonesian government as a bonded logistics centre, PLB, for the oil and gas sector. Here at Petrosi, safety is our #1 priority. As one of our core values, safety, health and environment has become part of our culture, which is embedded in every employee. We continuously strive to achieve safe, efficient and productive operations, with an ultimate goal of zero harm to people, the community and the environment. Our talent is our key asset to be successful in the industry. Through our human capital management strategies, we have and will always strive to attract the best talents, develop their full potential and encourage them to become champions of the industry. Implementing quality management that fulfills our clients' needs and adds value to their operations is an integral part of our success. To this end, we persistently apply our Petrosi Quality Management System, or PQMS. By continuously improving our business processes, the system allows us to meet the requirements of operations, quality, as well as safety, health and environment. A firm believer in the triple bottom line, Petrosi is committed to the implementation of corporate social responsibility programs that are directed towards local communities and the environment surrounding our operations, as well as our own employees and their families. By focusing on issues such as education, health and economic empowerment, these programs will positively impact the betterment of their lives.
Petrosi is no stranger to innovation. Our continuous improvement program and portfolio balancing strategy has enabled us to navigate through sea changes within the industry and to continue to thrive throughout the years. In order to further improve our corporate performance, we are continuously enhancing our operational excellence, while always being very disciplined in implementing good governance across all elements of the company. Going forward, Petrosi will continue to transform and embrace change in order to successfully provide enabling solutions for our clients, thus creating value for the shareholders and also help create a better Indonesia.
Enggak terlalu mahal, beda dengan jualnya besar.
Salam MGEI dimanapun Anda berada. Nama saya Noel Pranoto dan saya sehari-hari bekerja sebagai geoscientist di dunia pertambangan. Dalam kesempatan ini saya ingin berbagi sepintas mengenai program Fresh Graduate Mentoring yang dilakukan oleh Masyarakat Geologi Ekonomi Indonesia atau MGEI. Seperti banyak lulusan geoscientist pada umumnya saat kami kuliah dan baru lulus dulu, gambaran sebagai geoscientist itu sangat menawan, apalagi buat mereka yang menyukai perjalanan, kegiatan di alam bebas. Ibaratnya kami bekerja dan jalan-jalan, melihat banyak tempat di Indonesia dan bahkan dunia ya. Namun atas biaya perusahaan, ya siapa yang nggak mau ya. Namun setelah sampai 1-2 tahun bekerja, ya ternyata realitasnya tidak hanya seperti itu dan terus terang saya kaget. Ternyata gambaran yang indah itu cuma penggalan kecil aja dari tuntutan nyata pekerjaan sebagai geoscientist. Mulai dari pekerjaan di lapangan, lalu kemudian menulis laporan, menyusun program dan anggaran, menjual ide atau presentasi, hingga harus memimpin tim kerja dan juga melakukan banyak-banyak hal yang sama sekali baru begitu. Nah, repotnya lagi hal-hal seperti ini tidak kami dapatkan secara terstruktur dan sistematis di bangku sekolah. Nah, untunglah pada saat itu kami memiliki atasan atau senior-senior yang mau mementor dengan sabar dan penuh dedikasi. Tentu saja di samping itu perusahaan juga memberikan resource untuk kami yang baru-baru lulus ini untuk bisa belajar sambil bekerja. Nah, berbekal kisah nyata yang berharga ini gitu ya, dan pengalaman di organisasi yang lain, kami bersama kawan-kawan di kepanitiaan MGEI memulai suatu program Fresh Graduate Mentoring di MGEI yang menyasar pada lulusan geoscientist dan mereka yang baru memulai karir di dunia eksplorasi dan pertambangan. Tentu selain meningkatkan kompetensi ya, dan menjadi ajang sharing dan learning antar generasi geoscientist, program ini juga bertujuan membangun jaringan yang berkelanjutan antara mentor dan mentinya di dalam mereka meniti karir. batch pertama ini tentu saja banyak hal yang kami harus benahi. Kami belajar ada hal-hal yang waktu itu kami lupakan atau kami kurang begitu ya. Namun tujuan kami adalah progress, bukan perfection. Saya yakin sudah banyak hal positif yang telah dilakukan oleh para mentor dan mentee dibanding saat kita memulai program ini di awal tahun 2021. Akhir kata, saya mengucapkan terima kasih untuk para mentor dan mentee, khususnya untuk rekan-rekan yang sudah mendedikasikan waktu, tenaga dan pikiran untuk mewujudkan fresh graduate mentoring program ini. Saya yakin para mentor, mentee dan panitia ini telah menjadi bagian dari tonggak sejarah dalam usaha kita untuk terus meningkatkan kemampuan geosaintis Indonesia di dunia eksplorasi dan pertambangan. Salam MGEI.
Halo semuanya, nama saya Dina Durardi. Saya adalah HR profesional yang saat ini bekerja di salah satu perusahaan tambang batubara di Indonesia. Saya pernah mengisi salah satu program FGMP. Topiknya pada waktu itu adalah Successful Interview to Score Your Dream Job. Ketika pertama kali saya di-approach oleh Mas Nol, yang juga pernah menjadi rekan kerja saya di perusahaan sebelumnya untuk mengisi sesi ini, saya tentunya sangat excited. Karena selain dapat membantu FGMP, saya juga memiliki passion untuk terus memberikan kontribusi sosial di luar kontribusi profesional saya di perusahaan. Pemilihan topik dalam proses mentoring menurut saya juga sangat tepat, karena dengan menguasai proses interview, tentunya bisa mempersiapkan mereka untuk memasuki dunia kerja secara lebih mudah, hal yang mungkin tidak mereka pelajari pada saat di bangku kuliah. Secara keseluruhan, MGEI menurut saya merupakan salah satu wadah yang sangat powerful dan barangkali perlu dicontoh juga oleh mereka yang berasal dari disiplin ilmu lain. Saya yakin program-program MGEI ke depannya akan lebih banyak dan lebih menarik lagi. Wadah ini saya percaya ke depan akan semakin solid dan bisa menjadi support system yang terus berlanjut, di mana anggotanya bisa terus melakukan sharing knowledge dengan pengalaman kerja di perusahaan masing-masing. Salut saya untuk MGEI dan sukses terus ke depannya. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. Saya Agaton Chandra Setiawan selaku mentor untuk bidang hidrologi dan hidrogeologi kegiatan FGMP MGEI tahun ini. Bagi saya, peran mentor cukup penting untuk kegiatan kali ini sebab dapat memberikan wawasan dan pengetahuan di dunia kerja bagi para mentee yang merupakan pelaku baru dalam industri eksplorasi ataupun pertambangan. Lalu wawasan dan pengetahuan ini dapat berupa teknikal ataupun non-teknikal. Dan sehingga harapannya para mentee dapat lebih cepat untuk beradaptasi. Seperti yang kita ketahui di mana dunia kerja dengan dunia kuliah tentu sangat jauh berbeda. Hal inilah yang kami harapkan selaku mentor agar dapat memberikan seluruh wawasan dan pengetahuan yang kami mungkin hanya lebih dulu kami dapatkan pada pengalaman kami di dunia kerja. Lalu bagi saya kegiatan FGMP tahun ini cukup baik dan cukup positif baik para untuk mentor ataupun untuk mentee itu sendiri. Sehingga harapannya di tahun ke depan dapat dilanjutkan dan dapat terus lakukan evaluasi perbaikan sehingga baik mentor ataupun mentee untuk di kesempatan selanjutnya mendapatkan manfaat tentunya. Salam dari saya. Assalamualaikum warahmatullahi wabarakatuh.
Halo semuanya, perkenalkan saya Salma. Saya adalah salah satu mentee FGMP batch pertama. Saya merasa senang dan merasa tercerahkan setelah mengikuti mentoring ini karena saya dapat mengukur perkembangan saya juga dapat menentukan smart goal saya, dan saya juga merasa beruntung dan merasa bersyukur dipertemukan dengan mentor saya yang hebat, yaitu Pak Wesley Randa yang telah sabar mengajar dan membimbing saya melalui tugas-tugas, diskusi-diskusi, atau sekedar sharing-sharing pengalaman beliau tentang karir, tentang on-demand karir misalnya. Dan saya berharap untuk FGMP batch selanjutnya bisa dieksekusi secara lebih baik lagi dan komprehensif dan bisa menciptakan program mentoring yang aktif dan komunikatif.
We are PT Agincourt Resources, a world-class gold mining company based in Indonesia. We manage the Martabak Gold Mine, located in the South Tapanuli District, North Sumatra. Our vision is to develop a sustainable world-class operation, delivering first quartile performance in the gold industry. We will achieve this by growing our business and optimizing our assets, all of which is built on our strong foundation of sustainable development. We are pursuing exciting growth opportunities through exploration, the Sulfide Development Project, and plant debottlenecking to 6 million tons per annum. We have invested in a successful exploration program to deliver significant growth and value to the business. We have 6 deposits in reserves category and a vast mineral resource which we continue to develop. Our project pipeline includes an impressive portfolio of projects across a range of near-mine and contract of work targets. The focus is on near-mine exploration targets to utilize the existing infrastructure of the Martabak process plant. The Sulfide Development Project presents an opportunity to change the game at Martabak, enabling the processing of refractory ore and upgrading the recovery of precious metals from transitional ore. The project upside could potentially double the life of the mine. Our short-term opportunity is to further enhance asset performance by debottlenecking the process plant from its original design to 6 million tons per annum. We can do this with incremental capital investment and drive efficiency and costs even further. Production at Martabak is operating above design and ahead of plan as we are driven by opportunities for efficiency and asset performance. We are delivering in excess of 350,000 ounces of gold and 2.5 to 3 million ounces of silver per annum, all within first quartile cost comparisons worldwide. The foundation of our business is our belief in sustainable development. We believe that mines should be developed, operated, and closed in a socially and environmentally responsible way. In terms of our local community, we deliver practical outcomes, such as employment and capacity building, where more than 70% of our workforce are local people. And our CSR programs, which focus on health, education, infrastructure, agriculture, and economic development.
Selamat datang di Tambang Batu Hijau, salah satu tambang tembaga dan emas terbesar di Indonesia yang terletak di Kabupaten Sumbawa Barat, Provinsi Nusa Tenggara Barat. PT Aman Mineral Nusa Tenggara mengoperasikan tambang batu hijau sejak tahun 2016 pasca akuisisi dari PT Newmont Nusa Tenggara. Disinilah kami melakukan rangkaian proses untuk menghasilkan mineral yang sangat penting bagi kehidupan manusia. Aman melakukan transformasi dalam berbagai aspek operasional untuk mencapai visi menciptakan warisan terbaik. Strategi operasional Aman adalah untuk meningkatkan copper recovery sebagai upaya konservasi mineral dan mengurangi kandungan mineral pada tailing yang ditempatkan di dasar laut atau deep sea tailing placement. Recovery penambangan juga didukung dengan peningkatan produktivitas peralatan utama, seperti shovel elektrik dan juga haul truck.
Now, ladies and gentlemen, we would like to inform you that the next session with our special guest, the Honorable Menteri Koordinator Bidang Kemaritiman dan Investasi Republik Indonesia, Bapak Luhut Binsar Panjaitan, MPA, will start at 1:30 p.m. Western Jakarta time. So stay tuned and enjoy your break.
Welcome to PT GeoFix Indonesia. GeoFix is a multidisciplinary and multi-commodity exploration and mining consultant drawing all over Indonesia. With a band of highly skilled professionals as our core, GeoFix committed to maintain the highest standards and best practices, comply with the code and policies, and never compromise on safety, health, and environment in doing our business. We support all scope of mining enterprises to unravel their proficiency to fix, build, and enhance their assets' value through explore, discover, develop, and repeat. With the provision of innovative, reliable, and high quality of services and solutions, whilst nourishing state-of-the-art platforms and ecosystems in mining industry. Our services encompasses GIS, Greenfield Exploration, Brownfield Exploration, 3-dimensional modeling, geometallurgy, metallurgy, resource estimation, technical due diligence. We also provide drone LiDAR survey services, a high-precision aerial topographic survey provide reliable and accurate data for your project. GeoFix has diverse professional experiences in assessing across the range of multi-commodities and project stages. How do we execute a strategy and deliver a goal? Reputable expertise with passion, teamwork with state-of-the-art technical and non-technical capability, consistent and persistent management and stakeholder support. Guided by our values: respect, reputation, technology and innovation, breakthrough, quality and integrity.
The energy and minerals sectors are experiencing significant times, and the willingness to embrace and ability to harness change will become crucial factors to continuously move forward. Here at Petrosi, embracing this change is exactly what we continue to do. Established in 1972, Petrosi has been listed on the Indonesian Stock Exchange since 1990 and is now recognized as one of Indonesia's leading contractors that serve the mineral resources, infrastructure and oil and gas industries. In carrying out our operations, we are supported by our main shareholder, PT Indica Energy Tbk. Drawing on rich and varied experience throughout the Indonesian archipelago, we are now entering a new stage in our journey, harnessing emerging enablers to drive better performance and pursue new growth opportunities. With over 45 years of experience under our belt, Petrosi continues to be one of the most trusted contract mining service providers in the country, ready to tailor our integrated mining solutions for each of our clients. But experience is not the only thing that sets us apart. Our willingness to continuously innovate is also our winning factor. The company has taken a strategic step towards the transformation of our entire mining operations. With the implementation of new enablers within our other business lines also slated in the near future. We believe that the visibility and clarity delivered by these new enablers will enhance our agility, improve our productivity, and positively impact our future financial performance. Petrosi also has vast experience and expertise of providing engineering and construction project management and services, the mining and infrastructure industries, while constantly maintaining strong relations with key stakeholders such as the government, consultants, and communities to assist our clients in meeting their business goals. With the acquisition of PT Kuala Puebloan Indonesia in 2018, we have also continued to strengthen our ability to provide logistics services for the mining and infrastructure sectors. Petrosi provides services for the oil and gas industry in Indonesia through our Petrosi Offshore Supply Base, or POSB. From our deepwater supply base located in Sorong, West Papua, we consistently deliver international standard and cost-effective services to all of our clients. In 2016, Petrosi was officially inaugurated by the Indonesian government as a bonded logistics centre, PLB, for the oil and gas sector. Here at Petrosi, safety is our #1 priority. As one of our core values, safety, health and environment has become part of our culture, which is embedded in every employee. We continuously strive to achieve safe, efficient and productive operations, with an ultimate goal of zero harm to people, the community and the environment. Our talent is our key asset to be successful in the industry. Through our human capital management strategies, we have and will always strive to attract the best talents, develop their full potential and encourage them to become champions of the industry. Implementing quality management that fulfills our clients' needs and adds value to their operations is an integral part of our success. To this end, we persistently apply our Petrosi Quality Management System, or PQMS. By continuously improving our business processes, the system allows us to meet the requirements of operations, quality, as well as safety, health, and environment. A firm believer in the triple bottom line, Petrosi is committed to the implementation of corporate social responsibility programs that are directed towards local communities and the environment surrounding our operations, as well as our own employees and their families. By focusing on issues such as education, health, and economic empowerment, these programs will positively impact the betterment of their lives.
Petrosi is no stranger to innovation. Our continuous improvement program and portfolio balancing strategy has enabled us to navigate through sea changes within the industry and to continue to thrive throughout the years. In order to further improve our corporate performance, we are continuously enhancing our operational excellence, while always being very disciplined in implementing good governance across all elements of the company. Going forward, Petrosi will continue to transform and embrace change in order to successfully provide enabling solutions for our clients, thus creating value for the shareholders and also help create a better Indonesia.
terlalu mahal, beda dengan jualnya besar.
PT Nusa Halmahera Minerals adalah usaha bersama antara PT Indotan Halmahera Bangkit dan PT Aneka Tambang Tbk yang mengelola tambang emas Gosowong di Kabupaten Halmahera Utara, Provinsi Maluku Utara. Saat ini, perusahaan mengelola 2 tambang bawah tanah aktif, yaitu Tambang Kencana dan Toguraci, yang memiliki produktivitas dan potensi cadangan yang tinggi. Sementara itu, eksplorasi juga terus dilakukan secara agresif untuk terus menambah usia produktif tambang. Keselamatan kerja, serta kepedulian sosial dan tanggung jawab lingkungan selalu menjadi prioritas dalam semua kegiatan perusahaan. PT Nusa Halmahera Minerals menjadi salah satu industri penyerap tenaga kerja terbesar di Halmahera Utara. Kegiatan operasional perusahaan telah menjadi kesempatan bagi sumber daya manusia setempat untuk mengembangkan keahlian dalam bersaing secara global. Selain menambang secara profesional, kontribusi perusahaan untuk masyarakat lingkar tambang juga dilakukan dengan langsung menyentuh kebutuhan masyarakat yang sebenarnya. Di mana selain program pengembangan dan pemberdayaan masyarakat, perusahaan juga melakukan berbagai program tambahan sukarela lainnya. Seperti program bedah rumah, akses layanan kesehatan yang nyata, dan bantuan khusus untuk kaum duafa, anak yatim, dan lanjut usia. Menambang dengan hati. Itulah semangat yang diusung oleh PT Nusa Halmahera Minerals di Tambang Emas Gosowong, Halmahera Utara.
Welcome back from the break, ladies and gentlemen, and now we will continue to the next session with a special guest. Baik Bapak dan Ibu yang kami hormati, untuk selanjutnya marilah kita sambut keynote speaker berikutnya, yang terhormat Menteri Koordinator Bidang Kemaritiman dan Investasi Republik Indonesia, Bapak Luhut Binsar Panjaitan MPA. Selamat datang kepada Bapak Luhut Binsar Panjaitan MPA di acara konvensi tahunan MGEI yang ke-13. Baiklah, akan kami bacakan kurikulum vitae Bapak Luhut Binsar Panjaitan MPA. Beliau menjalani pendidikan di Akademi Militer pada tahun 1970. Kemudian, beliau memperoleh gelar Masters in Public Administration di George Washington University. Bapak Luhut Binsar Panjaitan MPA menjabat sebagai Duta Besar Singapura dari sejak tahun 1999 hingga 2000. Menteri Perindustrian dan Perdagangan Republik Indonesia sejak tahun 2000 hingga 2001. Kepala Staf Kepresidenan Republik Indonesia sejak tahun 2014 hingga 2015. Menteri Koordinator Bidang Politik, Hukum, dan Keamanan Republik Indonesia sejak 2015 hingga 2016. Menteri Koordinator Bidang Kemaritiman sejak 2016 hingga 2019, dan saat ini Bapak Luhut Binsar Panjaitan MPA menjabat sebagai Menteri Koordinator Bidang Kemaritiman dan Investasi Republik Indonesia sejak 2019 hingga sekarang. Kepada Bapak Luhut Binsar Panjaitan MPA, waktu dan tempat kami persilakan. Selamat siang, Bapak.
Selamat siang. Saya bisa mulai?
Bisa Bapak dipersilakan, Pak.
Assalamualaikum warahmatullahi wabarakatuh. Saya diminta untuk menyampaikan ini presentasi saya dalam kesempatan ini. Jadi saya akan mulai dengan bagaimana kita menghadapi COVID pandemic dan ekonomi recovery kita. Okay, ladies and gentlemen, let me begin about the COVID situation in Indonesia. Today is under control. If you look at this, the last 152 days since the peak of COVID-19, I think the status of COVID today under control. COVID situation in Jakarta and Bali the last 7 days. Also, if you look at the data here, next slide, looking much better. So, like Bali confirmed cases below left. This is December 12th. There's only 3 new cases. Like Jakarta confirmed cases also. 12 December 32, so the Harta population like 12 million. Jakarta dead case, I think 0 if you look at this one, the last 4 days, and Bali 0 and 1. Vaccination has accelerated also. More than 130 million Indonesians have received first dose of vaccine, COVID vaccine. Rapid economic recovery, consumption and production has returned to pre-pandemic level. Next slide. If you look at now, consumer index also improving very much. Indonesian manufacturing PMI has been an expansion area for 3 months in a row, which is I think very good. And investment performance remains stable and became the driver of economic growth throughout 2021. I think GDP and investment growth, slide number 11, and you look at the investment realization on slide on the right. And investment opportunity, I think rule of thumb for investment in Indonesia, there are 5. Environmental sustainable mean that all the technology have to be first-class technology. We don't want to see technology with unfriendly technology. Use local labor force, transfer of technology, value added, and doing this business B2B. This I think the rule of thumb that I always remind to the all investors in Indonesia. Ample opportunity in Indonesian investment priorities area, downstream mineral resources, lithium battery development, transportation, renewable energy, lowering carbon emission, which is I think Indonesia leading in this area. Downstream industry in Indonesia, if you look at this one also, very promising, so making our economy right now balance between Java, Sumatra, and eastern part of Indonesia area. Used to be like 70-30% in Java and Sumatra. Today, I think you got around 60 to 40%. Indonesia's abundant reserve of nickel, bauxite, copper, and tin that are area needed in clean energy. This is, I think, the situation today. We are heading toward this electric car. Hopefully by 2024, 2023, we can produce our own EV as well as a battery, lithium battery. Current nickel downstream development has focused on stainless steel, next to move towards battery component. If you look at the green color, basically already in place, but the red color is still ongoing. So what I'm saying is, used to be we just export source of ore left side, source of ore and left side and kiri, source of ore.
Paling kiri.
Kiri. Yeah. Used to be like this, but starting I think 2016 onward, we are ready and banned to export a source of ore. Now, Indonesian iron and steel export continue to increase, reducing current account deficit. Look at now, for today, November, up to November, I think 18 million something already our export. So we believe by end of this year, we can go up to 20 to 21 billion US dollar. Balance of payment also, I think if you look at the slide down the right, it's also looking good. And EV battery, production map like this, look at the nickel ore, MHP, up to recycling. So upstream to cathode, battery fabrication, EV, ESS charging, battery recycle. That's a thing also already in place. And we are now exploring cooperation with Indonesia and UK on cathode and nickel cobalt sulfide, which is ongoing. So this is, I think, another good collaboration. Most of coal production are exported. If you look at the next slide, and then if you look at also coal downstream DMA and methanol, there's also one project ongoing right now. Next slide, Indonesia. Okay, and look at the bauxite downstream to aluminium, Indonesia bauxite export. Next slide. The million of ton, look at this, and then value added stimulation based on 2021 price. You can see this one, and demand and production of aluminum in Indonesia, we still have a big gap on that. So this by 2025. So we need this industry in Indonesia. Minerals downstream industry has become the highest FDI contributor since 2018. Downstream of natural resources promote equitable investment. FDI investment share in Java continues to decline. So if you look at this slide right now, I would like to see the balance between Java, Sumatra, and eastern part of Indonesia. Downstream drive industrialization in eastern Indonesia, proportion of general Sulawesi, GRDP, proportion of national North Maluku, GRDP sector. Investment opportunity, if we move to next slide, Indonesia is committed to Paris Agreement. So this is, I think, you better read it and realize that we are can try very hard to meet the international request, but we need also have technology and finance. Indonesia has a great carbon pricing potential. I think I should say maybe Indonesia have like 75 to 80% worth carbon credit that come from forest, mangrove, peatland, etc. Indonesia has a great renewable energy potential along with progress toward carbon neutrality. If you look at the slide, I think you can see over there. The largest potential hydropower in North Kalimantan. If you look at this in total, 9,000 maybe to go up to 10,000 megawatt. North Kalimantan Industrial Estate investment, this is a new one. This is, I think, a giga project, I should say, because the size of investment over there, 6 million billion US dollar. This is a private, and this is, I think, carbon, green energy, and also still have some coal energy. But we add also with solar panel. Rare earths are needed to realize the renewable energy supply chains. I think you can see this one, European Green Deal aims to reach climate neutral by 2050. Complete composition of the tin ore strategy set in time in tin belt. You can, next slide. You can see the slide here. This is monazite and zircon, citrate, mineral, etc. So Southeast Asia, thin belts strengthened from Yunnan, China, to Indonesia, Bangka Belitung, Riau Island, and West Kalimantan. That's, I think, attract people want to invest over there. Indonesia is the second largest tin producer in the world with annual production 40,000 and highest annual record 70,000. Tin ore is associated with monazite and xenotime that's rich in rare earths. The conclusion or summary in general, the economic growth of Indonesia is quite stable. However, we should be cautious with the new variant of COVID-19. Economic recovery is highly dependent on how we can control a pandemic. The economic recovery can be accelerated with the economic transformation. Let's depend on the commodity and transition into the value-added economy through downstream. Downstream activity is various sector, especially natural resources, will boost Indonesia economic structure, strengthening its resilience in the global economic challenges. Through economic transformation, Indonesia will grow even stronger than before the pandemic to achieve Indonesia emas by 2045. Thank you.
Baik, terima kasih banyak Bapak Luhut Binsar Panjaitan, MPA, atas pemaparannya. Selanjutnya adalah pemberian memento secara virtual dan sesi foto bersama kepada Bapak Luhut Binsar Panjaitan, MPA, selaku Menteri Koordinator Kemaritiman dan Investasi Republik Indonesia, yang akan diberikan oleh Bapak Adi Mariono selaku Ketua Komite Bersama IAGI Perhapi. Kepada Bapak Adi Mariono, dipersilakan. Baik, kepada Bapak Luhut Binsar Panjaitan, MPA, dan Bapak Adi Mariono, apabila bisa lihat ke kamera. Oke, baik. 3, 2, 1.
Terima kasih, Pak Luhut. New spirit to our society.
Baik, selanjutnya kami akan mengundang Bapak STJ Budi Santoso selaku Ketua MGEI untuk ikut foto bersama dengan Bapak Luhut Binsar Panjaitan, MPA, dan Bapak Adi Mariono selaku Ketua Komite Bersama IAGI Perhapi. Baik, kepada Bapak-Bapak saya akan hitung dari 3, 3, 2, 1. Baik, terima kasih banyak Bapak Luhut Binsar Panjaitan, MPA, selaku Menteri Koordinator Bidang Kemaritiman dan Investasi Republik Indonesia atas ilmu yang diberikan. Terima kasih juga kepada Bapak Adi Mariono selaku Ketua Komite Bersama IAGI Perhapi, dan terima kasih juga kepada Bapak STJ Budi Santoso selaku Ketua MGEI. Welcome back, ladies and gentlemen, and now we have entered the next session. This session will focus on geometallurgy for sustainable mining. For this session, we have 2 speakers. Our first speaker is Ms. Didi of British Geological Survey, who will be speaking of critical material in bauxite and red muds. Our second speaker, Bapak Darius Varian Emil of Aman Mineral Nusa Tenggara, who will be speaking of geometallurgy application for sustainable mining in Aman Field. This session will be moderated by Bapak Omar Sharif of PT Aman Mineral Nusa Tenggara. But first, allow me to introduce Bapak Omar Sharif's background. Bapak Omar previously earned his bachelor's degree in geology engineering at the Bandung Institute Teknologi, or ITB, at 2003. His work experiences are Senior Geologist or Superintendent Exploration Indonesia at PT AMNT from 2017 until now. He was also a Senior Geologist at PT Finders Resources Ltd from 2013 until 2017. His professional backgrounds include 18 plus years of experience in mining industry in Indonesia, Oman, Saudi Arabia, and Kazakhstan. He is also a competent person in Indonesia, or CPI, for copper and gold commodities. And he's also a variety of geological settings in the porphyry, HS, LS epithermal, skarn, VMS, SEDEX, Carline, etc. His recent publication is by Omar Sharif, Ambang Wisbag Yono, Chris Farmer, The Application of Area Selection Criteria, or ASC, for exploration of economically viable volcanic massive sulfide, or VMS, deposits at Watar Island, Southwest Maluku, Indonesia, published in Balikpapan with the preceding of GJCB 2015, Indonesian Geologists Association, or IAGI. To Bapak Omar Sharif, you may now take the lead. Hello, Bapak.
Hello, Pak. Thank you for the introduction, Pak. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Salam sejahtera untuk kita semua. As already being introduced, my name is Omar Sharif, and I will be moderating next discussion session in 2021 Annual Convention of MGEI. And our discussion topic is geometallurgy for sustainable mining activities. Ladies and gentlemen, if I may, I will begin these sessions with read out one simple definition of geometallurgy just for our refresher. Karen Hall in 2008 has described that geometallurgy as an integration of fundamental economic geology and deposit mineralogy into the process of designing mine plans and resource recovery scheme. So there are at least three important aspects from the given definitions. First one is geological aspect, second, processing aspect, and the third one is production aspect. I guess that's enough for introduction and refreshing. Ladies and gentlemen, we will continue with presentations, and we will have two presenters in the sessions. And please, for committee to share the first presenter CV. Thank you. The first presenter is Amir Dedi. Apologize if I mistaken to pronounce your name. Now it's working in British Geological Survey. Her background is graduated from University of Edinburgh as a Bachelor of Science in Geology, and then continue as Master of Science in Mining Geology at Camborne School of Mine. And just after graduate, Amir working as an exploration geologist in mining industry, first in Congo Resources and first Quantum Mineral, I believe that's in Africa, and then start in 2013 until now, joining British Geological Survey as one of member of the Carbonization and Resource Management team. And Amir has note some publication here. It's mostly in rare earth elements, and it at different geological setting, at least carbonatite, alkaline igneous rock, bauxite, and as well the red mud. I guess that's all for the CV. And without further ado, I would like to welcome our first presenter, which will deliver presentations, critical raw material in bauxite and red mud. Ladies and gentlemen, please welcome Eimear Dedi of British Geological Survey. Eimear, the floor is yours now.
Good morning, good afternoon. Thank you very much for this very kind introduction. I'll just share my screen. Are we good?
Yes, sure.
See that? Yes, thank you very much. First of all, I would like to thank the organizers of the conference for inviting me along to deliver this talk. I appreciate you all waiting to hear it as well. So I am going to talk to you this afternoon about critical metals in bauxite and red mud. This is mostly based on work that I've done over the past, I guess, 5 or 6 years, and looking predominantly at rare earths and critical metals, but I'm going to talk a little bit more about some other critical raw materials that occur in these deposit types. First of all, I'd like to say that the research that was done on these deposits was supported by the European Commission under the EU Rare Grant, and I also work closely with colleagues in ETI Aluminum and the Greek bauxite mines as well, who supported us by providing samples and access, etc., when we were doing our fieldwork. So first of all, a little bit more about the rare earth elements themselves. They are a group of elements that occur all together, and they're typically mined from deposits such as carbonatites and alkaline igneous rocks. However, the production of which is dominated by China, which in 2019 produced over 70% of all the rare earths globally, while a couple of other countries such as USA, Burma, Vietnam, Australia, Malaysia produce smaller proportions of the global rare earth element production. The main uses for the rare earths, well, they actually have quite a lot of different uses. But one of the big drivers for rare earths at the moment are their use in permanent magnets, particularly the elements neodymium and dysprosium. And these magnets, these permanent magnets, are really important at the moment because of their use in things like wind turbines and electric vehicles. However, rare earths are also used in things like in ceramics and glasses and in the catalysts for petroleum refining. And they're also used in certain batteries, lasers, and in pigments and lots of other applications. So it's quite a wide range of things that we actually use rare earths for, although we all talk about magnets all the time. So I've kind of mentioned this critical raw material. So what is it? Essentially, you're looking at comparing the economic importance of a commodity, usually in your own economy or in a group of economies. And this, you would be looking at things like the demand or how much of these commodities that you might use in your own country to manufacture goods. And then you're looking at the security of raw material supply. So this is what we call the supply risk. And some of the things that impact on this is the high market concentration geographically. Now, I've said for the rare earths that over 70% were produced in China in 2019. If you look back to 10 years ago, that was over 90%. So we are seeing a reduction in that concentration of production geographically. However, they still plot quite high here. If we look, change my pointer. See it. So you can see here the supply risk, that the rare earths themselves are still ranked as incredibly high in terms of supply risk, but actually kind of middling in terms of economic importance when you compare it to things like tungsten or cobalt, niobium, magnesium, etc. Now I've copied some things here. This particular graph is from an EU report in 2020. However, the EU have been producing these reports since 2014, and the rare earths have always been high on the supply risk, and they've always been classified as critical. And if you look at some work the BGS did back in 2015, the rare earths were right up there in terms of having a very high supply risk in what we call our risk list. And the USA also included the rare earths as a list of critical minerals. Now, rare earths are not the only thing. I'm going to mention things like scandium and gallium, and of course, if we're talking about bauxite, we're really talking about aluminium here. And we'll talk about a couple of other elements later on in the talk. So if we talk a bit more just about the demand, if you are really interested, I'd point you towards these two particular reports looking at the Minerals for Climate Action and Metals and Decarbonisation, as these really indicate why there is such a demand for minerals, particularly for the clean energy transition. So what the World Bank is predicting is that because of the enormous economic growth we're undergoing, COVID aside, the annual global use of metal will more than double between now and 2060. So you're actually talking about less than 40 years. And in order to actually achieve that, we're going to have to really change our mineral and metal production and how we approach it. And just I focused in here on aluminium, and actually it's important. The aluminium itself, other than the rare earths, is important for wind, photovoltaics, energy storage, and it's used in nuclear, coal and gas industries as well. So the actual demand for the raw materials that we're talking about is enormous in terms of actual decarbonisation. I'm talking again about these wind turbines and these direct drive wind turbines. This is what I was talking about, where this permanent magnet sits in, and you can see that the size of the wind turbines has increased enormously. We're looking at things that are now nearly 300 meters high. And so the amount, as the size of the wind turbine grows, the size of the magnets, of course, also grow as well. And so there's an increased demand for rare earths such as neodymium and dysprosium. And of course, the aluminium to actually build the wind turbines as well. So where do we really get all our aluminium from? Well, it mostly comes from bauxite. And bauxite essentially is a sedimentary weathering product, or sometimes also called a residual weathering product. It's enriched in aluminium and iron, and it is low in silica. Global bauxite production in 2019, you're looking at almost 350 million tons of bauxite being produced, which is then converted to alumina and then aluminium metal. And here are just some images of what it looks like in the field. It can be quite variable how it looks, and this is a really nice image of an ooidal bauxite from in America. So how does it actually form? So here in the background, I've got pictures of I believe this is the Dogonkuzu deposit where we did some of our work, which I'll present later. And essentially, where you have moderate temperatures and you've mildly alkaline fluids, that you're ending up in these deposits, you're ending up with feldspar and kaolinite breaking down, and you're releasing your silica, and you end up with an aluminium-rich residue which remains in the deposit. And these usually occur where you have tectonically stable, you've got paleoclimatic conditions where you have sustained weathering, it's humid, it's tropical, and you end up with a chemical weathering rather than erosional process. And it's important that you also have these permeable ground conditions, so the fluids which are carrying your silica are able to essentially flow away from the deposits, leaving behind this iron and aluminium-rich residue. Now, if we have a look at this map, this is, I'd highly recommend reading if you're interested in gallium, the Schulte and Foley report from the USGS in 2013. They've produced a really nice map. Now, you can see here that there's symbols for karst bauxite and lateritic bauxite. Now, the work I've done on has been on karst bauxite, and I'm going to talk a bit more about that. But of course, particularly in Indonesia, there's an awful lot of lateritic bauxite, but we'll talk about that at the end. But you can see that along the current equator that there's an awful lot of lateritic bauxites forming, while in Europe and in China, you can see that there's a lot of karst bauxite that was previously formed. So if we delve a bit deeper, as I say, particularly into these karst bauxites and how we end up with rare earth mineralization in them. So there's a lot of different parameters you need to consider when you're thinking about how rare earths form within these deposits. First of all, how the actual bauxite itself forms. So here we have just a stylized This is our limestone. So a karst is essentially a weathered limestone surface, which you may or may not have seen before. And as I said, you end up with these depressions or cave systems almost filling in with detrital material from just general erosion in the area. Now these depressions fill over quite a long time, or they can actually fill quite quickly as well. And they have particular zones within them. So in the top levels of the surface, you end up with these oxidation zones. And as you go closer to the limestone base or the carbonate base, your pH is decreasing. And then you end up in actually quite a reduced zone. So as water is flowing through, as I mentioned, this carbonate can be very porous with its clints and its grikes and its significant kind of fracture systems within it. So there's real great fluid flow through it. The material itself is, because you're in these weathering zones, it's typically quite high iron content. There's lots of ligands in here. Things like fluorine and chlorine are actually carrying your rare earths from your upper parts of your deposit down through your bauxites forming. And what's important is that, as I mentioned, there's a decreasing pH. The pH of the actual limestone is highly alkaline and is considerably different to that. And this geochemical barrier is really important when we're talking about the rare earth. So if we work our way down through the deposits up here in the oxidation zone, what do the rare earths look like? So here the cerium 3+ gets oxidized to cerium 4+. So you end up with a mineral called cerianite, which sits up here. Typically in these fractures, you can almost see here kind of a botryoidal form. So the minerals are precipitating along these fractures and infilling, and you can see it's quite extensive. All these kind of bright bits here on these SEM images are cerianite forming within the bauxite in this top level. Now, as we go down through the deposit, you can get what's called orthogenic rare earth minerals or detrital rare earth minerals. So first of all, detrital are just minerals that have just essentially been washed in or have been eroded and then ended up within the bauxite. So they haven't been formed within it. So things like xenotime, monazite, maybe even some other phases might be there as well, but these are the most common ones that I found. And these can occur disseminated throughout the deposit. They can be this core of like an ooid or a completion within the bauxite. They can be quite rounded. It can be quite angular. They're quite variable within it. And then we have what are called orthogenic rare earth minerals. So these are minerals that actually form within the deposit. So I mentioned that you have this changing pH, you have ligands, and actually things start to precipitate within it. And here you can see what we call their fluorocarbonates, so things like the bastnasite group minerals. And you can see that they're bright here. There's some here in this fracture. So essentially fluids have cooled, the rare earths themselves have precipitated as fluorocarbonates in this example. And you can see that they're filling spaces and things like that. And as we go down into this reduced zone at the bottom of the deposit, as I mentioned, you have this very different geochemistry, so that the pH is significantly different and creates this geochemical barrier. So what it looks like at the bottom of the deposit, you can have clasts and rubble of carbonate, and then you have this infill matrix. But what actually happens along these edges at the bottom is that the rare earths themselves, the fluids are continuously flowing. You can see here as they continue on into the cracks. But the rare earths themselves can't cross this geochemical barrier, so they remain trapped. And essentially the fluids become saturated with rare earths, and you end up with mineral formation along these edges. This mineral is parasite, which is another of these fluorocarbonates in the bastnasite group. So you can actually have rare earth minerals themselves forming at the bottom of a bauxite. So what happens to the bauxite at this point? Well, as you all probably know quite well, it turns into alumina at usually through something called the Bayer process before it's then processed further into aluminium. And this is just a picture of a alumina or a Bayer plant in Limerick in Ireland. So what's actually produced? So as you mine, crush and process your bauxite and then put it through this Bayer process becomes alumina. But alumina is 99.9% pure. So all the other elements, as 99% pure aluminium oxide. So all the other elements that are in it end up in the waste, and you end up producing something that's called red mud. Now, for every ton of bauxite that is produced, you end up with 1.5 tons of red mud. And you can see what the ponds look like. You may have seen them yourself. They're essentially enormous slurries. They're highly caustic. They're really quite unpleasant. But we did sample these, and these are from our Turkish colleagues, this is from the mine site of our Turkish colleagues. Now, the typical content is about 1,000 ppm, which is 0.1 weight percent, which compared to something like a carbonatite, which would typically have 10,000 ppm, is quite low. But when you think about the bulk amount of it, it's a significant resource. And this just shows that the bauxite, there's essentially, as you process the bauxite and you release your rare earths, your red mud actually you're able to capture the information about the rare earths, and you have a much higher level of rare earths in your red mud compared to your bauxite. These are data from a selection of bauxites from Greece and from Turkey, and then the matching red muds, the data from the matching red muds as well. So how far have we come in terms of actually extracting rare earths from these red muds? You might ask why we look at the red muds rather than the bauxites. And that's because if you remember the pictures I showed you of the bauxite, they're very heterogeneous. So what the processing engineers were aware of, that when you obviously crush everything and blend it, it becomes much easier to manage. What people generally envisage when they talk about extracting rare earths from something like red mud is that you would have your normal buyer process, and then you would maybe add another circuit, like you would add a gold circuit. You would add a rare earth circuit to your red mud before it ends up going into the ponds. The other thing to consider about it is that rare earths, as I mentioned, are particularly small proportions. So you wouldn't really be dealing with it in terms of managing waste, because you would only be stripping out a very small proportion as you strip your critical raw materials from it. Anyway, that is an aside, just some caveats to this, or how people are thinking about it. There's actually an enormous amount of work that has gone in to looking at the extraction of rare earths and other critical raw materials such as scandium from bauxite. There's some really interesting work gone on in ionic liquids, in bioleaching, and of course acidic leaching. And you can see here this long list of literature references here where people have been working on this for quite a long time. And this EU Rare project that I mentioned that funded this work, a whole work package was on processing of red muds. So there's loads more information there. Now, what I will say is these are all pilot scale. These have not been moved up, but you're kind of talking bench to pilot scale. They haven't really been brought further along than this, but there's still lots of people really interested in this, given the scale of red muds that are produced globally. Now, what I have said so far is I've kind of given overviews in terms of the rare earths, but however, there are other critical raw materials that occur in bauxite. Scandium is one of the other elements that apparently more than 70% of global resources of scandium actually occur in bauxite and bauxite residue. You can get, nearly 0.28% scandium in bauxites in Suriname, while you're looking at 135 ppm scandium oxide in Russian red muds. There is significant amounts of scandium. When you consider how small the scandium market is, it would be very easy to flood the market with it if this tech was developed. But at the same time, it's definitely an alternative resource for scandium. Gallium itself is resources are primarily from bauxite, and from the average content for karst bauxites is approximately 60 ppm, but they range from less than 10 to 180. Now, what I've been talking about here, of course, are the karst bauxites, but what you may in fact be more interested are in these lateritic bauxites. Now, one of the interesting things is that gallium, so there's not a huge amount of information about rare earths in lateritic bauxite, but there's an awful lot of academic interest in it. Gallium itself, there's actually Schulte and Foley showed in 2013 that statistically there isn't really much difference between karst bauxites and lateritic bauxites in terms of gallium content, and so that there is plenty gallium also in the lateritic bauxite types as well. But of course, what you are probably most interested in are, of course, the PGMs and the cobalt, which are associated with the more nickel-rich laterites, depending, of course, on the control being, of course, the bedrock that the laterites are forming on. But just as some examples, and some examples from work that's actually going on, colleagues in Indonesia, of course, that there is a real interest in critical raw materials and lateritic bauxite. And I think that it's an area that's growing. Karst bauxites have been researched probably since the 80s or 90s in terms of their rare earth content, other critical raw materials. But I do think that given the interest and the switch from, say, sulfide-rich sources for nickel more to the nickel laterites, given the increased demands, as we just saw as well with your minister in terms of nickel for electric vehicles and batteries for electric vehicles, there's real interest in increasing nickel production. But what's very interesting, of course, is the critical metals associated with those nickel-rich laterites. So these are just some examples. So New Caledonia is people are looking at scandium and rare earths and various transition metals in nickel laterites in New Caledonia. There's real interest in similarly in Cuba and the Dominican Republic. And then, of course, there's quite a lot of publications on critical raw materials and laterites from Indonesia as well. So looking at scandium, rare earths again, nickel and other critical metals. So there's a real interest in this. I think there's some real scope. I think there's quite a few gaps in our knowledge, and I think we could probably learn from the knowledge we have from karst bauxites and see how much of that is transferable to lateritic bauxite. So I hope I've given you hopefully a brief overview of some of the critical raw materials in karst bauxites and hopefully giving you some food for thought in terms of critical raw materials and lateritic bauxite. So I'm going to leave it there. Thank you all very much, and thank you again for inviting me.
Thank you for the presentations, Eimer. Very well delivered and very interesting indeed. Thank you very much. Ladies and gentlemen, please give a big round of applause for Eimer Dedi. Okay, now it is time for the second presentations. The session for question and answer will be joined together after the completions of the second presentation. So please allow me again to introduce the next presenter. Darius Parianemil. He is my colleague from the office. He is metallurgist from Aman Mineral Nusa Tenggara. His background education is metallurgy from Institute Teknologi Bandung, and his experience include Freeport Indonesia, Merdeka Copper Gold, and the last one is Aman Mineral Nusa Tenggara. So let's welcome Darius Parianemil, metallurgist, which will deliver presentations on processing aspect with title Accurate and Practical Ore Hardness Mapping on Batu Hijau Deposit using the HIT Hardness Index Tester device. Pak Darius, the floor now is yours. Pak Darius?
Excuse me, Pak Umar, Since there are weather condition in the location of Darius, we may wait for another 5 or 10 minutes. Thank you.
Pak Darius mungkin bisa dilanjut untuk tanya jawab dulu dengan Bu Emer, karena Pak Darius sedang keluar dari Zoom begitu karena ada masalah teknikal dari site.
Okay then, we'll just continue with the discussion session, everyone. Everyone on the floor might raise a question or comment to the first presenter by raising your hand. We have approximately 20 minutes actually, while waiting Pak Darius to be arrived in the discussion. Please, for everyone who have questions or comments about the first presentations. Pak Andi Yahya.
Hello, good morning, Aymar.
Good morning. Hi, Andy.
Hey.
Or good afternoon.
Yeah, I'm sorry. Okay. I just wonder that in Greece and also in Turkey, you have been working with the karst deposit, bauxite with the karst environment. Is there any possibility to find another rare earth minerals in the lateritic environment? Because you said that loparite and then other rare earth minerals are always related with the carbonate. How about the lateritic type? Thank you.
No problem. So as I said, I work on karst bauxite, not lateritic bauxite. But my understanding of it is that you can definitely get rare earths in these lateritic bauxites. But I think the control of that will be the bedrock. So I haven't worked on it, so I'm not sure. But I think that where you have lateritics forming on, your bedrock control will be incredibly important in terms of which rare earths. So, I mean, essentially, if you think about something like a ion absorption deposit, it's not exactly a laterite, but it's something a bit similar. It is a weathering deposit on top of a rock where there are rare earths within it, and they're ending up in this residual layer. So the concept is very similar. So I think if you find the correct rock types and where your laterites are forming, so maybe something granitic or maybe something more alkaline, it will be definitely worth at least checking for your rare earths, at least, analyzing, your assays, including rare earths in your assay element list to check for it. I think my understanding of things in Indonesia is that you have quite a lot of ultramafic laterites forming on ultramafics. Is that correct? So I guess you may be more interested in things such as scandium, cobalt, the PGs, but I guess that's maybe more well understood than the rare earths. But I think what I'm quite keen on and what I'm very interested in is ensuring that the full metal budget of a deposit is exploited. Because I don't think there's anything positive or sustainable about ending up with things like rare earths or cobalt ending up in your waste material. So I think that's really the angle I come from, is that everything is exploited. Now, of course, this isn't always entirely straightforward. It might not always be economic. It might be in insufficient amounts, but I think at the very least, understanding what is in there, what form it takes, the mineralogy, the petrography, the geometallurgy of your deposit, that's what's really important. I can see that, you know, there's quite a lot of work ongoing already in Indonesia on rare earths, and there's quite a lot of research ongoing. And I think that the comparison, perhaps, maybe comparison is too strong a word, but you know, understanding of the differences between the rare earth content in karst and in laterite, and the controls on the formation of rare earths in laterite. I think there's a gap in the knowledge, or at least to my understanding, there's a bit of a gap in the knowledge, and I think there's real scope for lots more work in that area. And I think Indonesia is probably a great case study for it, and it'll be really interesting to see what comes out of from researchers in Indonesia in the next few years.
Thanks. And I'm just wondering, how big is the rare earth in bauxite, not in red mud, in Turkey or in Greece? Do you have any value in your mind?
As in how much?
Yes, how much? I'm sorry.
Oh, sorry.
I mean, the concentration of rare earth elements in the bauxite, not in the red mud.
In the bauxite, so typically around 500 ppm, and then as you crush and release everything from, so that's how much they can get from the bulk, and then as you crush and release everything through the Bayer process, you end up with about 1,000 ppm in your red muds. It's typically 1 to 2. It's the ratio. Now, what you have to remember, of course, is that not all red muds are created equally. Not all red muds are just from karst bauxites. And so I think understanding the rare earth content of your lateritic sources versus your karst sources, because they often blend them at these alumina plants, they blend them to get exactly the right aluminium content, I guess, and that will of course blend all your other elements. And so I think that variability between deposits and possibly between red muds as well. I don't think all red muds are created equal, because of course you'll have that control in terms of the original content in your original various different types of bauxites. So, but I think that's what makes it really interesting.
Okay, thank you.
No problem.
Okay, the next questions from Pak Joko Wijayatno.
Can you hear me?
Yes.
Yes? Okay. Through the genesis of rare earths, the possibility of occurrences in Indonesia was in west area. If I refer to your map, this is in Bangka, in Belitung Iron, and a little bit in West Kalimantan. But yeah, but the content of rare earth is very, very low, and how to explore then to make sure that this have economic value. Because if today we refer to the exploration cost is very high, but the result is very low. But this is also important mineral for us. Thank you.
Yes, and I think you've hit the nail on the head there. The economic value of the rare earths is absolutely the limit, I guess, to it. So if you, like I said, so if you compare it to something like a carbonatite or an alkaline igneous rock, you're looking at kind of minimum 10,000 ppm rare earths within those deposit types. In something like bauxites or red muds, I can only really speak for the karst types. You're looking at maybe 500 ppm in your bauxite and 1,000 ppm in your red mud, which is obviously tenfold less than your kind of minimum amount you'd need in a carbonatite. The other things to consider are the fact that the processing has not yet been developed, although there's a lot of interest in it. Perhaps, you know, I think there would need to be a significant investment in this type of deposit if it was ever going to happen. But I think for me and for the other people that are researching this, what's more important is that we recognize that these resources exist. We might not be able to extract them, but if it, worst comes to worst and we have to, that we know what we have in the ground. I think that's where it comes from. And yes, I totally understand how difficult it is to convince bosses of mining companies and exploration companies to add elements to an assay, increase their costs, etc. So yes, you've the economic limitations and restrictions on it are the number one challenge, really, probably coming to in this particular deposit type. But if you're already extracting it for aluminium, and it doesn't cost that much, maybe to add on a rare earth circuit, I'm very keen to try and extract something out of these extra, because there's also gallium, there's scandium, and if your circuit's able to extract scandium and rare earths, does it suddenly become more viable?
So may I have the second question?
Yeah.
So for a long time ago, we have bauxite deposit in Jintan area, and all the tailing was sent to the dam and still there. It's a possibility that the rare earths still there, because the processing only washing at a time at the beginning of 80s, and all the tailing sent to the dam. What is your opinion? Is any possibility there to find?
So what I would love to do, and what I always want to do, is actually get a drill rig at the top of a red mud deposit and get profiles down through a red mud. I think just in terms of your particular deposit, what would be important is if the tailings dam was aligned, what it was lined with, or because the rare earths are very mobile, so they would happily leach away if the fluid conditions were right for them. That would be the first thing. The second thing would be what we really don't understand is the mobility of rare earths. Is it like in the bauxite? Do they move with changing pH throughout it? Becomes more alkaline at the bottom. So do the rare earths actually sit at the top, or are they immobilized by the pH of the red muds? That's not something we understand. The other thing is that if you go back to the kind of economic side of it, it depends. So if you have ongoing alumina production, then to my mind, it makes more sense to add something onto a currently functioning circuit rather than extracting red muds and potentially, running the risk of releasing metals or pollution to the environment. That would be my general feeling. However, I also know that, not specifically for bauxite, but in certain deposits, the processing, the buyer is very efficient, so it's not necessarily a good example. But definitely for other deposit types, people are absolutely reprocessing tailings to try and get extra gold or copper or whatever valuable metal out of it. So I think there is definitely scope for reprocessing tailings. Whether you would reprocess red muds to something like rare earths, I suspect is probably a no. But I would really love to know more about the geochemistry of rare earths within red muds, within the profile of the red muds, and I think that would be a really interesting thing to know more about.
Well, excuse me, Emil and Pak Joko.
Yeah, thank you.
We'll continue the discussion later because our second presenter is already joining with us. And
lovely. Thank you very much.
Okay, thank you.
Just keep the question for the next. Okay, Pak Darius, are you already here?
Yes, I am.
Okay, let's again. I have to introduce Pak Darius Parinemio. He is a metallurgist from Aman Mineral Nusa Tenggara, which will deliver presentations on processing aspect with title Accurate and Practical on Batu Hijau Deposit using the HIT Hardness Index Tester device. I guess the introduction through CV is already being delivered. So now you just directly to the presentation, Pak Darius. The floor is now. Now is yours, sorry.
Okay, thank you. Could someone share my presentation? Okay, thank you. So first of all, I would like to say thank you for the invitation and the opportunity given to me by MGEI. So my name is Darius, and as a metallurgist, to be honest, I feel happy and but nervous at the same time to speak about the geometallurgical in front of the geologist community. So on this occasion, I would like to share information related with the geometallurgical application in Aman Mineral Nusa Tenggara, which focus on the ore hardness. So I would like to start my presentation by asking a couple of questions. So first, why does ore hardness matters for metallurgy? And the second question is, do metallurgists only require information related with the assay and mineralogy from the geologists? And the answer is yes. The ore hardness is important, is required information for metallurgists. And in fact, it is as important information as assay and mineralogy information. There are a couple good reasons, but the strong one is first, if you talk about the copper sulfide minerals, which the practical technique for the processing is flotation. So to be efficient in the process, the size reduction of ore from rock into a fine dust is important. It's a must, especially. And then logically, you know, when the ore becomes harder, logically, it becomes more difficult for the size reduction process will be. Then at the end, all information related to the ore hardness is very important to accurately design the plan and selecting the size of the equipment itself. And the second question, so the second answer or the second reason about why ore hardness information is important for us as a metallurgist, because that's related with the synergy between mine and mill that everyone talk about. So by knowing the ore hardness information, metallurgists, mine engineers, and the geologists can work together to develop a strategy for blending. So the crushing and the milling circuit won't become a bottleneck. In this case, we want to ensure that the milling rate is matched with the ore delivery or the mining rate. I think that's all for the introductions, and the outline of my presentation would be, I will start with the brief introduction about Aman Mineral and also the Batu Hijau deposit, then continue with how metallurgists define the ore hardness, and then we discuss briefly about the hardness index texture, or later known as HIT in Batu Hijau application, and then we wrap up our discussion. Okay, next slide, please. So who we are? So we are Aman Mineral Nusa Tenggara, who currently operating Batu Hijau copper and gold deposit located in West Sumbawa, Indonesia. So by Aman Mine site, all employees talk about how to create a legacy of waste by briefly in thinking. And so we constantly challenge ourselves from the status quo. So in this case, I proudly say that the HIT application in Batu Hijau or in Aman Mineral Nusa Tenggara is the real example of thinking bravely. Why? Because first, the technology or the device itself is considered as new for industry around the globe. And the second, no industry or laboratories in Indonesia ever used this device before. So Aman Mineral is the first user of hardness index tester to measure the earth hardness. Yep. Next slide, please. So on this text, on this slide, I'll just give the brief overview about the Batu Hijau deposit. On the left picture, you can see the lithology of Batu Hijau deposit, which consists volcanic diorite, intermediate tonalite, and a young tonalite. By the rule of thumb, the young tonalite in the center is barren, then followed by the volcanic, which is we define as a low grade, and diorite is a medium grade, and then the last is the intermediate tonalite, which is contain lots of copper or high grade. And on the right, in terms of the mineralization, the copper minerals is dominated by the chalcopyrite and bornite. Then the gangue is dominated by the pyrite itself. So what interesting fact is the ore grade or the copper content follows the ore hardness. In this case, once the copper grade become increased, we should expect the ore become softer. That's the rule of thumb. So for the practical operational, we know that we will have in the mill, we expect the lower milling rate when we receive significant amount of the volcanic lithology from the mining deposit, and we should expect high milling rate if we receive the significant amount of intermediate tonalite. Okay, next. Okay, on this slide, I would like to share about two key variables in defining the ore hardness from metallurgical perspective. So in general, there are only two variables to define the ore hardness from metallurgical perspective. First is AB, and then the second is, we call it as a WIBM. So on this slide, I will talk about the AB index, and then on the next slide, I will talk about the WIBM. So what is the AB index? So this is a well-known standard in mining industry that developed by the JKMRC a couple of decades ago, and that's really relevant with for the crushing or sub milling application, which the breakage of the rock is influenced or driven by the compression. To simplify all the process or the understanding, so ore becomes more resistant to impact or becomes harder if the AB number gets lower. And the AB index traditionally is generated by the device developed by JKTech. On the left, on the right picture, we call it as a drop weight tester. And later, the procedure is being simplified by the test name SMC, which developed by Steve Morrell. But in essence, it's just a reduced version of the classic drop weight test, but still using the same machine to generate the number. In summary, the tests above are well-defined and well-established and well-known in the mining industry standard, but it requires significant amount of samples, and the procedure itself is quite complex. Okay, next. Okay, on this slide, as promised, I will like to talk about the WIBM, so the second variables to define the ore hardness from metallurgy point of view. So the ore hardness itself is defined as the work index for the ball mill. So in simple words, it's defined how much energy required to reduce the size of the material from rock or pebble into a fine dust. That's the simple definition of the work index ball mills. In simple words, the ore becomes more difficult to be ground as the numbers get higher. And the index is generated by the device or the machine on the right picture, named the ball mill test. Similar with the drop weight tester, is well established, well known, but requires significant sample. And also the procedure itself is quite complex. Okay, next slide. Okay, then on this slide, I would like to introduce about the hardness index tester or HIT that intellectual property owned by the SIMSACI. So the device in general is engineered and the main objective is to significantly simplify and reduce the amount of sample required and also to simplify all the procedures required to test the ore hardness by using the conventional method. In this case, is drop weight test, SMC, or work index ball mill by bond. So the idea is to simplify all the process, but without really compromise the result itself or the integrity of the data itself. So if you can take a look on the upper right picture, that's the heart of, that's the concept of the A/B test and also of the HIT. So I know you are wondering what is the A/B meaning. So the A/B mean is if you're able to plot specific energy on the x-axis and also the number of fines particle on the y-axis. So the drop weight index conventional and SMC try to construct the full curve, and the AB is just the constant of the curve. By definition, written in the JKMRC monograph back to 1966, that the AB is defined as the slope at zero energy. So the idea of the HIT in simple is try to measure the AB index by testing the rock at the low level energy only. So from the vendor itself, from the SIMSACI, it's possible to use only 10 rock fragments to generate a number of 80, but at Batu Hijau, we use 30 rock fragments just for the sake of improving the sample size to increase the accuracy and the precision of the AB measurement number. To test about 30 rock fragments, it's required only less than 10 minutes at the laboratory. The practical benefit, if you can take a look on the device itself, it's safe and easy to use and simple calibration, and it's just a simple device. The dimension or the size of the device itself is equal to desktop PC, and it's no power or air hydraulic required. And later we know there is a strong correlation between the laboratory result from HIT device to WIBM. So we can educated estimate the WIBM by using the same machine. So if possible, I prepare a video to give a better visualization to you guys about how this machine works. Yep, just play about 5 or 10 seconds to give a better illustration. So it's pretty simple. You just put a 20 milliliter rock fragments into the cup and you drop below, and then you then do a sequence and we can measure the ABI. I think that's enough. Okay, now this slide will talk about the more detail about the update of ore hardness mapping at Batu Hijau deposit. So in general, we complete all the project within 6 months only, considering the challenge nowadays, which is the COVID-19 pandemic. And it involved 326 drill core samples with only 10 centimeter length. Anyone who familiar with the drop weight test or SMC know the samples is significantly reduced by using the HIT. And The success criteria also, we report 0 safety accidents. So that's the good indicator that the device itself is met the industrial standard. And also, once I give all the data to the geologists for the geological modeling, zero retest ask from the geologists for the validation, meaning that even all the procedure and the sample tested significantly reduced, but the integrity of the result is still valid. 4 photos below only give an illustration about the core samples, the rock fragments at diameter 22, and the uncrushed sample on the cup, and the crushed sample on the cup. Okay, next please. Okay, and that's the result. On the left picture, it shows the full drill course plotted in the deposit, with also the legend about the number, the AB index with all the definition from very hard until the very soft. And 2 pictures on the right just show the geological block model for the AB index. And yep, in summary, by briefly in thinking from the geologists and metallurgists in Aman Mineral Nusa Tenggara, we successfully update the ore hardness mapping by using only 326 core samples within 6 months. That's equal to about 10,000 rock crush, and all the tests and analysis were performed in-house. And in summary, if we relate back to the lithology, we know that that intermediate tonalite tends to have a high AB index, which is soft, in contrast with the volcanic and also diorite, which have low AB index number, which is we classify as hard material. Next. I think that's the end of my presentation. If I can wrap up. So we, in the beginning, we discussed about the Aman mineral mindset, and then we discussed about the Batu Hijau deposit. Then we discussed about the 2 key parameters, how metallurgists defining the ore hardness. We jump to the discussion about the conventional way to quantify the AB index and the WIBM. Then we continue with the alternative method, which is heat that being applied in Batu Hijau. And then we discuss about the result, and we satisfy and success the program of heat within only 6 months. I think that's all of my presentation. Thank you.
Thank you, Pak Darius, and well done. Very well delivered, and it is very enlightening for most of us as a geologist. Thanks again. Thank you very much. And ladies and gentlemen, please give big round of applause for Pak Darius Parianamil. And now we back to our discussion session. Everyone on the floor might again raise the question for all 2 speakers, 2 presenters by raising your hand. And I hope we still have about 15 minutes for these sessions. Pak Janjan, please, Pak Janjan.
Okay, thank you. My question is to Pak Darius, basically. So, Pak Darius, have you applied or have the result comparison between your study with Yemio or Prasov? And what's the relationship? Is that more correlate with the Prasov or Mio or both? Thank you.
Okay, Pak Omar, should I answer Pak Janjan question directly?
Yes, please.
Okay, thank you. So Pak Janjan, yeah, it is a very good question, and to be honest, I forget to mention the ultimate objective of updating the ore hardness in our geological block model. For sure, the paramount or the main objective is we want to accurately predict the milling rate, or in this case, the milling rate of the crusher on the SAG mill? Yes, the answer is yes. By upgrading our knowledge in terms of the ore hardness by using this device, now AMA Mineral able to predict accurately, improving the accuracy and also the precision of the milling rate modeling. I hope it answers your question, Pak Janjan.
Pak Janjan, do you still with us?
Okay, thank you for the moderator. Yes, basically we have the same study basically with the, but not with the BWI in Martabe. We have the PLI, we are using PLI, and when we reconcile with the meal, basically it's okay with the meal crushing, with the meal, but not with the crusher. But so that is what's happening in Martabe. That I think in your case maybe that's good correlation for both. Yeah. Okay, I think that's all. Okay, thank you.
Okay, there's another 3 questions here. The next from Ibu Pebi. Ibu Pebi, you can directly ask the questions to the presenter.
Okay, thank you, Pak Omar. I have a question for Pak Darius. A couple questions. The first one is, how did you manage the how to get representative sample to model the ore hardness in the Batu Hijau? And then the second one is, did you compare the model of the hardness between and the actual of the after the production? Thank you.
Yep. So the representative of the samples against the population is the scope of the geologist. So in this case, I trust my geologist colleague to get the samples that represent the ore body for me. I think I hope that's answered your question. In terms of the modeling, yep, that's typical. So when we develop the empirical model, and then we need to validate the model against the actual production. And in this case, because we bring back all the empirical modeling concept in terms of the milling rate back to the textbook, which is the textbooks is pretty clear that if you want to modeling the crushing and also the submilling, you need to the well-known or the well-established standard is the AB index. And then if you want to predict the milling rate in terms of the grinding or the ball mill, then the well-known standard is for the WIBM. So yep, pretty much because we follow all the textbook and that well-established. So the modeling itself, the empirical modeling has no significant problem, and we're able to improve the accuracy and also the precision of the model.
Okay, I hope that's answering the questions. And next question is from Mbak Wulan. Mbak Wulan, are you still there?
Hello, Pak. Yes. I have a question for Pak Darius. Pak Darius, I want to ask you about what do you think about the non-destructive hardness method, test method? It will be work well like other conventional hardness tests for this for identifying the ore hardness in ore processing. Thank you.
Okay, that's an interesting question. So as a metallurgist, for me, especially metallurgist who works in the mineral processing industry, to be honest, I rarely heard about the non-destructive method in measuring the ore hardness. So the well-known standard, especially if you deal with the equipment plant design and equipment selection, still back to the very original, proven concept and well-established concept, which is in this case the destructive. Yes, it is. There are always conflict of interest between geologists and metallurgists because the test itself for measuring the ore hardness requires significant amount of the samples. So that's why this alternative methodology by using the heat tester, which is significantly reduce all the amount of samples and the complexity of the test, is somewhat promising. Yes, there is still some debate on arguments from the expert about the integrity and the consistency of the results, but considering, for me as a metallurgist, a practical metallurgist, considering all the benefits with the cons, I think the numbers generated by the heat still valid and also still make sense for me.
Okay, thank you for the answer. There is another question. It's Mbak Tami ready. But if I may, there's another questions in the chat room. It's already being answered actually, but if you can explain to the audience, it will be better. The question is, in Indonesia, red mud is considered as waste. Maybe you know how about that in another country. Thank you. That's the questions, and maybe you can answer verbally.
Of course, yes. So yes, red mud is definitely considered a waste material. It's quite problematic because of the volume, the caustic nature of it, how difficult it is to store. There's been some really horrendous accidents in Hungary and in Brazil where red mud tailings have failed, and lives have been lost, and there's been enormous damage to land and houses and infrastructure, etc. So it's been it is a problematic mining waste. It used to be, before the 70s, red mud was actually dumped in the sea, which is environmentally very damaging as well. But since the London Convention in the 70s, that mining waste now must be stored on land. I would say that for some of the newer facilities, of which there aren't very many, a lot of the facilities are quite old because we've been making aluminium for a long time. The storage of the waste has improved, where we have linings. The structural integrity of the dams is better monitored. The pH is monitored. They use water to keep the dust down and things like that. So I think that the management of the waste is better. But yes, it is most certainly still waste.
Okay, thank you for the emphasizing. The last one, Mbak Utami Sastramiharja, please, you are free to ask the questions.
Okay, thank you. So I have questions for Pak Darius. I just want to ask whether the test that you've been doing has already impact on the mill liner's efficiency, or like the liner, it prolongs, like the test could have the answers to prolong like the mill liner's lifetimes, or like have more like strategic liners replacement.
Okay, that's a difficult question. So again, I think by updating the ore hardness and then and also by using this device, you're also able to the geologists say this send samples from the blast hole drillings or the short term the material that will be sent to the mill soon, and then if we and then we can predict the milling rate, and by improving the accuracy and also the precision of the model itself, indirectly we also able to better predict the liner lifetime, or also the other detail within the SAG mill itself. I hope my generic answer will address your questions.
Yeah, thank you. I think it's just like it's really interesting if this could lead to another task works relating to the liner usage of the mill, I think, in my opinion.
Yep, for sure. Yes, for sure, Mbak Tami. But the main or the ultimate goal of this device is just to simplify all the conventional tests for defining the hardness or AD index into, yep, that's all.
Okay, thank you. Okay, actually there is one other questions, but due to time limitations, we apologize, we cannot ask these questions, and probably Aimer, you can answer directly to the chat. And finally, we come to the end of our discussion sessions. We would like to say thanks again for all the presenters for their informative and interesting talk, to all audiences, also for all active participations. And before we end these sessions, I will summarize some important notes we have learned from the discussions from the first presenters. We start with definitions, what is critical raw materials, which are those that are economic importance and at risk of supply interruption. REE are categorized as critical metal due to complex issues, supply monopoly from China, and surge of demand to a global issues policy on clean energy and as well green technology. Bauxite and red mud, which is waste product of Bayer process, are becoming interesting resources for REE. Red mud originated from karst bauxite is even better REE sources, as the conditions during formation of the bauxites allow for concentrating the metals. The second presenters emphasizing that quantifying or hardness in terms of impact resistance for crushing application and grindability for milling applications play important role in an effective mine to mill. Current standard for crushing and milling application used in mining industry are XB index and bond work index, which being applied since exploration phase as part of feasibility study and design engineering. Hardness index tester is currently being applied by Aman Mineral Nusa Tenggara as part of improvement in geometallurgy program. Together with SimSage, Aman has updated map particularly related to distributions of ore hardness at Batu Hijau mine. Ladies and gentlemen, that's very much all. Our time flies very fast. I would like to close this discussion session and return the event to MC. Thank you, Mbak Rahma.
Thank you, Bapak Omar Sharif as our moderator, Ms. Imer Didi, and Bapak Darius Varian Emil for our speakers for this session. And now it is a session of the moment of appreciation, which will be given by Professor Emi Suparka, Advisory Board of MGEI. The first memento of appreciation will be given to Ms. Imer Didi. All right, I will count from 3, 3, 2, 1. Thank you very much. Thank you very much, ladies. All right, and the next memento of appreciation will be given to Bapak Darius Varian Emil. All right, I will count 3, 2, 1. Thank you very much. And last but not least, we'll give the token of appreciation to Bapak Omar Sharif as our moderator. Okay, same again. I will count from 3, 3, 2, 1. Wonderful. Thank you very much. Thank you to Bapak Omar Sharif as our moderator, Ms. Imer Didi as our speaker, Bapak Darius Varian Emil as our speaker also, and we thank again to Professor Emi Suparka for giving the token of appreciation. Next, we would like to take a group photo with the four of you. If you could all please kindly look to the camera. I will count from 3. All right. 3, 2, 1. All right, thank you very much, everyone. Thank you very much to Bapak Omar Sharif, Ms. Imer Didi, Bapak Darius Varian Emil, and Professor Emi Suparka. Good afternoon, ladies and gentlemen. We've now entered the last session of the second day of the 13th MGEI Annual Convention. This session's topic will cover waste management and mine closures. Our speaker is Mr. Bapak Tony Gultom of Harita Nickel, who will be speaking of waste management in Harita Concession. This session's moderator is Bapak Muhammad Arif Wicaksono of PT Antam Tbk, Geomine and Technology Development Unit. But first, allow me to introduce Bapak Muhammad Arif Wicaksono's background. Bapak Muhammad Arif Wicaksono previously earned his bachelor's degree in Geophysical Engineering at the Institut Teknologi Bandung, Indonesia, class of 2009. He then earned his master's degree in the Master of Energy at the University of Auckland, New Zealand, class of 2016. His work experiences are geophysicist of an independent geophysicist from 2004 till 2018, and also an exploration geophysicist of PT Antam Tbk from 2018 until now. His professional background is Himpunan Ahli Geologi Indonesia or HAGI, and Mata Garuda Association of LPDP Scholarship Awardee and Alumni. His recent publication is Ground Penetrating Radar for Nickel Laterite Exploration, a Case Study in Pangkal Island, Indonesia. To Bapak Muhammad Arif Wicaksono, the time is yours.
Okay, thank you, MC, for the opportunity. Am I sound clear? Let me check my sound first. Okay, ladies and gentlemen, good afternoon. My name is Muhammad Arif Wicaksono, as introduced by the MC. For this session, I would like to moderate the session from Mr. Tony Gultom about the waste management in the Harita Nickel Group concessions. Maybe could we see the CV? Okay, so first of all, I would like to say hello maybe to Mr. Tony Gultom. Bapak, selamat siang. So, how are you, Mr. Tony Gultom? Okay, I haven't heard your voice, Mr. Tony, or is it my system?
Did you hear me?
Okay. Yeah, okay, I hear you. So how are you, Pak Tony?
Good, thank you.
Okay, yeah, before Pak Tony give the session about the waste management, let me show the CV, please. Okay, Pak Tony H. Gultom is from Harita Nickel Group. His educational background is from the Bachelor in Geography, Gajah Mada University in 1984. And then Mr. Tony also continues in the UGM as well in the 1987 in the graduate in Hydrology, Yogyakarta. And in 1991, he continues to the postgraduate in Hydrology Engineering in IHE Delft, the Netherlands. And then lastly, in the 2000, Mr. Tony Gultom continues his Master in Financial Management, AWU, IOEA, USA. So as you may see as well, he has a lot of work experiences. So I'm already honored with this opportunity to see Mr. Tony Gultom by myself. So since 1984, Mr. Tony has already been an assistant lecturer in the University of Gadjah Mada, and then in 1988 and 1992, he continued to the Iwako, BV, and Waseko Tirta for water supply and environment consultant. And then he continues again in 1993 until 2000 in a CNC, Lavalin International. So, it's about the water resources and environment consultant. And then from 2001 until 2013, Mr. Harita continues again to the PT Newmont Nusa Tenggara, Newmont Pacific Nusantara, BHP Billiton. And lastly, since 2013 until today, he works in Harita Group as a management and head of AHE Sustainable Ops. So a bit about his professional background. In 2021, just earlier, Mr. Tony Gultam has just done his engineering profession in the ITB Engineering Professional Program, and then he also has more than 20 years of experiences in mining. I see almost all of the commodities, yeah, Tony in here. So he has a lot of experience both in copper, gold, bauxite, nickel, and other minerals. So we will have a very good discussion today. And then lastly, he's been an international consultant in projects on due diligence, capacity building, environment, and water resources with various practical experiences in field assignments. And his recent publications back in 2020 is about the high pressure acid leaching, a newly introduced technology in Indonesia, IOP Conference Series, Earth and Environmental Science 413. Okay, Pak Tony Gultam, without further ado, if you are already ready to begin the presentations, the stage is yours. Please, Pak Tony.
Thank you, Pak Arif. I hope that my internet is stable so everybody can hear me. Is the committee can give the slide presentation? Okay. Okay, that's the topic of this afternoon discussion related to the waste, right? With focus on the nickel mine, and I'd say that this nickel mine waste management is a part of ESG commitment in Obi Island of the Halmahera Selatan district, province of North Maluku. Next slide, please. Okay, it's introduced that's Harita Nickel Group in Obi Islands in North Maluku province. The project area is a part of the National Strategic Project as per President Decree 109/2020, and that's the company or the group's vision is to optimize the value of our resources to the best of contribute to shareholders, stakeholders, and the nation. So if we contribute to sustainable metal production and reliable supply of metal for society through the strategy of the owning our own mines and smelter. As you see there on the slide, there's the 5 Harita Nickel business units in Obi Islands. There's 2 business units for mining. That's Timbaga Bangun Persada, Gane Permai Sentosa, and 2 of that's RKIF, nickel pig irons on PT Mega Surya Pertiwi and Halmahera Jaya Ferronickel. Halmahera Jaya Ferronickel is under construction, and 1 is the EXPA on the Halmahera Persada Legend. Next slide, please. So then Harita is originally focused on the mining, and we start mining in Obi Island in 2009, and then by 2015, we start the transformation of the company into the looking for the downstream. With the first groundbreaking, we started in 2015 for the high-grade nickel or saprolite, and 2016 that we have the first production with the 10 to 12% nickel. And then we continue the constructions, the ferronickel for the 4 lines in 2017, and 2019 we start constructed for the low-grade nickel ore or lamanites using the high-pressure acid leach or ITSPAL. And by 2020. Can you hear that?
Yeah, it's sounding clear. Certainly.
Okay. Yeah. Okay. By 2020, that we start constructed the 8 units RKF, and then this year in June we start produce the first production of ITSPAL. It's a mixed hydroxide precipitate. So that's the project area in OB. There is a construction, there is a mining, and there is a refinery and the smelter operation, all in the within the same area. Next slide, please. Okay. So the mining, there's a two, as I mentioned, there's 2 mining operation there. It's that feeding for the processing, either for the pyrometallurgy and hydrometallurgy, and then we did as a separation for purification, either for the RKF and the ITSPAL, and the result, the production is for the RKF is a ferronickel with 10 or 12% of nickel, and then for the ITSPAL, currently we produce mixed hydroxide precipitate, which is later on. I hope that by next year, then we will produce also the nickel sulfate and cobalt sulfate downstream of the MSP, and then go to markets and end user. I'm not talking about the output or the production of this refinery or smelter, but this session I'm talking about the waste, which is the waste of this processing, resulting huge volume of waste, or I would say it's a byproduct. Byproduct is a 93 to 98% of the ore inputs become a byproduct or waste from the processing. Next slide. Okay, this is to show it that in the nickel mines, first that we know we have to manage the mine water management. The mine water need to manage as is the liquid portion, while the OB we manage as part of the overburden. The soil is not a waste, but soil is something that we need to keep it. And in the smelter area or in the refinery, there's 2 products, byproduct. I mean, byproduct is one of it is the nickel slurry. The nickel slurry is coming from the hydrometallurgy process that's required to the treatment, right? And the treatment And from this treatment, we have the dry tail portion, and we put it as the waste to utilize into the X mine. And the water portion is the effluent to the sea. On the processing using the pyrometallurgy, the slag nickel and is a byproduct, and same time also from the power plant is fly ash and bottom ash. The slag nickel is the product from the slag nickel. Typical is like sandy, so that's we put it as backfilling to the mining as a pit area, and then from that we also utilize for other purpose. This I will show it later on, and from that slag nickel and faba, of course, that's the liquid portion that we need to manage and have the treatment before release to the environment. Next slide, please. Okay, first I like to talk on the mine waste utilization of the dry tail from the byproduct of the hydrometallurgy process. From the processing, the product is in a slurry form. The slurry form with the solid portion is about 9 to 12%, and the rest is water. And that slurry portion that we send it to the filtration plant is to filter and then change into the solid portion, and we put the solid portion into that X mine, right? And we manage that as we call it as a dry tails X mines area. The process is it's a simple actually, but what's important too is that the liquid portion, we bring it back to the process, and then we processing. Sorry, before we can release to the environment. For this, because of the dry tail is under the Indonesian government regulation is is classified as hazardous waste, then we have to get a permit first before we can operate. Next slide. Okay, on the slag nickel, the slag nickel is it previously is a hazardous waste, same as a fly ash and bottom ash, but then government changed in the regulation this year, and that's become the slag as the non-hazardous waste. But the management of this waste have to be still remain same. Why? Because the volume is a huge volume that we have to manage. So basically the slag nickel, we have the permits since 2017, and then we place it into the X mine, right? And then we have also permits for utilize. That's we define into that two type is the aggregate, the granulate from the slag nickel, and it's a ground granulated electric furnace slag nickel. So that the two type, why we put it the two type, because of that for the ground granulates, right? We need to have more treatment to make it more specific, the same size of the material, and that can be used as the mortar or cement slag, and that can be used as for the construction. While the aggregate granulated, which is currently we already implement, is for the paving block or concrete bricks, and also for the road base, and also for the as part of the concrete for the construction. So we use basically almost 100% of the material from the slag nickel, replacing the sand, so that we have less bring it sand from other islands to OB. So we use these resources. And the next slide. Because that's the volume, like I said before, the volume of the waste is huge, very huge. Then the speed of to utilize for others, it will take time. Therefore, we utilize the slag nickel as part of backfilling to the X mine, right? That so as you see that's on this slide, that is a slag nickel, and for the stabilizations, I use fly ash to make the slope more stable. Okay, the next. So that's the location. On the top, you see that is the location of the slag nickel that I explained. And then it's not far from there, there's a waste utilization that's the slag nickel that we utilize for the concrete brick and others purpose. And also the dry tail utilization on the blue portion, we put it there at the X pit. So on the left slides, that you see that the number of the volume of the slag. When we complete all the RKEF completed, then byproduct of this RKEF, there'll be 6.7 million ton of slag per year, and the dry tail is like 8.6 million, and a small portion of the fly ash and bottom ash. So so that we have to manage this 5.6 million ton, and that's need place, need a time, and then need also where is the user, while that we located in the island. So that's become the portion need to calculate is also is it if it the economics and then the transport also economic, then sending outside, it will be the best way to reduce the volume of this waste. And then the next slide, when this portion of the managing the waste is a part of the ESG. ESG is an environmental, social, and governance that is a company responsible. Which we have three major portions in the Haritani nickel. One of it is that how we manage the waste. It is a part of the environmental and good governance. And we also follow and then looking that on the climate change, where that's now is a very, very part of the responsibility on the related to the land management and the air, ensure that the emissions are less, and also the marine, because because of the marine is the project is close to the marine empowerment, and human rights. The human rights is important, that especially with the local community and how we help and support the community and empowerment of the people, the local people have the opportunity to work, and also that we at the same time fighting the poverty and it creates the social justice. And on the good governance, that the good operational excellence that will be improved in the Harita business, and as well as to the empowerment, and that for the most mining that we believe that occupational health and safety is offering the safe workplace and safe culture. And last but not least is that it's a good corporate governance that ensuring the integrity and ethical behavior as the culture of the company. On the there's at the bottom and on the right side, you see there's a number that is related to the SDGs, because that we are in the mining also need to support the SDGs goals, the Sustainable Development Goals. So which portion? There's a lot of portion under the 17 SDGs that we could apply under the mining operation. I think that is what I can give the presentation for this afternoon. Thank you for the listening.
Okay, thank you very much for your presentation, Pak Tony. It was a really insightful discussion and sharing from you, especially about the slag nickel and the dry tails. So, ladies and gentlemen, we have arrived at the discussion session. So, for those of you who would like to ask for several questions, you may raise your hand virtually and or just directly chat your question in the chat box. Okay, so while waiting for the questions, let me ask you first. This is my privilege as the moderator. Eh? So, Pak Tony, I checked about the sustainability framework. Yeah, this might haven't been shared from you, but this is quite interesting for me about the waste management pillar and initiative. So about the climate change, like increasing carbon storage by doing diverse rehabilitations continuously. So what are the things that have been done by Harita to tackle the carbon offset? So it is quite related to what Pak Luhut discussed before about the carbon offsetting as well. So, and you discussed it as well in the climate change. So I would like to ask that first about the several things or programs maybe that have been done by Harita. Maybe it is related to the slag nickel or related to the HPL that is quite tackling the carbon offset in the Harita itself or even in Indonesia. Please, Pak Tony.
Thank you, Pak Arif. Yes, it's an interesting question, and here also that what Luhut mentioned on that what we have to do it and then don't forget with also with the climate change, and that is actually we are in the mining business. We already do that on the supporting climate change. One of it is the reclamation. So the reclamation is the rehabilitation is a part of mining responsible to support in the carbon emission reduction, right? And it's a simple, but that's we already doing it, right? But we have to also consider that in Indonesia is a time of or that's an opportunity that's downstream of the mining. While before or I would say the 5 years ago that we only more produce on the ore
Yes.
Production and then export ore.
I can still hear you,
Okay.
but your picture is quite freezing, I think. But it's okay.
Yeah,
Yeah.
the freezing is not a good face.
Yeah. It's okay. It's all
All
right,
right.
Tony.
Yeah.
You may continue.
Okay. So when we start doing the downstream of this mining, then we have to see that there's an impact, right? Like for instance, like in the nickel downstreams, mostly it's the RKF, the pyrometallurgy required a big power energy, right? So this big energy that's release the emission too, right? So so we will continue with that, right? And I believe that there will be continuous of the developing the power plant to support the industry, but then we need to see other energy, right? The renewable energy, or we support other activities, like we consider reclamation is also part of the responsibility. It's under regulation, but also under responsibility for us to support on the climate change. But also others managing, like waste management is a part also for emission reduction. And the company do continue to do that, right?
Yes.
And that's it's a part of that what we are doing on the climate change, supporting also on the protecting and mitigation of the impact in the marine environment. Also, it's support this climate change. So I hope to answer your question, Pak
Yeah.
Harith.
Okay, it's really answering my questions, Pak Tony. It's really great, even for myself to hear that. Yeah, now mining company has already considering for doing carbon offsetting or getting more serious in the environment, because yeah, maybe you know as well that several years ago, mining company mainly only focusing on the ore target or only profit. But now, as the ministry as well has already considering about the SDGs, the carbon offsetting, even in the we already agree with the Paris Agreement. So I think it's a good start, I think, for us. Okay, we may continue to the other question, Pak Tony. Yeah, it's from Mr. Dennis Henry. Maybe you can see as well in the chat box, Pak Tony. So, how long to get a permit from KLHK to allow company to utilize X-pit area for B3 permanent storage? Thank you, Pak Tony.
Yeah, when we talk about the B3, the hazardous waste means that related to the tailings, right? If it's the slag nickel, it's not longer is not longer a hazardous waste. So for slag nickel, you don't need a permit, but just put it in the AMDAL and how you manage it. While if it's a tailings or slurry to expand, is the time if you look from the regulation is not long. It's a very now in the regulation there's the number of days. You just follow that one. The time make it longer if we don't have enough information to submit, right? My experience with the permit what I have before is about six to 8 months to get a permit, but mostly that because of the data requirement that need to be completed. So I hope that's answered that question. I think that's the best answer actually for the next presentation, which was planned from KLH, right? Arif?
Yeah, but unfortunately, I think Mr. Sigit couldn't attend this event due to
Mr.
the
Sigit is promoting as a new Director General in the KLH.
Yeah.
So yesterday, so that's why he maybe regret to come to attend.
Yeah. Okay, Pak Tony. Maybe Pak Dennis, maybe you can do you still have any response or other questions for Pak Tony? Maybe you can open mic and cam. Pak Dennis.
No, thank you. I think Pak Tony already explained well for us, and it's good to know for me also the slag is not part of the B3 anymore. Thank you.
Okay, Pak Dennis, do you still have any questions, Pak Dennis?
No, thank you.
Okay, thank you, Pak Dennis, for the questions. And next questions will be from Dr. Andi Yahya. So maybe Pak Andi Yahya could directly ask the question. Can you please open mic and cam?
Thank you. Pak Tony, what is the average moisture content for the filtered tailings?
It's about 32 to 35%. So that's from the filter press. That's what your question, right?
Yes.
So that's and then go to the X mine.
And what happened with the slurry?
So yeah, so the process after the filter press, the cake portion is go to an X mine. Okay, so the water from the filter press back to the process, right? And then we put it into the tanks, mixing tank, and we treat it, and before we release it.
Okay, thank you, Pak.
Okay, thank you, Pak Andi Yahya for the question and Pak Tony for the answers. So this will be the last question from Pak Adi Mariano, who has opened the cam and mic. So please, Pak Adi, you can deliver the question.
Pak Tony, thank you for the good presentation today. And I would like further to take on the HPAL plant, Pak. And I believe this is the first HPAL plant, and has been, what I heard has been going okay. So my question would be, when it's going okay, how much actually meeting the targets, and what are or is the challenge so far that faced during the commissioning and early start of the HPAL? Thank you.
Thank you, Pak Adi. Yes, we start commissioning and production in June this year, right? And we start with the first autoclave, and now we starting operating the 2 autoclaves. So far is the process, the product is as expected, right? But it's come to your questions. We expect sooner, right? We expect sooner, but you see that in EXPAL all over the world, that's is an up and down and takes so long to get to reach the capacity, right? With the full capacity. So there's some experience. It's a good lesson learned from other EXPAL, and that's that we adopted, and then we hope the process can be reached sooner than the others. That's that, and I need support from all of you, including you, Pak Adi, to get a success better than the others. Thank you.
Thank you, Pak Tony. It's congratulations, and we would like we wish that will be very successful, and we would like we are happy to hear that. Thank you.
Thank you, Pak.
Okay, thank you for the answer, Pak Tony. Pak Adi, do you still have any question?
Nggak ada, Mas. Makasih ya.
Okay, thank you for delivering the question as well, Pak Adi. Okay, Alhamdulillah, we have reached the end of this discussion session as well as the session about the waste management in Harita Nickel Group concession from Pak Tony. Pak Tony, I would like to show a big thanks to you because you give us a lot of insightful session and knowledge, because what you have shared today about the waste management. But because of the time limit, I'm really sorry to say that this is the end of our sessions. But before we close the session, maybe can we hear a bit of closing statement for you, maybe Pak Tony, about the waste management practice? Maybe something that you can share as a closing statement for the ladies and gentlemen here. Okay.
Yeah, thank you. This is something about the waste that we need to all together to consider, right? Because like I said, that the waste from the refinery or the processing is a very huge volume. It needs to manage. Is a government decision with the new regulation to put slag nickel, fly ash, bottom ash, and not longer the hazardous waste. It really helped us to manage better and to utilize better. And we I hope that others waste too, like the tailing, can be considered, because that needs to be utilized properly and managing better than we if it's still in the categorized as the hazardous waste. That is my my closing remarks, and then hope that in the next coming years that we get better in the managing the waste.
Okay, inshallah. Thank you, Pak Tony, for the closing statement. And as moderator myself, I would like to thank MGEI for the opportunity to give me opportunity as a moderator, especially Mr. Budi Santoso. So thank you, ladies and gentlemen, for your time in listening this session. I would like to give the session back to the MC.
Thank you very much, Bapak Muhammad Arif Wijaksono as our moderator, and also Bapak Tony Gultom as our speaker for your presentation. And now we would like to invite Bapak Hashari Kamarudin, Staff Khusus PPMGEI from 2018 to 2021, to give the token of appreciation first to Bapak Tony Gultom as our speaker. If the operator could please display Bapak Tony Gultom and also Bapak Hashari Kamarudin. All right, gentlemen, I will count from 3. 3, 2, 1. All right, thank you very much. Our next token of appreciation is to Bapak Muhammad Arif Wicaksono as our moderator. Okay, can the both gentlemen please look at the camera? Could the operator please display the 2 monitors of our speaker? Okay, gentlemen, I will count from 3, 3, 2, 1. All right, thank you very much. Thank you, Bapak Muhammad Arif Wicaksono as our moderator, Bapak Tony Gultom as our speaker, and also to Bapak Hashari Kamarudin. Baik Bapak dan Ibu yang saya hormati, selanjutnya kami akan memasuki sesi Proposing Work Program of MGEI Chairman Candidate, di mana sesi ini kami akan mengundang Bapak Hashari Kamarudin, Ketua KPU MGEI tahun 2021. Before we start this session, we first would like to apologize and we would like to take the photo of the 3 gentlemen, to Bapak Hashari Kamarudin, Bapak Tony Gultom, and also Bapak Muhammad Arif Wicaksono. Okay, gentlemen, I will count from 3, 3, 2, 1. Thank you very much, Bapak Hashari Kamarudin, Bapak Muhammad Arif Wicaksono, and also Bapak Tony Gultom.
You are welcome. My pleasure.
Selanjutnya, kita akan memasuki sesi Proposing Work Program of MGEI Chairman Candidate, di mana pada sesi ini kami akan mengundang Bapak Hashari Kamarudin selaku Ketua KPU MGEI tahun 2021. Kepada Bapak Hashari Kamarudin, dipersilahkan. Selamat sore, Bapak.
Okay, terima kasih panitia. Thank you for the organizing committee that support and facilitate the KPU to conduct this today event for our stages in the for the chairman of MGEI election 2021-2024. Since today we will conducting the report of the previous proses kepengurusan DPP MGEI 2018-2021, I think it will be better to conducting the event in bahasa. Mungkin Pak Ketua MGEI bisa juga ikut bersama kami pada kesempatan ini. Selamat sore Pak STJ. Mungkin belum bisa aktif mikrofonnya.
Ya, selamat sore Mas Has. Assalamualaikum warahmatullahi wabarakatuh. Selamat sore untuk semua.
Waalaikumsalam warahmatullahi wabarakatuh.
Baik, sebelum kita melanjutkan ke pemaparan dari pengurus. Jadi pada saat ini Pak Budi Santoso, Pak STJ Budi Santoso, hadir sebagai Ketua MGEI periode 2018-2021. Pada kesempatan ini kita akan mendengarkan pemaparan dari Pak Budi STJ terkait laporan, dan juga nanti karena sesuai dengan tahapan yang sudah dilakukan oleh KPU, dari tahapan yang kita lakukan, dari 14 bakal calon ketua yang telah diverifikasi pada bulan November 2021, ternyata dari hasil konfirmasi dan verifikasi yang dilakukan, kita mendapatkan 1 bakal calon. setelah kegiatan ini nanti beliau sebagai bakal calon ketua atau kandidat ketua MGEI 2021-2024 juga akan memberikan gambaran tentang rencana kerja 2021-2024 yang dipropos atau akan disampaikan oleh calon ketua MGEI. Waktu dan tempat saya persilakan kepada Pak STJ Budi Santoso.
Baik, terima kasih Pak Hasari. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk rekan-rekan, Bapak Ibu semua yang hadir di event sore ini. Ada masih 147 yang bertahan begitu ya, meskipun sesi ini bukan sesi technical annual convention MGEI, tetapi mohon izin diperkenankan untuk saya, seperti tadi disampaikan oleh Pak Hasari, menyampaikan usulan program dalam posisi saya sebagai calon ketua MGEI untuk periode berikutnya. Untuk mempersingkat waktu, saya mohon izin untuk bisa share screen. Apakah sudah bisa dilihat dengan jelas?
Clear.
Ya, clear. Baik. Pertama, saya ucapkan terima kasih untuk KPU pemilihan Ketua Umum MGEI untuk periode 2021-2024. Kemudian rekan-rekan semua yang sudah mendukung dan menguatkan untuk, atau bagi saya secara pribadi sebenarnya juga kerja kelompok untuk maju lagi begitu ya. Ada semacam tanggung jawab dan beberapa hal yang ingin kami lakukan di kepengurusan yang berikutnya. Jika dalam mekanismenya nanti usulan program kerja tersebut dapat dimaterialisasi sebagai program kepengurusan untuk MGEI 2021-2024. Saya menyampaikan ini pertama-tama mengucapkan terima kasih kepada seluruh personel gitu ya di MGEI khususnya yang telah menginspirasi saya, menginspirasi kami, dan untuk semua rekan-rekan yang telah membuat sebagian besar dari program sebelumnya itu menjadi nyata, bahkan lebih dari yang kita harapkan, atau bahasa kerennya itu beyond our own expectation. Ini karena kerja luar biasa dari rekan-rekan semua. Selain kepada rekan-rekan, tentu juga kepada keluarga, pada pasangan begitu, karena bekerja melakukan tugas aktif di organisasi profesi seperti MGEI perlu support yang luar biasa dari orang-orang tercinta di sekitar kita. Baik, karena pada dasarnya kepengurusan yang kami usulkan dengan programnya adalah lanjutan dari yang sudah ada, maka kalau bisa dikatakan atau boleh disampaikan ada sebuah visi, kami ingin dan selalu berusaha sekuat tenaga bahwa MGEI haruslah menjadi sebuah organisasi yang makin kuat. Alhamdulillah sejauh ini kita sudah sangat kuat begitu, sangat percaya diri, mandiri juga dalam beberapa hal atau banyak hal, dan tentu saja tagline yang luar biasa menginspirasi, satu kata yang itu bisa mencakup banyak hal hingga perjalanan kita sampai sudah sejauh ini dan akan lebih jauh lagi. Kemudian misinya adalah menguatkan dan memajukan. Ini kita mencoba untuk mengembalikan sedikit kita ke kitohnya, bahwa basic background kita adalah geoscientist yang tujuan paling dekatnya bagaimana mengimplementasikan itu adalah membuat atau mendapatkan discovery. Kemudian juga tentu banyak hal aplikasi dari geoscience itu dalam dunia pertambangan yang ada di negeri ini. Kita ingin lebih memainkan peran untuk lebih aktif dan penting, begitu ya. Aktif dan penting, saya pikir itu sudah dua kata yang sangat harus ada dalam industri pertambangan. Dan kunci kata berikutnya adalah yang lebih baik, karena kita ingin berevolusi, ada perbaikan-perbaikan pada setiap waktu yang kita jalani ke depannya. Tagline kita tetap Inspiring MGEI adalah sebuah tagline yang saya pikir bisa dipakai, diadopsi, dan diterima oleh banyak pihak tanpa ada pretensi bahwa kita lebih dari yang lain, karena kita selalu sampaikan masing-masing dari kita menginspirasi satu dengan yang lainnya. Jadi kita ingin keyakinan diri bahwa secara mendalam atau di dalam kita kuat dalam dari masing-masing personal di MGEI, organisasi di MGEI sudah sangat kuat, dan kita ingin terhormat di luar. Di luar tidak hanya di luar MGEI dalam kancah Indonesia atau nasional, yang alhamdulillah sudah pada posisi atau tempat yang kita inginkan, namun tentu di dunia atau kancah yang lebih luas, di dunia internasional. Jargonnya tetap, karena ini adalah urusan pekerjaan, ini adalah urusan komitmen, urusan dedikasi, start dengan komitmen, melakukannya secara konsisten dan mendedikasikan waktu, tenaga, dan usaha yang cukup, tapi bungkusnya adalah dengan integritas. Saya pikir itu akan menjadi koridor dan value yang akan mengikat kita semua untuk mencapai target kita ke depan secara bersama-sama. Ini adalah program usulan kita. Yang pertama, penguatan kelembagaan MGEI ini berkaitan dengan identitas, pemberdayaan anggota dan organisasi di bawah MGEI ini dalam SC, MGEI, dan juga yang lain, karena ingin ada pelembagaan beberapa program kita yang harapannya dengan pelembagaan program-program tersebut kita sudah mempunyai bentuk dan standar operasional yang lebih tertata. Jadi setiap program, setiap acara kita sudah memiliki bagaimana itu harus dilakukan. Tentu saja pemberdayaan anggota, nanti kita akan lihat adakah program-program baru yang kita bisa masukkan dalam kategori pemberdayaan anggota MGEI. Kemudian yang kedua, penguatan hubungan dan komunikasi eksternal. Kalau kita boleh sampaikan eksternal dalam hal ini, untuk kepengurusan berikutnya, mungkin kita harus sudah lebih berkibar di luar secara dunia internasional. Kita punya banyak sekali rekan-rekan yang pada saat ini sangat aktif di organisasi profesi jenis di luar. Demikian juga saya, karena anggota AUSIM di SIG juga beberapa waktu saat ini duduk juga di komite Lindgren Award, sebuah award yang sangat prestisius untuk para researchers atau geoscientist dengan riset-risetnya di bawah umur 35 tahun di bawah SIG. Itu luar biasa. Saya pikir hal yang kita bisa masukkan sebagai salah satu program yang kita bisa adopsi di MGEI. Kemudian penguatan penggalangan sumber dana alternatif dan sustainable. Ini sesuatu yang kita tahu betul, organisasi dimanapun, apalagi ini organisasi sosial, organisasi profesi, support ke dana untuk operasional khususnya, untuk melakukan kegiatan-kegiatan atau mengimplementasikan dan merealisasikan program-programnya akan butuh itu. Alhamdulillah dengan kerja keras rekan-rekan di setiap kepanitiaan acara, itu kita bisa mendapatkan support yang sangat luar biasa dari industri. Terima kasih sekali lagi dalam hal ini kepada para rekan-rekan yang saat ini sedang bergabung di setiap organisasi atau instansi atau perusahaan yang selalu mendukung dengan luar biasa kepada MGEI. Kita juga tidak hanya melakukan atau mengedarkan proposal, itu tidak sama sekali. Banyak program kita yang kita integrasikan dengan kebutuhan industri. Ada kegiatan-kegiatan nanti kita lihat setelahnya apa saja yang kita gunakan dalam bungkus mutual simbiosis mutualisme antara industri perusahaan-perusahaan tersebut dengan rekan-rekan profesional kita dan kelembagaan MGEI. Kemudian yang keempat, melanjutkan dan memperkuat reputasi program andalan rutin MGEI. Ini tentu saja dari sejak awal didirikan, apalagi 3 tahun terakhir banyak sekali program-program andalan baru yang kita masih ingin, kita perlu memperkuat itu dan membangun atau menyusun reputasinya. Dan itu hanya bisa dilakukan jika kita menempatkan ini sebagai salah satu dari sekian seri 5 program unggulan. Kemudian sinkronisasi program-program MGEI dengan IAGI. Tentu saja kita tahu betul MGEI posisinya di mana sebagai anak organisasi IAGI. Kita sudah mulai menginisiasi kegiatan-kegiatan MGEI yang tadinya kita bisa lakukan itu dengan bendera MGEI, tapi perlu kita ingat setiap kita melakukannya MGEI adalah selalu kita juga menggunakan logo IAGI di sana sebagai anak organisasi. Namun beberapa program kita sudah membaginya secara lebih terbuka, secara proporsinya secara lebih besar menjadi bagian dari program-program induk organisasi kita IAGI, karena bagaimanapun kita adalah anggota dan kader IAGI, bisa dikatakan seperti itu. Demikian juga dalam waktu-waktu yang akan datang ada dua program yang kita sudah arahkan ke sana, beberapa komitmen, apakah itu tentang vaksinasi program vaksinasi COVID-19, kemudian juga penggalangan dana dan lain-lain. Kita tidak menginisiasi sendiri, tapi kita sudah menyalurkan menggunakan baju induk organisasi kita. Untuk banyak hal yang lain tentang CPI, sertifikasi dan lain-lain itu hal yang sama. Ke depan insya Allah akan banyak hal lagi yang kita bisa lakukan seperti itu. Kemudian ini beberapa highlight saja untuk mengcover beberapa hal penting yang menurut kita akan perlu usaha yang sangat keras, bahkan lebih keras dari sebelumnya. Namun kita berusaha lebih sedikit effort apakah itu waktu, apakah itu energinya. Kita mencoba untuk melembagakan apa-apa yang akan kita buat ke depannya. Bukan hal yang mudah di awal, tapi pada saatnya dalam waktu 3 tahun ke depan, insya Allah menggunakan analog, menggunakan referensi yang kita sudah lakukan selama 3 tahun terakhir ini, insya Allah bisa. Yang pertama adalah kita sudah punya 2 flagship program. Kalau kita perhatikan ada beberapa pergeseran begitu ya, hal-hal non teknis strategis yang berkaitan dengan dunia industri sedikit mixed up dengan acara annual convention. Nah, kita mencoba untuk membaginya, meskipun mungkin garisnya tidak akan hitam putih, tapi yang jelas kita ingin annual convention mengcover, menggali, menemukan banyak hal-hal baru, breakthrough, sharing knowledge, kemudian juga lesson learned, beberapa lessons to be learned gitu ya, untuk kita dari best good practices dari perusahaan-perusahaan atau rekan-rekan yang lain secara teknis itu di annual convention. Sementara yang berkaitan dengan kontribusi kita untuk industri pertambangan yang jauh lebih strategis itu kita lakukan di CEO Forum dan IEDC. Jadi ada forum yang kita ingin kumpulkan hal yang berkaitan dengan itu di sesi yang lain dalam 1 tahun. Jadi akan ada 2 flagship program untuk kebutuhan yang sedikit berbeda, namun tetap saja masih sangat tebal benang merahnya. Kemudian berikutnya adalah membentuk MGEI Exploration Center of Excellence, itu MECE. Ini sesuatu yang saya pikir sudah saatnya. Kita punya banyak sekali talents atau pool of talents dari orang-orang di Indonesia, national experts. Kita juga punya anggota-anggota yang multinational expert juga, foreigners, yang saya pikir bisa kita himpun, kita lembagakan di mana mereka rekan-rekan tersebut ada satu wadah untuk mengeksplor segala sesuatunya yang berkaitan dengan eksplorasi. Apakah itu nanti berupa workshop yang selama ini masih tematik karena memang kita masih lakukan itu secara katakan sporadik begitu, meskipun sudah ada program-program pre-convention, post-convention dan lain-lain, tapi kita bisa lembagakan itu dengan acuan seperti kita lakukan fresh graduate mentoring program sebelumnya. Hal-hal yang kita bisa lakukan di sini berkoordinasi atau berkolaborasi dengan misalnya BRIN yang sudah ada sekarang, misalnya Amira yang ada di Australia, atau mungkin Coach yang ada di Tasmania, Australia juga. Hal-hal seperti itu yang dalam pemikiran kami kita bisa lakukan di MGEI ini. Dan impact-nya akan sangat luar biasa. Apakah untuk industri, bagaimanapun pada saatnya industri akan lebih maju, jika industri maju, bisnis berjalan, impact-nya juga akan langsung kepada anggota-anggota kita atau masyarakat ekonomi geologi di Indonesia secara umum. Kemudian internship program, ini banyak hal yang kita dapatkan dari rekan-rekan di universitas. Banyak sekali mahasiswa yang masih kesulitan mencari tempat untuk menjadi atau melakukan tugas akhir. Nah, kita ingin lewat MGEI, apakah itu nanti MOU dengan universitas atau seperti apa, kita menjembataninya dengan industri, terus kemudian kita pool diri kita, terus kemudian kita coba menjadi bridge atau jembatan. Rekan-rekan khususnya dari SCMGI misalnya, ada berapa banyak interest-nya apa, dan perusahaan-perusahaan mana saja yang pada saat itu membutuhkan. Karena kita juga punya FGM, kita juga bisa lakukan itu lebih awal pembinaannya, which is sudah dilakukan di SCMGI. Jadi ada semacam kemenerusan. Teman-teman di SCMGI mendapatkan banyak pengetahuan, skill. Mereka juga bisa lakukan internship dengan bridging oleh kita, kemudian bisa menjadi atau masuk dalam program fresh graduate atau early career program, mentoring program, dan seterusnya. Saya pikir itu sesuatu yang sangat layak untuk diperjuangkan. Kemudian pelembagaan sistem orientasi pada service, dalam tanda kutip ya, kita orientasinya bukan semata-mata untuk bisnis, tetapi ini adalah bentuk kontribusi kita kepada perusahaan. Jadi perusahaan mendapatkan benefit dari keberadaan para expert di MGEI. MGEI mendapatkan benefit dari komitmen perusahaan tersebut menjadi long term sponsors misalnya untuk kegiatan-kegiatan event-event dalam 1 tahun, atau bisa dipilih event apapun yang menurut mereka lebih kontekstual dengan keberadaan atau visi misi dari perusahaan tersebut. Penguatan posisi ke CPE dan kode KCMI saya pikir ini bagian dari tugas penting dari IAGI dan juga dari Kombers KCMI, IAGI dan Perhapi. Saya pikir ini sesuatu yang mau tidak mau akan menjadi sebuah program mulia, namun bukan tidak mudah, karena isinya adalah orang-orang yang sangat berkompeten, orang-orang yang membutuhkan industri, bahkan oleh pemerintah untuk itu. Kemudian pembentukan bidang eksekutif harian MGEI, kita sadar betul makin ke sini makin banyak yang harus dilakukan, mengandalkan kegiatan-kegiatan, semua kegiatan itu di-tackle oleh rekan-rekan kita yang pada saat ini sedang melakukan kerja profesionalnya dengan perusahaan, tentu ada challenge tersendiri. Jadi kita ingin bidang eksekutif harian MGEI ini nanti mengurusi semua hal yang berkaitan dengan administrasi, termasuk juga hal yang berkaitan dengan pengaturan event dan lain-lain. Kesekretariatan bisa dikatakan seperti itu, tapi kita akan bentuk lebih punya level dan image yang berbeda. Seperti kalau kita lihat bagaimana di SIG, bagaimana di AUSIM, itu sangat-sangat profesional dan sangat-sangat membantu untuk urusan day-to-day operasional organisasi. Kemudian internalisasi cookbook MGEI. Ini bukan ADART karena kita tidak punya dalam posisi tidak diperbolehkan gitu ya untuk memiliki itu, karena memang ADART yang kita acu adalah punya IAGI. Namun kita punya pedoman bagaimana organisasi ini dijalankan. Ini kita perlu internalisasi nanti pada saat cookbook tersebut sudah mendapatkan approval atau kesepakatan dari apakah umumnya adalah board atau advisory board dari MGEI dan tentu saja dari IAGI, karena kita harus mensinkronkan antara cookbook MGEI dengan AD/ARD yang ada di induk organisasi. Kemudian FGMP program ini program sangat luar biasa, di mana kita mencoba memberikan bekal yang cukup begitu bagi rekan-rekan yang baru, fresh graduate, early career, yang dimentori secara sukarela oleh rekan-rekan kita senior-senior yang sudah malang melintang di dunia industri. Kita set kriteria siapa yang boleh menjadi mentees dan siapa yang kita inginkan berkenan menjadi mentor. Dan itu luar biasa. Sedang terjadi batch pertama selama 8 bulan, kita akan tutup atau wisuda begitu ya untuk batch 1, batch 2, batch 1 di pertengahan Januari. Ini satu program yang kita bisa lakukan secara mandiri atau pada suatu saat jika program itu dikhususkan untuk apakah itu industri atau kelompok industri, kelompok apapun sejauh kedudukannya adalah egaliter, kedudukannya kesepakatannya adalah dasarnya keterbukaan untuk perbaikan-perbaikan profesional yang kita perlukan. Kemudian MGEI Award ini penting, kita tidak berbicara tentang industrinya, perusahaannya, tetapi pada performance atau achievement pribadi-pribadinya. Ini sesuatu yang kita harapkan segera bisa terjadi, paling tidak di 2022 sudah ada award itu. Apakah semua yang berkaitan dengan geoscience di Indonesia. Kemudian pendirian kampus Economic Geology Training Ground MGEI. Karena begini, kita mempunyai program yang kita sebut bootcamp. Isinya adalah rekan-rekan mahasiswa SCMGI yang kita kumpulkan dari seluruh Indonesia. Kita fasilitasi untuk datang ke satu tempat. Kita sediakan mentor-mentor yang bagus, instruktur-instruktur yang luar biasa itu ke lapangan. Melakukan mapping, melakukan interpretasi, melakukan diskusi, presentasi, sampai mendelineasi target-target pemboran as if atau seolah-olah jika mereka melakukan kegiatan yang real pada saat mereka menjadi profesional atau bekerja segera setelah mereka lulus. Dan itu dalam pemikiran kita bisa lembagakan itu, kita pilih satu tempat yang memiliki kompleksitas deposit yang cukup, representasi dari jenis deposit yang ada dan itu cukup, dan kita set di situ dengan segala fasilitasnya, fasilitas simple facility, tetapi itu bisa menjadi flagship pencapaian kita. Kenapa ini saya sampaikan seperti ini berlebihan dan lain, saya pikir sama sekali tidak. Kita punya resource yang cukup, bahkan satu untuk memiliki sekretariat sendiri. Kalau sekretariat sendiri yang di Jakarta di tempat yang cukup bagus dengan fasilitas yang memadai kita bisa. Kalau untuk yang seperti ini insya Allah lebih dari bisa. Saya pikir ini waktunya cukup singkat ya. Ini program andalan rutin hanya menyampaikan, merefresh saja untuk rekan-rekan yang mungkin hanya mendengar setengah, sebagian atau bahkan belum mendengar. Untuk annual kita punya MGEI Annual CEO Forum. Kita juga punya Indonesia Explorers and Developers Collegium IEDC. Ini tempat berkumpulnya para investor, berkumpulnya para pemilik tambang, brokers, consultants, bankers, lenders, dan lain-lain untuk berkumpul di situ. Ini kita inisiasi mulai dari tahun lalu dan alhamdulillah luar biasa hasilnya dan sangat representatif untuk dijadikan sebagai basis pengembangan setelahnya. Kemudian tentu saja MGEI Annual Convention. Kemudian yang untuk profesional ini hal berkaitan dengan pengembangan keprofesian dari rekan-rekan kita yang sudah bekerja. CPI dan verifikasi CPI tentu saja ada CPI Development Program, itu bagian yang sudah selama berjalan. Fresh Graduate Mentoring Program, ini tadi saya sebut MGMP, termasuk early career ya. Sebelum 2 tahun, yang punya pengalaman maksimum 2 tahun saat ini. Kita sedang review akankah kita expand atau akan kita lebih kecilkan dulu untuk lebih intens dan lain-lain, itu akan ada pelaporannya nanti. Kemudian ada Indonesian Journal of Economic Geologists, ini yang terakhir, yang pertama sudah selesai. Kita akan launch dalam waktu dekat, mestinya kita sudah bisa launch dalam tahun ini, bulan ini, karena ini sudah siap. Ini seperti SEG bulletins minimal yang kita biasanya lihat dari Society of Economic Geologists. Kemudian ada Discoverman, ini podcast seperti radio begitu, ini luar biasa. Kita bisa mengengage banyak sekali orang-orang top di dunianya dan dilakukan secara online. Kemudian MGEI Webinar Series, ini kita sudah bisa melihat dari tahun 2019 sampai 2021. Saya pikir dengan jari tangan dan kaki yang ada lebih dari itu jumlahnya. Kemudian dari untuk industri dan government banyak sekali ini MGEI Ghost Industry yang tadi saya sebutkan, workshop MGEI sudah luar biasa, sangat terkenal itu, selalu sold out dalam waktu yang sangat singkat. Kemudian juga partner diskusi dan narasumber untuk perumusan kebijakan. Ini terima kasih banyak untuk para senior yang selalu berkomitmen dan selalu siap kita minta untuk mewakili, merepresentasikan MGI untuk tampil. Kita juga sudah mulai mengencourage rekan-rekan generasi berikutnya untuk juga terlibat untuk hal yang strategis seperti ini. Ini yang tadi saya sebutkan, untuk students, ada training bootcamp, ada software comprehensive training dan competition. Ini kita engagement kita dengan industri, ada SCMGI dan SEG, kita juga masukkan di dalam area of development bagi kita, karena saya pikir punya background yang mirip, economic geologist. MGEI Ghost Campus, suatu yang sangat ditunggu rekan-rekan di kampus, dan juga hibah dari industri untuk universitas khususnya yang ada SCMGI. Ini salah satu contoh yang terakhir adalah ada satu perusahaan yang menghibahkan sets of skeleton cores yang itu merepresentasikan tipe deposit dan model geologi atau model ore deposit di deposit tersebut. Jadi ada poster dengan letak atau posisi di mana batuan tersebut berada. Jadi kita bagikan itu kepada universitas-universitas, mohon maaf sekarang masih yang ada SCMGI-nya, meskipun itu belum semua, sehingga mereka bisa melihat tipe deposit tertentu, ini hasil validation, tipe deposit validation pada level ini dalam sistem itu bagaimana kenampakannya, pada level yang lebih dalam, lebih distal, lebih proksimal, seperti apa penampakannya. Jadi teman-teman di kampus, Bapak, Ibu dosen juga, bisa belajar secara langsung, ini drill course, tidak surface grab rocks atau rock chips. Ini adalah drill course yang diset sedemikian rupa untuk belajar secara langsung material-material peraga yang memang itu merepresentasikan deposit-deposit yang saat ini sedang dikerjakan atau sudah terbukti keberadaannya dan ditambang oleh perusahaan tersebut. Saya pikir itu saja, mohon maaf jika terlalu panjang untuk menyampaikan, karena memang banyak hal yang ingin kami sampaikan. Yang jelas kita ingin dan still ada keringat begitu ya, kita bekerja keras, ada waktu, ada dedikasi, tentu saja pertama itu dari komitmen ya, kemudian konsistensi mendedikasikannya dan konsistensi melakukannya, dan bungkusnya kita selalu dengan integriti. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh. Salam, selamat sore.
Waalaikumsalam warahmatullahi wabarakatuh. Selamat sore. Ya, terima kasih paparannya Pak Budi STJ Budi Santoso yang telah menyampaikan 5 program kerja utama yang kemudian di breakdown menjadi program-program penguatan kelembagaan dan penguatan identitas MGI. Yang kalau kita lihat masing-masing dengan 5 program tapi tetap merupakan satu kesatuan, dan juga di awal telah menyampaikan visi, misi, dan tagline, termasuk di bagian akhir menyampaikan program-program unggulan, baik yang fleksib maupun rutin yang sudah berjalan dan akan dilanjutkan ke depan. Selanjutnya, saya ingin memberi kesempatan kepada seluruh anggota, karena pemilihan ketua adalah milik kita bersama sebagai anggota, dan saya yakin banyak aspirasi yang bisa disampaikan kepada calon ketua, sehingga nantinya akan memperkaya dari program-program yang sudah baik yang sudah disampaikan, ataupun ada program-program lain yang dianggap perlu untuk juga diperhatikan oleh kepengurusan ke depannya. Silakan kepada seluruh anggota yang ingin menyampaikan komentar, pertanyaan, masukan, dan lain-lainnya, saya persilakan. Panitia mohon dibantu. Kalau ada yang ingin bertanya mungkin bisa raise hand atau langsung hidupkan mic-nya. Baik, di sini ada juga Mbak Ulan sebagai anggota KPU bersama kami. Kami ada berlima. Jika ada dari anggota yang ingin menyampaikan pertanyaan atau komentar, dipersilakan.
Pak Budi, mungkin pertanyaan aja dari saya sambil menunggu dari anggota yang lain, Pak.
Silakan, Mbak Ulan.
Tadi cukup menarik program-program berikutnya yang ingin saya tanyakan. Kalau nanti MGEI punya award gitu ya untuk setiap anggota ataupun SCMGI, kira-kira apa yang akan dilihat atau dinilai dari individu itu, Pak, gitu. Melihat setiap orang kan bekerja di perusahaan yang berbeda gitu ya, punya standar yang berbeda. Kira-kira MGEI akan memiliki standar yang seperti apa? Terima kasih, Pak.
Baik, terima kasih Mbak Wulan atas pertanyaannya. Satu hal yang mungkin lebih simpel untuk melakukannya adalah misalnya berkaitan dengan paper. Itu sesuatu yang lebih simpel untuk melakukan penilaian begitu ya. Yang kedua, capaian-capaian misalnya dia adalah orang yang menemukan atau meletakkan titik bor discovery holes atau menemukan discovery outcrops. Tentu ini tidak mudah menyiapkan kriterianya dan tidak mudah juga untuk mengklaim siapa yang melakukan itu. Tentu dalam hal nanti pengajuan nama-nama tentu akan tergantung pada organisasi atau institusi di mana mereka berada. Sementara kriteria kita bisa set apakah itu technical discovery misalnya atau economic discovery, sebuah deposit, sesuatu yang sudah jadi begitu. Jadi pada saat ditemukan outcropnya, pada saat itu sudah dibor, bahkan mungkin the best intersection yang itu adalah hasil propose seseorang misalnya. Tentu kita perlu ya masukan rekan, nanti kita biasanya akan kumpulkan semacam tim perumus gitu ya, biasanya ad hoc untuk menentukan kriteria tersebut. Nah, harapan kita memang personal yang kita nilai, karena kalau untuk tim atau untuk perusahaan IAGI sudah melakukan itu, meskipun pada saat itu tahunnya itu sama, kami juga ingin melakukan hal yang sama, namun itu di cover oleh IAGI dan lebih luas cakupannya dari mineral, batu bara, dan juga oil and gas, termasuk geothermal. Saya pikir seperti itu Mbak Ulan, dan ini open for discussion. Jika ada usul, ada sesuatu yang mungkin pernah dilihat atau dilakukan oleh organisasi profesi yang lain, saya pikir itu sangat bisa begitu. Jadi kriteria kita set, perusahaan-perusahaan itu mengajukan orang per orang bisa, atau sekelompok orang atau yang bersangkutan bisa sejauh itu bisa diverifikasi dan bisa dibuktikan sesuai dengan kriteria yang kita inginkan. Begitu, Mbak Ulan.
Oke, baik, makasih ya, Pak.
Oke, baik. Dari yang lainnya mungkin ada lagi yang ingin menyampaikan sesuatu atau memberikan saran masukan, mungkin dari bentuk kegiatan lain yang juga dari organisasi profesi atau yang dirasakan oleh anggota perlu untuk dilakukan. Sepertinya semua sudah cukup jelas dengan program yang ada, dan mungkin yang program yang ada dianggap sudah sangat efektif untuk bisa meningkatkan dan sesuai dengan kebutuhan anggota dan MGEI ke depan. Baik, kalau memang tidak ada lagi yang ingin menyampaikan sesuatu, memberikan tanggapan, masukan, dan yang lainnya.
maaf,
Bapak,
ada yang bertanya, Pak.
Maaf memotong, Pak. Ada yang menanyakan pertanyaan?
Oke, silakan.
Bapak Iwan Setiawan.
Baik, terima kasih atas kesempatannya. Saya hanya ingin mencoba menginformasikan ya ke Pak Budi ya, Pak STJ. Tadi saya dengar salah satu programnya itu adalah ingin membantu adik-adik mahasiswa untuk mendapatkan tempat untuk melakukan tugas akhir, Pak ya. Mungkin ini nanti kita bisa bicarakan lebih lanjut, Pak ya. Cuman informasi sementara yang bisa saya sampaikan bahwa kita di Badan Riset dan Inovasi Nasional itu ada satu program itu namanya hibah mobilisasi SDM riset. Kita sudah berjalan beberapa tahun kemarin, namanya kita itu tesis market. Kita semua mahasiswa yang ingin melakukan tugas akhir, silakan mendaftar secara elektronik lewat website LIPI ya, elektronik layanan sains LIPI ya. Kalau tahun-tahun kemarin, kalau sekarang masih bisa pakai link tersebut, gitu kan. Kita akan menerima banyak mahasiswa dari berbagai ilmu ya, cabang ilmu ya, termasuk geologi ya, geoscience gitu ya. Bisa teman-teman itu nanti mau belajar tentang geologi, mau belajar tentang oceanografi atau limnologi atau tentang laut dalam, mau sumber daya, mau geodinamika atau apapun itu nanti cukup mudah gitu kan, tinggal memilih mengusulkan proposalnya, ditulis dengan baik, dipilih calon pembimbingnya siapa, dan itu nanti akan dibantu pendanaannya gitu. Pendanaan untuk analisisnya sampai selesai. Bahkan nanti bisa juga melakukan magang gitu kan. Artinya ada kemungkinan ada penghasilan di sana ya, pendapatan di sana. Dan kalau memang yang bersangkutan itu cukup bagus dan sangat kompeten gitu kan, punya passion yang bagus di bidang riset, dia bisa dipromosikan untuk mendapatkan beasiswa S2 atau S3 dan seterusnya. Mungkin sementara itu Pak Budi, informasi dari saya. Terima kasih.
Terima kasih banyak Mas Iwan. Wah, ini luar biasa nih Gayung bersambut. Semoga usulan program tadi diterima oleh rekan-rekan Mas Iwan, tapi apapun itu, usaha seperti itu, informasi seperti itu akan sangat berguna bagi kami. Beberapa pengalaman pribadi nih, Mas Iwan, banyak sekali di antara rekan-rekan anggota MG itu yang sudah dalam atau sudah pada posisi bisa mengambil keputusan di perusahaan masing-masing untuk menentukan atau membuat program pengembangan di internal, termasuk penerimaan rekan-rekan mahasiswa untuk melakukan kerja praktek atau tugas akhir, tapi masih sifatnya sporadis itu. Masalah apakah itu karena dengan alma mater yang bersangkutan, atau karena kebetulan kenal, atau bahkan ada yang ke kampus mereka bertanya-tanya, ini kenapa kok tidak ada yang masuk atau tidak ada yang tahu program tersebut. Nah, mungkin apa yang disampaikan oleh Mas Iwan tadi, bagi sebagian universitas case-nya seperti itu. Nah, nanti kita coba untuk bridging gitu, mendiseminasi program tersebut dari LIPI atau dari BRIN, yang semoga itu bisa kita arahkan untuk hal-hal yang berkaitan dengan economic geology dan aplikatif begitu, karena kita ingin rekan-rekan itu melakukan penelitian yang konteksnya adalah applicable pada saat mereka segera setelah lulus terjun di dunia profesi. Terima kasih sekali lagi Mas Iwan. Saya akan langsung follow up itu segera setelah ada approval atau persetujuan bahwa program ini akan menjadi program MGEI kepengurusan setelahnya. Terima kasih, Mas.
Baik, terima kasih Pak Iwan untuk pertanyaannya dan saran yang dimasukkan. Oke, dari panitia mohon konfirmasi karena di monitor saya nggak kelihatan nih kalau ada yang resen seperti yang tadi. Apakah masih ada pertanyaan atau masukan dari anggota?
Ada Pak Joko itu, Pak Jokowi Dayatno.
Silakan Pak Joko.
Terima kasih atas kesempatannya. Bisa suara saya terdengar?
Jelas Pak Joko.
Begini, sekarang ini kita tidak dapat menyalurkan fresh graduate dengan baik. Saya juga kewalahan dengan mantan-mantan anak didik yang mempunyai murid-muridnya mencari job di bidangnya. Nah, ini ada usulan dari saya, kira-kira seberapa jauh MGEI bisa memberikan masukan kepada Depnaker atau badan kepegawaian jumlah mineral jumlah orang-orang geologi ekonomi yang dibutuhkan, sehingga pendidikan yang ada di seluruh fakultas geologi atau di tambang bisa mengarahkan jumlah mahasiswa yang bisa diterima dengan melihat permintaan yang ada di industri. Karena ini menyangkut juga jangan sampai ada sekolah yang membuka karena sedang rame, kemudian mahasiswanya banyak dan overload, sehingga pada waktu mereka mengalami pencarian kerja mengalami kesukaran. Itu saja mungkin masukan saya untuk MGEI. Selamat bekerja Pak Budi, mudah-mudahan kerjasama kita bisa berjalan terus. Selamat sore.
Selamat sore, terima kasih banyak Pak Joko. Sepakat Pak, kami memetakan jumlah tidak hanya jurusan geologi, tapi juga jurusan tambang khususnya itu sangat-sangat banyak. Rekan-rekan kita di Asprodi Tegi juga kita coba untuk tadi dalam salah satu penjabaran program dengan universitas adalah dengan Aspro di Tagi, jadi Asosiasi Program Studi Teknik Geologi, untuk memberikan itu. Memberikan pengertian tentang serapan pasar industri bahan ekstraksi ini sangat tergantung, salah satunya adalah demand di luar. Tidak semata-mata dalam 1-2 tahun itu harga bagus, bisnis ramai, terus kemudian berbondong-bondong membuat jurusan yang terkait. Ini sama juga dengan jumlah mahasiswa yang diterima bahkan oleh universitas-universitas yang sudah cukup lama, yang mestinya paham bahwa penerimaan tidak lagi hanya berdasarkan pada kuota yang dihitung, karena mereka sudah menjadi statusnya sebagai BLU atau yang lebih dari itu, jadi mereka harus menghitungnya, tetapi mestinya diperhitungkan juga seperti tadi disampaikan oleh Pak Joko, bagaimana serapan pasar di luar. Baik Pak, kami catat itu, masukkan dalam usulan program. Nanti bagaimana implementasinya, paling mudah adalah mereka, rekan-rekan dari dalam itu menyampaikan pada saat ada rapat internal manajemen organisasi universitas tersebut. Tapi secara umum kita perlu berikan gambaran bagaimana nature bisnis khususnya berkaitan dengan economic geology, dalam hal ini pertambangan, Pak Joko. Untuk bekerja sama dengan IMA, kami mohon nanti di IEDC, karena IMA saya yakin ada sesuatu yang mirip, tapi kami akan agak lebih spesifik karena ada hal teknis di situ. Nah, saya pikir itu akan jadi hal yang saling menguatkan, begitu harapan kami, Pak Joko. Jadi ada 2 atau 3 event sejenis dalam tahun yang sama oleh organisasi yang berbeda. Saya yakin itu akan saling melengkapi. Matur suwun Pak Joko. Salam untuk bapak-bapak di IMA juga Pak.
Ya, terima kasih. Sebenarnya gini Pak Budi, ya. Saya lama di organisasi Persatuan Insinyur Tambang waktu di Jerman. Jadi kita yang di lapangan ini kan tahu kurang lebihnya lah berapa kebutuhan kita di masa yang tidak terlalu enak ini. Terutama sekarang yang kita perlu persiapkan dengan adanya tekanan daripada global, industri ekstraktif yang kelihatannya hari ini menarik karena komoditasnya mahal, masyarakat berharap bisa mendapatkan kehidupan di industri ekstraktif. Nah ini yang perlu kita pelajari bersama karena ternyata harga bagus, keuntungan tinggi. Kita perhatikan saja ya perusahaan-perusahaan batu bara, perusahaan emas. Rekrutmennya tahun kemarin sekitar tahun ini 3 orang, 2 orang, sedangkan fakultas teknik tambang itu ada 54 sekarang di Indonesia. Dan ini kan menyedihkan kalau nanti adik-adik kita terpaksa mempunyai waktu tunggu yang lama. Zaman saya begitu lulus sudah ditawari jadi apa begitu, tinggal milih. Selama itu masih dalam kurun 10 besar atau ya 15 besar lah. Sekarang ini 5 besar saja agak kerepotan dengan surat yang menyatakan dia cum laude 3,6, 3,59 itu masa penantian panjang. Jadi saya prihatin dengan keadaan itu dan siapa yang punya informasi di perusahaan yang menjadi anggota, katakanlah person-person yang menjadi anggota MGEI, dia bisa mengadakan katakanlah pemaksaan untuk perusahaan, kita butuh orang begitu loh. Karena kita kompeten kan, diakui sebagai orang yang kompeten untuk memaksakan itu. Sedangkan saya di IMA, saya mengusurkan berapa yang berani diserap, dia buka kartu, kita masih bayar utang banyak Pak, nggak bisa bayar orang begitu. Jadi ini antara saya sebagai orang ekonomi tambang, kemudian expert ekonomi geologi mengatakan saya butuh orang Pak, nggak bisa eksplorasi dikerjakan atau keputusan ekonomi dikerjakan oleh saya sendiri sebagai ahli ekonomi geologis. Terima kasih.
Pak Joto, jadi memang masalah disrupsi ini banyak tantangan yang harus kita jawab. Tadi sudah dicatat oleh Pak STJ sebagai salah satu masukan, dan kita akan melihat apakah itu memang bisa diakomodir dalam program kerja ke depannya. Saya kira untuk kesempatan ini, saya sekali lagi berterima kasih kepada seluruh anggota yang sudah tetap meluangkan waktu. Saya melihat yang partisipan tetap bertahan di sini lebih dari 120 orang, dan kita harapkan besok atau di hari terakhir annual meeting ini, kita akan melakukan perlihatan, pemilihan, dan penetapan Ketua MGEI untuk periode berikutnya. Dan sekali lagi, kami dari KPU tetap membuka kepada anggota jika ada saran-saran atau masukan yang ingin disampaikan, yang nanti akan kami teruskan kepada calon Ketua MGEI periode berikutnya, sebelum nantinya akan sebagai usulan untuk dimasukkan dalam program kerja berikutnya. Saya kira untuk kesempatan ini bisa kita cukupkan sekian. Sekali lagi terima kasih kepada panitia yang sudah bersedia memfasilitasi event KPU pada kesempatan ini, dan juga kepada seluruh anggota MGEI yang berkomitmen untuk bersama-sama kita mendengarkan pemaparan dari calon Ketua MGEI periode 2021-2024, yang pemilihan dan penetapannya akan dilakukan pada hari terakhir Annual Convention 2021 ini. Demikian dari saya kembalikan kepada panitia dan kepada Pak STJ sebagai calon ketua. Kami juga mengucapkan terima kasih untuk kerjasama dan pemaparan yang dilakukan pada hari ini.
Baik, terima kasih banyak kepada Bapak Hashari Komarudin selaku Ketua KPU MGEI 2021 dan Bapak STJ Budi Santotso selaku Ketua MGEI atas pemaparannya. Up next, ladies and gentlemen, we will enter the door prize event. We hope that you are still excited, even though today has been an eventful day, and as much as we've all learned valuable lessons, it is quite tiring to sit in front of the computer for the whole day. So, to entertain you all, we've prepared another quiz session for all of our participants. there will be 3 lucky winners who will receive MGEI's merchandise. So are you today's winner? So first, I would like to explain the rules. It is simple. I simply ask the questions, and you may answer the correct questions. All right, could all of our participants please turn on their camera? Okay, is everyone ready? Can I have a thumbs up if everyone is ready? Okay. These 3 questions are quite easy, so I hope that our 3 winners will come ahead with the correct answer. All right, the first question. Who was the first chairman of MGEI? Okay. Can I have a raised hand? Okay, we have our first participant, to Dr. Arifuddin Idrus.
Yes.
Good afternoon, Bapak. Do you have the correct answer?
Of course.
All right, let's hear it.
So the first chairman of the MGI is Dr. Bronto Sutopo.
Are you sure?
I think so, yeah. As I remember.
Okay. To our committee, is it the right answer?
Pak Sukmandaru, ya.
Are you fixed with your answer, sir, or would you like to change it, perhaps?
Sukmandaru Prihatmoko.
Okay, are you sure this time?
Yes, I think so.
Okay, congratulations, that is the right answer. And now our committee will contact you for you to receive your merchandise. Okay, everyone, please give a round of applause for Dr. Arifuddin Idrus. Okay, our second question. Where was the first convention of MGEI held? Do you have a raised hand? Where was the first MGEI convention held? I think we have. Okay, Miss Wulan, do you have the correct answer?
Jakarta 2009, 8, 8 or 9, I think. Jakarta. Oh, sorry, annual convention is in Semarang.
Are you sure?
I think so, yeah.
Okay, we'll let you know. Congratulations, that is the correct answer. The committee will soon contact you to receive the merchandise from MGEI. Okay, everyone, this is the last question. Who will be our last lucky winner? Okay, who is the current Ketua Kombers KCMI IAGI Perhapi? Oh, we already have a hands up from Bapak Irianto Rompo.
Yeah.
Okay, good afternoon, Bapak. Do you have the correct answer?
Yes, of course I have, yeah.
Oh, okay. Very confident. We like that. Okay. Let us hear your answer, sir.
Unfortunately, the Combers is just replacing the chairman. So the chairman now, the last chairman is Pak Adi Mariono, but now the Ketua Combers adalah Pak Luki.
Pak siapa?
Okay.
Pak Luki ya, Pak Luki.
Okay, Bapak Irianto, are you sure with your answer?
Yes, I'm sure, yeah.
All right, congratulations, you've answered the right answer. The committee will now contact you soon for you to receive the MGEI souvenir. Okay, everyone, congratulations to 3 of our winners, but do not be sad. Sorry? We apologize for a minor technical difficulties, but do not be sad if you have not received the MGEI merchandise, because tomorrow we still have another quiz for you to answer. So are you tomorrow's winners? We will see. Okay, everyone, before we leave for today, we would like to take a group photo of all of our participants. So can you all please turn on your cameras? Okay, all right. We will take several photos as usual, as there are several slides. Okay, for the first slide, I will count from 3. 3, 2, 1. Fantastic. All right, can we see the second slide? Okay, 3, 2, 1. Okay, the next slide, please. 3, 2, 1. Okay, and the very last slide. 3, 2, 1. Okay, thank you all, everyone. Now, I would like to remind you of the activities from the MGEI annual event, which consists of 1. Pre-convention event, which are the student research poster contests held on the 26th and the 29th November 2021, where there are 20 participants. The 3 winners will be announced tomorrow, so stay tuned. Next up, we have the workshop where we discuss mineral resource estimation, which was held from the 7th until the 9th December of 2021. 13 participants participated with 10 audiences. And now we are at the main event, where it is conducted from 14th till the 16th December 2021. And after that, we will have the post-convention event, which will be the MGEI field trip of Central until East Java, where the date will be announced soon on MGEI socials. As usual, ladies and gentlemen, this event would not have happened without the support from our sponsors and media partner. Starting from our Superbite sponsors, we have PT Geofix Indonesia, PT Merdeka Copper Gold Tbk, and PT Pedrosi Tbk. Our Gigabyte sponsor, we have PT Antam Tbk. Our Gigabyte sponsors, we have PT Agincourt Resources, PT Aman Mineral Nusa Tenggara, PT J Resources Nusantara, PT Namsumaluban Abadi Sumacorp, PT Reka Buana Penjuru Mineral, and PT Sumbawa Timur Mining. Our Kilobyte sponsors, we have PT Eksplorasi Nusa Jaya, Minerba Indonesia, PT Greenland Resources, Harita Nickel, PT Indodrill Indonesia, PT Nusa Halmahera Minerals, and PT Timah Tbk. Our workshop sponsor, Sequent Limited. Our other sponsors, PT Medco Energy Mining International, and PT Minevesting Resources Indonesia. And of course, our media partner, Dunia Tambang. To our sponsors and media partner, we sincerely thank you in making this event happen. Well, ladies and gentlemen, we have now entered the closing session of today's event. I would like to remind you first that tomorrow will be the 3rd and last day of the 13th MGEI Annual Convention, so please come on time, as the event will start at 8 a.m. Western Jakarta time, while the registration will start from 7:30 a.m. Western Jakarta time. I am Rama Marsha, your Master of Ceremonies. Enjoy the rest of your afternoon, and on behalf of the committee, we thank you. We thank our speakers, moderators, and our participants for your enthusiasms. Good afternoon, everyone, and see you tomorrow. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Terima kasih all. Assalamualaikum Pak Nas.
Waalaikumsalam Pak Nas.
Assalamualaikum Pak Nas. Sehat Pak Nas.
Terima kasih.
Senang sekali bisa melihat Pak Nas.
Ya, terima kasih.
Semoga sehat terus Pak Nas.
Terima kasih.
Besok kita tunggu lagi Pak Nas ya, hari terakhir Pak.
Iya, terima kasih.
We are PT Agincourt Resources, a world-class gold mining company based in Indonesia. We manage the Martabak Gold Mine, located in the South Tapanuli District, North Sumatra. Our vision is to develop a sustainable world-class operation, delivering first quartile performance in the gold industry. We will achieve this by growing our business and optimizing our assets, all of which is built on our strong foundation of sustainable development. We are pursuing exciting growth opportunities through exploration, the Sulfide Development Project, and plant debottlenecking to 6 million tons per annum. We have invested in a successful exploration program to deliver significant growth and value to the business. We have 6 deposits in reserves category and a vast mineral resource which we continue to develop. Our project pipeline includes an impressive portfolio of projects across a range of near-mine and contract of work targets. The focus is on near-mine exploration targets to utilize the existing infrastructure of the Martabak process plant. The Sulfide Development Project presents an opportunity to change the game at Martabak, enabling the processing of refractory ore and upgrading the recovery of precious metals from transitional ore. The project upside could potentially double the life of the mine. Our short-term opportunity is to further enhance asset performance by debottlenecking the process plant from its original design to 6 million tons per annum. We can do this with incremental capital investment and drive efficiency and costs even further. Production at Martabak is operating above design and ahead of plan as we are driven by opportunities for efficiency and asset performance. We are delivering in excess of 350,000 ounces of gold and 2.5 to 3 million ounces of silver per annum, all within first quartile cost comparisons worldwide. The foundation of our business is our belief in sustainable development. We believe that mines should be developed, operated, and closed in a socially and environmentally responsible way. In terms of our local community, we deliver practical outcomes, such as employment and capacity building, where more than 70% of our workforce are local people. And our CSR programs, which focus on health, education, infrastructure, agriculture, and economic development.
Selamat datang di Tambang Batu Hijau, salah satu tambang tembaga dan emas terbesar di Indonesia yang terletak di Kabupaten Sumbawa Barat, Provinsi Nusa Tenggara Barat. PT Aman Mineral Nusa Tenggara mengoperasikan tambang batu hijau sejak tahun 2016 pasca akuisisi dari PT Newmont Nusa Tenggara. Disinilah kami melakukan rangkaian proses untuk menghasilkan mineral yang sangat penting bagi kehidupan manusia. Aman melakukan transformasi dalam berbagai aspek operasional untuk mencapai visi menciptakan warisan terbaik. Strategi operasional Aman adalah untuk meningkatkan copper recovery sebagai upaya konservasi mineral dan mengurangi kandungan mineral pada tailing yang ditempatkan di dasar laut atau deep sea tailing placement. Recovery penambangan juga didukung dengan peningkatan produktivitas peralatan utama seperti shovel elektrik dan juga haul truck.